I'm gonna be studying until I pass away. Any activity around here? Maybe it has to process first. Studying until I pass away. Hell yeah! Hell yeah, that's what I'm gonna be doing today, yeah? Alright, oh yeah, alright, oh yeah, alright. Now, a lot of Dear Diaries. But the main point here, we're supposed to find our tuition. Copyright it. Maybe it has to process first.
Okay, so lactic energy is a kind of measure with the ionic bond strength. So actually, this is some definition. You need to have a giant ionic lattice for the final. So actually, they will getting at a sonic as the final products. Okay, but in order to calculate the energy, we
Oh
are
my
not.
god, I forgot about lattice energy as well.
So
Then what is this?
More exercise because they will have more
Oh, I forgot to close it.
calculation with this kind of.
Which one is the first one? This is 7th of February, 8th of February. So let's watch this one first.
also the electron potential. So let me just show the screen first. Can you see the screen?
Yeah.
Great. So are you still familiar with this picture? That's what we were talking about last section, right?
Yeah, I remember.
Yeah, so it's going to be a quick recap. So this is what we call as a cell, or more specific, it's a electrochemical cells. What happened is that we're actually separating the redox reaction into two half equation, and we physically separate them into two different containers. So like in the middle. So on each separated container, only one redox reaction will happen. It's either reduction or the oxidation. So can you tell me that on this hand side, on this gray solution, we have zinc metal to be oxidized to form the zinc ion. So we have oxidation happening here. Is this part the anion or the cathode part?
This is the anode
Why is anode?
because it's giving away. I mean, it's
giving away electrical current. What has been given away? What's been given out?
the cation.
Not cation. Actually, it's actually electron to be given out. I mean, yes, we also given out the cation, but it's not actually giving out to the circuits. What has been used to define the anode and cathode is that we are giving electron out on the anode side. So it's actually negative part of the whole circuit. And on the cathode side, because it's accepting electron. So if you're trying to do it like a physics question, you would write something like, oh, we have cells, and one part is positive, one part is negative, and that's what we refer to as the anode and the cathode. So we always say the circuits flow from the cathode to the anode, but by this drawing we are referring to the the electricity. However, because we find out electricity a long time before we actually find out electrons, so I mean, after define, we have electricity going from the cathode to the anode, and we determine the side of the circuits, and then people later find out, actually, electricity is caused by the flowing of electron, while electron is carrying a negative charge. So actually, electron is flowing vice versa, but it's too late to change everything. So that's why we have the electron flowing in the vice versa way than the electricity that has been defined. So that's what's happening. Okay, so anode means this is the electrode that is giving out electron, and the cathode is the part to receiving electron. So in this case, can you tell me that we are going to have oxidation happen on which electrode?
Oxidation happens on anode.
Yes, and reduction happen on
the cathode.
Exactly. So you just got to remember anode means negative. It's giving out electron to the outer surface. Great. And then in this section, we're going to define a new term. We don't use it that much. We call it electromotive force, and in abbreviation, it's called EMF. It basically means there is a potential energy to push electron flowing in a specific way. So it says that the cell generates electromotive force, resulting in the movement of electrons. So it's just the force to push electron to move in the way it wants to, and it's always from the anode to the cathode, via the external circuit. So we also call the EMF as the cell potential. This is the term that I personally use most, the cell potential. You must remember that here I refer as the cell potential. It means you need to have a complete cell to have a cell potential, and we use this term. To represent the cell potential. And have you seen this term before?
No.
No. Have you seen this one before?
Yeah, this one I have.
Yeah. Yes, so I mean, do you see this more like theta before?
Yeah.
Yes. What does this theta mean?
I forgot.
It's fine. Theta
Standard conditions.
That's it, like bring up any memory. Standard condition.
Oh.
Standard equation, right? We only call like the H as enthalpy, and delta means that is the enthalpy change or enthalpy difference before and after the reaction, right? And theta means everything happens in the standard condition. 100,000 pascal, and also like 25 degrees, and also everything must be in the standard state. Remember that part? That's all represented by this small theta. If we don't have that, you can measure the entropy change at any situation you want, right? We just standardize everything to make sure that when we're doing the comparison, it's more reasonable. We're not comparing things that happen in different situations that make everything that has more logic in it. So here we do the exactly same thing for the electron potential. We're also going to standardize a lot of conditions to make sure that we are comparing things under exactly the same situation. And why we are doing that? Because you see that there is an electromotive force to push the reaction to happen. I wonder, this is an A2 section, but have you seen this one before? The Gibbs free energy.
I've seen it before, but I didn't learn it.
It's fine. So free Gibbs energy is also a way to measure the reaction will happen or not. So that part also contains a standard condition. And also, you can find out that here when we're trying to describe the electromotive force, that means reaction will happen by itself, right? There are different potential in two different electrodes. The electron will be pushed in one way specifically. So it's also a way to present, one reaction will happen by itself. So those two things, they're actually sort of connected. If you're going to learn chemistry in college level, those two things are interconnected. That's why we always see this kind of theta. And also it's because that cell potential or this kind of volt is also a type of energy, right? Electricity is a type of energy. Entropy is also a type of energy. It's just represented as the chemistry way. So because they are both energy related, so they must be sort of, interchangeable. I'm not going to talk about it more. That's why we always have this standard only when we talk about the energy related topic, because it's related to the temperature, related to the pressure. Those two conditions will change the energy that's in the system. Okay, so we're going to move to the next slide. So EMF, which is the electromotive force of a complete cell, must remember it's complete cell because we want to push electron from one end to the other end. If we only have one flux here, there's no way to measure that because electron will just stay here, nothing will change, right? So it must be measured for the full reaction, for the full cell, and it's measured under standard condition. So you will see this very, very familiar term as you've seen before. 298 K, which is 25 degrees Celsius, or in another term, we actually call it room temperature. In the chemistry, we just assume room temperature, that's 25 degrees. That's what happens in most of the place or in most of the lab. And also the gas must be at this pressure. And what is this specific number means is also the 1 atm. Have you seen this unit before, ATM?
Yeah.
it's atmosphere, just like the pressure you will have when you are at the sea level. So basically, standard condition just means the room condition, the most common condition. And another thing we add specifically here is the concentration of the solution, because as you can see in both of the electrodes, it's a solution. So we need to define a specific concentration. As you can imagine that if we increase the concentration of electrode, it will change the electromotive force, right? The higher the condition, the reaction rate will be higher or lower? Usually, if we have a higher concentration.
Higher reaction
rate, exactly. So in this case, that when we increase the concentration of any electrode, for example, like on the anode side, it will push electron to move even faster because we want a faster reaction. So it will change this voltmeter reading. So we want to set concentration to be 1 mole per decimeter cubed. So that's the condition you must remember. And that's the condition that if you ever go to exam, they ask, oh, can you define the EMF? That's something you must include, just like when you're doing the enthalpy question. Okay, should we pass? So then we want to define slightly more about the electromotive force. So it's actually measured by setting up these electrochemical cells. What happened is that we use a voltmeter and set it in the outer circuits. Then we can measure this electroflow. And here, when we set up cells under the standard condition, and we got this reading, and that's what we define as electromotive force. So the unit of electromotive force will be volt. The unit for the what is it like the electric pressure?
Cells generate an electric motive force measured in volts as electrons flow from the half cell with more negative potential to the half cell with a more positive potential. The magnitude of this voltage depends upon the difference in the tendencies of the two half cells to undergo reduction. No one half cell can be measured in isolation. We need a fixed reference point that acts as a standard for measurement, standard hydrogen electrode at a standard condition. So that's the half cell potential that we get.
We will see that the electron will move from a more negative part to the positive part. Remember these two, negative part and the positive part. So remember these two. Remember this sentence that's written in bold in red, and we will catch that very soon. So another thing is that the magnitude of this voltage depends on the tendency difference of the two electrodes. Just as when we just learned the redox reaction in the first year, they will talk about something like to give out electron, something like to take in electron, right? And what is the term that we define? Some element wants to give out electron, some element wants to receiving electron. Do you remember the term to define the element's ability to take in or give out electron?
reactivity.
Nope, that's something we call electronegativity.
Oh.
Remember that? That's kind of fitting here, right? Yes, reactivity is a better way to describe in this section, but generally, we can also use another term, it's called electronegativity. However, the problem with electronegativity is that it only defines the element, but it does not define the ions, right?
Yeah.
We usually only compare the electronegativity of the element, not the ion. However, in the redox reaction, sometimes we will reduce the ion from one oxidation number to the other, and oxidize from ions to ions without passing the element state. That's why reactivity is a better way to describe here, the reactivity of something, rather than electronegativity. But it's sort of related. If you want to compare element only, we will have a look later on, okay? And then there are just some terms we already know, like no half cells can be measured in isolation because we need a full circuit. One part to give out electron and cathode to receive electron. So just with one half cell, we can't do measurement. And then in order to standardize everything, we set a standard electron and we set the potential of hydrogen electron as 0. So in that case, I'm going to show a picture first. So in this picture, if we try to connect any potential we want to, put a number on, we want to specify with the hydrogen electrode, and we measured its electromotive force, we now can know that what is the difference between the hydrogen and this copper one. Because we set the hydrogen to 0, so the number we measure will be the number of this electrode. How do we set? You see the point? So we're actually still measuring the difference of the other electrode with the hydrogen electrode. However, because we humanly set the electropotential of the hydrogen one as 0, now the difference between the other electrode with the hydrogen, then we set this number to be the electropotential of the other one. Do you get this part? Yeah. Okay, then we will go back. So this is just a way that we can actually put the number to any half cells. Because I just say we can't measure a half cell, so we need to find a way that we only put the number on the half cell. Okay, then we decide to set the second half cell as 0. So the number mathematically it will be the same. So we will set up the standard hydrogen electrode at a standard condition. So the pressure of hydrogen gas is 100 kPa and the temperature is 25 degrees and the concentration is 0.1 mole per decimeter cubed. Why we are using hydrochloric acid here? Any guess?
I don't know. Not sure.
Or why we need to use an acid here? Why we can't use water?
Because they have to be in the ionic form.
Oh, because maybe the ions, because it turns into H plus ion.
Yes, because when we're trying to do reaction with the hydrogen gas, in each half cell there must be a redox reaction happen, right? So on these half cells that we are going to do the redox reaction to change the hydrogen gas into the hydrogen ion. So in the solution we must provide some hydrogen ion because sometimes maybe we are going to do the reduction part. So the hydrogen ion will be reduced back to release hydrogen gas as has a half equation. So we need to have both the reducing part and the oxidizing part in the standard condition. That's why we're using acid here, not the water, because water cannot provide enough hydrogen gas. Have you learned the decay part yet?
Yeah, I have.
Yeah, so you know that if we only have pure water, the Kw it's only 1 × 10⁻⁴. So we have too low concentration. We have a very, very low concentration of the proton. So we must use an acid to provide enough concentration of the proton to ensure that this reaction is actually reversible in each direction. And now we can actually draw this picture, and this is called the cell diagram. We draw the last section, right? So this is the cell diagram for the half equation only, and you must remember that in the standard condition and also in the time that we want to measure the electrical potential, we always put the hydrogen half cell on the left. So this is just like, I can't tell you why, it's just something the scientists who decide this topic, they set it as standard. Just like they decide to use hydrochloric acid, they don't use nitric acid, they don't use sulfuric acid. Just like something people have set there and we have to follow the rule. Okay, so the hydrogen half cell, it's always on the left-hand side. So the order will be, we've written out the electron metal. And metal here we use is always palladium. Again, this is set, don't ask why, we just follow the rule.
Platinum.
So it's palladium. And then we have hydrogen gas on the left and hydrogen ions on the right. Because when we draw out the half cell, it's always that electron flows from the left to the right. That's why we put hydrogen gas on the left and the proton on the right. Because you can see this equation here, when the hydrogen gas is changed to the proton, it's losing to electron. So the electron is actually flowing this way. So if we continue to draw the other part of the cells, that electron will flow from left-hand side to the right-hand side, from the anode to the cathode. This is just the way that I always draw the cell diagram. Happy with that?
Platinum.
Yeah.
Okay.
Yeah.
And then we determine that the electrical potential of this half cell is 0. Now it's the set point. Then we compare the rest of the electron with these hydrogen standard half cells. And then we know that this reaction is reversible. It's either the oxidation of hydrogen or the reduction of proton. You can see that the reduction of proton is the forward reaction and the oxidation of hydrogen is the backwards reaction, because I need to draw a half equation here, doesn't matter. But it also depends on the electrical potential of the other half cell. Because if we go back, you can see just one side has a higher potential to give out electron, and one side has a lower potential to give out electron, so instead it will receive electron. So we don't know the potential of the other half cell that we're going to measure. So then what happened on the hydrogen half cell? We don't know, we can't tell. It really depends on the reactivity of the other things. If it has a stronger reducing ability, then it will reduce the proton. If it's a stronger oxidizing reagent, then it will oxidize the hydrogen. So it really depends. Cool. And that's something we'll talk about. So then the other things. If it has a stronger reducing ability, then it will reduce the proton. If it's a stronger oxidizing reagent, then it will oxidize the hydrogen. So it really depends. Cool. And that's something we'll talk about. So then if I try to draw this standard hydrogen half cell in the middle, what will happen is that if we have let's say if we have a stronger reducing agent, which means you want to give out electron, right?
Yeah.
Then the electron will flow this way. And because even though I said yes, we usually put the hydrogen standard cells on the left-hand side. So in the more standard way, we need to put it here. And we still have this stronger reducing agent. Then the electron will flow in the backward ways. Do you agree?
Yeah.
And in this case, what will happen is that on this voltmeter, we will have a negative value. Because now electron is flowing vice versa. Do you agree? I think the last time, did you take any physics? Sorry, I need to ask
I'm
again.
the reducing agent.
Yes or no?
Yes.
So you know that when we use this voltmeter, you need to make sure that the connection is in the right direction. Otherwise, it gives you some random number, right? So here, because when we are trying to measure the electrical potential of the up of the other electrode. We always put this one, the standard hydrogen electrode, on the left. And in order to make sure that we know how we're going to connect the voltmeter. However, it's inevitable that sometimes the other half cells has a stronger reducing ability.
Yes, redox. I'm gonna study until I pass away. I'm revisiting old footage from February 7th. So many topics to go through, man.
In that case, it's inevitable that we will have some negative value. We will have some negative value, and as what I said before that, the value that we measured by the standard setup will be the value of that measured half cells. So now we know that if it's a stronger reducing half cells, it will have a positive or negative value.
Negative.
A negative.
Yeah, it will have a negative value by definition, how we measure the cell's potential. And then you can see obviously that electron will flow from the negative part to the positive part. And if we purely stronger reducing half cells to the right, it's kind of like changing the Y connection between the measured half cells and the hydrogen half cells. Then this value will be positive. However, it's not matching with our definition, how we are going to measure the electron potential of the half cells. Even though it's the correct positive value, that's the right way to connect the voltmeter. And this is not right according to our definition. Do you see the difference?
Yes.
It's kind of confusing. Do you want me to repeat again?
Actually, yeah, maybe try. Yeah, explain again.
Yes, I will try again. Stronger reducing agent. Stronger reducing agent. So according to the definition, we want to measure the cell
It's
potential
not
of
that
the electrode.
complicated,
We always
bro.
put the hydrogen half cell on the left, right? It must be on the right, and that determines the way how we're going to connect the voltmeter. Do you agree with this part?
Yeah.
We're just
And
connecting the
go here.
voltmeter with the
Go to
hydrogen cell on the
measure
left.
the standard electric potential of electrode. We must put whatever the second half cell on the right. However, sometimes that this half cell will have a stronger reducing reactivity, so it will give out electron in a backward way. Because usually for the voltmeter, we want electron to flow from the left to the right? In this definition, that's how we connect it. However, due to that second half cell, the measured half cell has a stronger reducing ability. So electron now is actually flowing backwards. It's flowing backwards. That's what we call backwards. Happy with that?
Yeah.
So now we have a negative reading on the voltmeter. Do you agree?
Yes.
Yes.
So now we have a negative reading. So now we can come up with a conclusion that if we have a negative cell potential, negative voltmeter reading, if we have a negative value, that means this half cells has a stronger reducing ability.
Okay, I got that.
Do you agree? For this conclusion?
Yeah.
Yes. However, when you are in the physics section, always that for a voltmeter, you should have a positive reading, right?
Yeah.
So because if it's negative reading, that means you set up the whole setting wrong. So in an ideal world, you should actually put your stronger reagent to the right, so to the left. So this is actually correct setting.
But in chemistry, you
voltmeter.
put it on the right.
You agree?
Yeah.
To get positive reading. But this is not correct according to our definition, how to measure electrode potential of electrode. Do you agree?
Yeah.
Yeah. Because if we try to set up everything we want to measure according to the right setup of the voltmeter, then for some electrode, we'll put it on the left, some electrode, we'll put it on the right-hand side of the hydrogen. So the value of every electrode will be positive, then we cannot compare, right? That's why we have to set the rule. Okay, we set the hydrogen as center, and we always put the hydrogen on the left. No matter the voltmeter is giving us positive or negative value, it doesn't matter. Because what we want essentially is to measure whether this is a stronger reducing agent than the hydrogen or is a less stronger reducing agent than the hydrogen. And it's told by the positive or the negative reading come out from the voltmeter.
Yeah.
Any clear? Is it getting clearer?
Yeah, but what determines like what do you put in the empty cell?
It depends on the question. They may ask you, oh, I want to measure the electrical potential of, let's just say, a zinc half cell. So I put zinc and zinc sulfide in it. So it will be given by the question. Whatever you want to measure or whatever you've been asked to measure, you put it here.
Okay.
Yes. So, and I have to say that this kind of setup to have this negative value from the voltmeter reading, it's only allowed to measure the half cell's electrical potential. If they ask you to set up a cells, you must make sure that stronger reducing agent putting on the left and the stronger oxidizing agent putting on the right. So for this kind of setup that you have hydrogen cells always on the left, it's only for measure the electrical potential of electrode. And for anything else, that this part is how to set up normal electrochemical cells reducing on the left. So you must tell very clearly that what is question asking you. They want to measure the half cell potential or they want you to set up a normal electrochemical cells.
Okay.
Do you see the difference?
Yeah.
Okay, great. So we can pass. Now here is just how we're going to measure the electrical potential of whatever given. So we need to prepare everything under standard condition. Again, standard condition. So something new here is that all solution must be 1.0 mole decimeter cubic. Gas must be at this pressure. All the substance must be pure and same room temperature. That's it. And also they ask specifically is that if the half cell or the half equation does not have any metal in it, you must use palladium as the electrode. That's required. Any question on this slide?
No.
So here is just actually an example that at what time that we don't really have a metal in this redox reaction. For example, that you can actually oxidize iron 2+ to iron 3+ without passing through the iron metal stage because redox reaction can just happen within ions. So metal is not always required. So in that situation, you can use a palladium. Why they ask it specifically? Because in some cases or in some actual results that's in real life, they use carbon graphene as electrode. Still remember that graphene is also conducting electricity because it has that special
graphene or graphite. Alright, Ethan, good luck on your run. Hopefully you run more than 3K this time.
So graphene is also conducting electricity. So graphene or graphite or carbon is also an option for the electrode, but that's not a standardized electrode. So that's what you have to remember. So it can just be part of the multiple choices. Okay. So here, now we have a standard setup in order to measure the electrical potential of this copper half cell. As you can see here that I've given you this reaction equation, total reaction equation, and I also give you the cell's potential of this measurement. So it means that this voltmeter is telling you that E cells equals to plus 0.34 volt. Now you need to try to draw me or tell me how to draw a cell diagram. It's just a recap how to draw that one.
I think H2 gas on the very left.
Yes, I think we want to have a look at what we had before for this half cell. What else is written on the very left?
Oh, the platinum.
Platinum, because here is quite special. Because what we're talking about in the last section that we probably talk about this half cell zinc and copper, right? Because zinc is already metal, so we don't need extra electrode. So it's only zinc, then two zinc ions, then double bridge. However, in this hydrogen half cell, the reduced version of the hydrogen is hydrogen gas, but it cannot be used as the electrode. So we have to put the palladium on the very left first. So it will be palladium. Then bracket hydrogen gas. And what is the next?
Hydrogen ion.
And what you need to put in between hydrogen gas and hydrogen ion?
Oh, the phase boundary,
Yes.
Yeah.
Just one dash. You shouldn't call dash, it's like horizontal. I don't know how to say it. But yes, hydrogen ion, we also call it proton. So what else you need to add to this proton?
That is aqueous.
Yes, you need to put the physical state of everything because you must remember that physical state will affect the energy. So this is the same rule when you're trying to write down anything that's representing the entropy, right? Is it gas state or is it like liquid state? It will affect the energy.
Yeah.
So now we finish the left half cell. And what happened to the right hand side?
There's the bridge.
Yeah, double line. That's bridge.
And then Cu2 plus Aq.
C2 plus copper ion, Cu plus. Then aqueous. And what else?
And phase boundary, and then just Cu solid.
Yeah, do we need to add any electrode for the copper half cell?
No.
Yeah, because copper is also involved in this redox. So it's a metal, it can conduct electricity, so we don't need extra electrode. So this is a conventional cell diagram. And as I emphasized before, for this measurement, we must put the hydrogen half cell on the left. That's always. And then what would be the next step is that we can just copy and paste of this cell electricities of the electrical potential measurement of this equation to this cell diagram because it's essentially exactly the same thing, right?
Yeah.
And then we need to
what?
know the next step is that we can just copy and paste of this cell electricities of the electrical potential measurement of this equation to this cell diagram because it's essentially exactly the same thing, right?
Yeah.
And then we need to know that what is this positive 0.02 means? It means that it's the electron potential difference between two half cells. Because that's what we measured here, right? It's actually the difference. Do you agree?
Yeah.
Yeah, the difference
Electrons are flowing from the left to
two
right.
electrons. And also, don't forget that we have defined that the electron potential of the hydrogen standard half cell is 0. Do you agree?
Yeah.
We always define that electron always move from the more negative to the more positive part. And also you can see that here we have a positive reading. So which means electron flow in the forward way according to its voltmeter. So you can just take the reading directly as the cell potential of the half cell you're trying to measure. So the electron potential of this copper 2+ and the copper half cell is 0.34. It's 0.34 because if you compare 0 and the positive 0.34, you can see that 0 is definitely the more negative value. It's matching what we were trying to describe before, right?
Yeah.
So the good thing is that if we standardize that, we set this hydrogen half cell is 0, and we always put it on the left, that the reading that's come out from the meter is the reading, or it's actually the cell potential of this half cell. Just take the reading. It's the actual electron potential of the measured half cells. You don't need to do any conversion. Happy with that?
Yeah.
Okay, now we can see that, copper here has a positive reading. What does it mean? Or actually, what this reading is trying to tell you, it's actually this reading is a comparison with the hydrogen gas, right?
Yeah.
So what does this mean tell you anything about copper?
It's an oxidizing agent.
It's more reactive.
What kind of reactivity? It can be more oxidizing active and it can be more reducing active. So when you say the reactivity, you really want to emphasize what type of reactivity you're talking about.
It's more easily
Electronegativity.
It's more easily reduced.
Because
it's more easily reduced, so it's a stronger oxidizing agent.
accepting the electron.
From where?
It's
From
taking
the
the
hydrogen.
because it's taking the electrons from hydrogen.
Yes, it's taking electron from the hydrogen. Who is taking electron from the hydrogen?
The Cu2
Copper.
plus.
Yes, Cu2 plus is taking electron from the hydrogen to form the copper metal. So the copper metal or the copper ion, this combination, it's taking electron from hydrogen, taking electron, giving out electron. What does it indicate? What kind of reactivity is indicating?
It's reduced.
Stronger.
Yes, it's about reducing and
oxidizing
oxidizing,
agent.
right?
Yeah.
Yes, so copper is taking electron. Let's write it down. Copper 2 plus is taking electron from hydrogen
Stronger
2.
oxidizing
Copper 2 plus
agent.
is reduced. So what it's telling you? Who is stronger at what?
Cu2 plus is stronger at reduction.
It's reduced.
Oh,
So it's
stronger at oxidizing.
Yes, or we can actually say copper is less active than hydrogen than in reducing, right?
Oh yeah.
Because it's taking electron. Remember that copper is reduced means it's oxidizing agent. Hydrogen is oxidized means it's the reducing agent. It's vice versa. Hydrogen is reducing copper. Copper is reduced by hydrogen. So hydrogen is the indeed reducing agent in this reaction. So we can conclude that if we have a positive value, that half cell is less reduced. How should I say? It's less reduced active than the hydrogen. It's less reducing active. Reducing agent. You need to remember that. You can remember it in terms of reducing, you can remember in terms of oxidation. You've got to remember if you have a larger or larger than 0 electron potential value, what does it mean? That's very important, okay?
Yeah.
This is the most confusing part throughout the whole topic, but I'm to get this one right, otherwise your answer to any question will be totally wrong. So higher the E value, less stronger reducing agent, and lower the E value, that means it's a stronger reducing agent. What does that tell you? That if we have two half cells putting together, like this and this, we always put the more negative half cell on the left, right?
Yeah.
Always more negative. According to our definition, that in this cell diagram, we always want electron to flow in this direction, right? So you want to put a half cell that with more electron, which means more negative E electron potential on the left. How do we start? It's holding more electron. Okay, that means holding less electron. This is not like a real meaning of it, but it's the way that I try to tell students, trying to remember it correctly, which part should be put in which. And negative electron potential means it's holding more electron, means it's stronger at reducing, right? Stronger reducing agent. So that's how I asked them to remember it correctly. Negative electron potential means more electron. So you put it on the left hand side of the cells and it's a stronger reducing agent. So that's all you have to remember. Okay. So here, if we measure the electron potential of the half cell by constructing a full cells with the standard hydrogen half cell, we can write down that half equation of the right hand side. Here is the half equation of the right hand side. And you always remember that you need to put the oxidized form on the left and the reduced form on the right, because that's the right hand side of the cell. So that's the correct order, because ideally that on the right hand side is always receiving electron, right? And then you put your measurement from the voltmeter as the standard electron potential, and this value will just be the electron potential of this measured half cell. Happy with that?
Yeah.
Okay, so now here's just a quick summary of what we talked before. This simple is really hard to cut in, so it's actually that theta value. It just tells you everything is done under the standard division. Great. So, however, actually that's
Half cells under the conditions listed previously are known as standard half cells. When the standard hydrogen electrode is connected to another standard half cell, the EMF generated is known as the standard electrode potential of that half cell. E means electrode potential and theta means carried out at standard conditions.
theta value. It just tells you everything is done under the standard division. Great. So, however, it's not that easy to measure to setting up this gas half cell because this hydrogen half cell containing gas and hydrogen gas is actually explosible. If you have it in the lab and if you accidentally have some flame in the air, it can be easily ignited. So it's actually quite dangerous. We want to use that. Therefore, we use another half cell as a reference electrode because essentially that we want to know the difference between two half cells, right? So if we're trying to draw this kind of line here, we know at 0 is this hydrogen and hydrogen ion half cells, and we measure our stuff and we know the difference. For example, this one is 0.5 and this one is like positive 0.7. So we know the electric potential of anything we want to measure. However, if we use another reference, for example, these half cells, and we define that we set it to the left. Always we set our standard of reference to the left. So you can see that it's written down in a reduced way or an oxidizing way. It must be taking or giving out electron.
Giving.
If we set the half cell, it must be giving out electron or taking in electron.
Giving.
Yes, it must be given out. It must be given out electron. So we will write down this half equation like that. And why we have this first half equation? Because here that we have is mercury, Hg is the mercury in the oxidized form and in the reduced form. So if we try to write down a cell potential of a half cell, this is the order we must follow, right? Because when we're trying to measure the electric potential of a half cell, we always put it on the right and the reference on the left. So this is the right order to write down the electric potential of any given cell, as I described here. To write the electron potential. Okay. Then, however, because now this time we want to set this mercury half cell as the reference, now we have to change it to the left hand side. So we need to vice versa. We need to put everything. We need to turn everything vice versa. Are you happy with this part?
Yeah.
As a reference, it's just like some confusing rules that people have said you really need to follow. Now, if we set this reference to the left and write down according to the format is required, then we can find out that on this axis, now this reference point is here. Now this reference point is here, right? So if we're still trying to measure out the electric potential of half cell number 1 here, what we'll have in the voltmeter will be the difference between those two half cells, right? It will be the difference between those two half cells. Do you agree?
Yeah.
And then the reading value will be what? What is the difference between those two?
Zero
What will be the difference between our half cell number 1 and our new reference electrode? What will be the electric
0.5
potential difference
minus
between those two?
0.17.
Negative.
Negative what? What is the exact value?
0.27.
23.
Oh.
Right, 0.23. So this negative 0.23 will be the value we read from the voltmeter. But since we already know that the left hand side, our reference electrode is on electrode potential is minus 0.23. So we just add up those numbers. We can still get to, and we can still know the difference between our measured number 1 electrode and the standard hydrogen one, right? So it's just like by measuring the difference between the reference and the measured one, since we know the difference between the reference and the standard hydrogen one, we add those two things up. We can still get the difference between our measured one and the hydrogen, which is actually our electric potential. Does that make sense?
Yeah.
It's known. So it's just kind of like an explanation, but I'm going to show you some questions here for you to understand. So for the question A and B, can you quickly answer?
Okay.
What are the half equations and standard electrode potentials of the right-hand electrode in each of the following cells? The standard electrode potential is literally just this. Literally just this.
H2.
And it should be a quick one.
H2G becomes 2H plus 2E minus.
It's actually asking you the half equation of the right hand side.
Yeah. SN2 plus 2E minus becomes SNS.
Because it's negative, that means it's giving electrons. So it's actually Sn becomes Sn2 plus plus E 2E minus.
Okay, so what is the electric potential of this half cell? First thing is that, are you sure this is the right half equation to write down when we try to write down the electric potential? Can you just double check that?
No.
Giving away electrons, so it has to be opposite.
No, it's actually accepting electrons. When you're trying to write down the standard electric potential, it's always accepting electron. It must be the right hand part of the cells, which indeed it is, right?
Oh, the half equation is actually accepting. Okay.
Yeah.
So it's the right way. It's the right way. Giving out electron is always the reference part. Giving out electron is the reference part, and right hand part is to accepting electron, which is the measure part. Okay. So what is the electric potential of this half cell?
It's exactly
Still
negative 1
negative?
point.
It's negative 0.14.
Yes. So it should be a really quick one because we've already set our measured half cell on the right. Is that correct?
Yeah.
Which means, and we set the left hand side as our standard hydrogen one, the electrical potential of the measured half cell is just the reading. It's the reading directly. So just take this number out directly. Okay. How about the second one?
2Br minus plus 2E minus equals Br2. Electric potential plus
2 plus
1.07.
2E minus becomes 2Br minus.
To bromide. And how about electric potential of this half cell, or this half equation?
It's just plus 1.07.
Exactly. Okay, let's have a look at the question number C. That is the tricky one. So let's try to write down the half equation first, okay?
Oh, Hg.
Plus CR3 plus 3E minus becomes CR.
Backwards. Okay, how about the electric potential of this half cell? Minus 1.01.
Minus 1.01.
Because there's only 2 electrons on the left.
Don't worry about electron loads again. We are not balancing here. You don't need to balance it. That's okay.
Oh, then I think it's only negative 1.1.
Are we having a standard electron on the left hand side?
Oh,
no.
This is hard to imagine. So, against hydrogen, they're both negative. Cr is more negative than Hg. So, he's gonna get... Cr is more negative than Hg. So it's gonna be still negative. Negative... Negative 1.01 minus negative 0.27.
No, we are having a non-standard. We're having a reference one here, right?
Yeah.
So remember, it's negative one, sorry. So it's negative one here, right?
Oh, yeah.
So, and what we remember is that electron will move from the what? How it's gonna move? From left hand side to the right hand side, right? How electron is gonna move is always going this direction, right? Do you agree? When we're trying to draw this cell diagram, electron always will push it to move here. It's voltmeter reading, and we have this minus 1.01 voltmeter here, which means we have a starting point here is already not positive. Sorry, negative 0.27, and electron will move here to here, and we have this negative reading because we're having a negative reading, so electron is moving in the backward way. Do you agree? Do you agree?
I agree.
Yeah. So now we know that on the right hand side, our measured half cell, it will have a more negative value or more positive value. More positive or more negative electron potential?
More positive.
No, more negative. You must remember that electron always flow from the negative side to the positive side because negative electron potential means it's holding more electron. So electron will move from somewhere has more electron to less electron because it's minus 1.01 more negative than the minus 0.027. So here it will be, if you just add those two values together,
Oh my god,
it goes
that's
to the real
so
confusing. Because this is minus 1.01, it means the difference between those two half cells, right? And we know that is minus means that our measured half cell is more negative than the reference. So we need to do minus 0.27 minus 1.01 to have the real electric potential of this half cell. Do you see the point?
It's so
So
confusing.
the real answer is that minus 1.28. Have you that? Do you see the point?
It's a bit hard to
It's a
understand.
bit hard to get it. Yes. So let's try again. So first we need to know that this reading tells us the difference. Right? This
Yeah.
reading is actually reflecting the difference between two electrons. Have you that?
Yeah.
And this negative reading tells you that electron flows to the right hand side to the left hand side. That's electron flowing way.
Yeah, yeah.
And so the right hand, our measured electron is more negative. Do you agree with that?
Yes.
But how much? This electron is more negative than our reference one? It's the reading come out from the voltmeter.
Yeah.
Which means you need to do the calculation. Say, I know this unknown. Let's just say, okay, doing it in a mathematical way. We say this unknown half cell has a value of x. Have you that?
Okay, yeah, yeah.
And also it's more negative. Let me find another way because it's more negative. It has a minus here. So x equals to I don't want to use x. Let's use the name. Okay, a and b. That's easier. So b is more negative than a. Have you that? By how much? B equals to a minus this voltmeter reading because b is 1.01 more negative than a. B is this value more negative than a. Have you that?
Yes.
So we now know the electric potential of a is minus 27, 0.27, and you do the math here that minus by 1.01, then you have the value of our electric potential. You see the point?
Yeah.
Have you with that?
Yeah.
Okay. So eventually is that I would delete this one. It's very confusing. So if we are using this mercury one as reference electrode, how to calculate the electrode potential? Just voltmeter reading minus 0.27. That is the electric potential measured. You simply add those two values together.
Okay.
Value of voltmeter reading plus the value of electric potential because electric potential of our reference is 0, so it's like minus 0.20. So it's a bit confusing because you always have like this positive and negative, but essentially you're just adding two values together. But both values are negative, so you're doing the minus, not the plus. Have you said?
Yeah.
Okay. Okay. Should we pass? Okay. There is another test question. Can you give it a try?
Standard electric potential for Cu2 plus electrode is that for the cell. The standard cell EMF equals to 0.47. What is the standard electrode for lead? For the cell, this electrons flow from the right to left for negative 0.47. .34 0.34 Cu2 plus 0.34 electrons flow from, oh my god, I have to draw this out. think it is 0.13. Yeah, it makes sense. But I have to go through it one more time.
And the electric potential of the cells.
I think it's just 0.34 minus 0.47.
Yes, you got this part. Exactly. I'm not going to do math because
Yeah.
essentially is that this negative value tells you that electron is flowing from the lead part. PB is actually lead. Is flowing from the lead part to the copper part, and then which means the lead part is more negative, right? Is more negative than the electric potential of the copper part. And by how much is more negative? It's 0.47 more negative.
现在是
So you do the math, the value of your copper electric potential 0.34 minus by 0.47. So it's kind of similar than what we have done before. We set something to the left. Left part is always the reference, right? So here is not actually what we should use as a reference, but that's what has been set by the question. And we have a reading from the voltmeter. So if you add the number of reference plus the reading from the voltmeter, and that will be your electric potential of your method. Happy with that?
Yeah.
So here we can actually come up with a conclusion that electric potential of left plus voltmeter reading will equal to the electric potential of the right. Do you agree?
Yes, that's correct.
Isn't that some kind of conclusion we just come up from the previous few questions?
Yeah.
Yeah. However, there's a big tricky thing. For any given electric potential, are we going to write it down as the right-hand side form or the left-hand side form? Actually, the right-hand side of the half-side form, right? It's required and it's given and it's compulsory for any electric potential you want to report. It's always oxidized formed to the reduced form. Happy with that?
Yeah.
Which means electron potential of the left hand, which is set, which means that the electric potential of any cells you put on the left will be the vice versa value of the electric potential of the real cells that has been given. Do you agree? Do you see what I'm saying? It's very confusing, I know. So any data that you obtain from the data booklet, any electric potential, it will be given out in this form. Always oxidized form on the right, on the left, and the reduced form on the left. And this whole expression means that this electron has been put on the right hand side as a half cell, because that's how we come up the value from comparing to the hydrogen standard electrode. Because I said before, if we have a standard hydrogen electrode, we always put on the left, right? So any electron potential coming out from this measurement, we take the value and whether it's positive or negative. So the expression of the half cell will be the oxidized form to receiving electron to the reduced form. Happy with that?
Yeah.
Which means if we want to switch any half cell to the left, you need to vice versa electric potential as well. You see that part? Set to left. If we want to set this half cell to the left, the value will be the negative of the real electric potential. Do you agree? Do you see this part? Because you are trying to reverse the reaction direction. If you set the half cell to the right, it's oxidized form to reduced form. And if you want to set it to the left, it will become reduced form to the oxidized form. So the electric potential will be vice versa as well. Happy with that?
Yeah.
Okay, if we get this part, now we can know that for this equation that we come up with, we can further change it to, because this electron potential of the left-hand cell will equal to the electron potential, will equal to the minus value of the electron potential of the cell. Do you agree? Because for any value that's given in the data booklet, it's always given in the form if we set the cell to the right hand side. So if you want to put that one on the right to get on the left to get its electron potential, that will be the negative value of the given value. Do you agree?
Yeah.
Happy with that?
Yeah.
Okay. And then if we have the voltmeter reading, if we have so for this part we can go to here. Then we can go to here that when we have two half cells, you just do the math like that. So for any the value that has been given by the data booklet, it's always the oxidized form to the reduced form, and you have two half cell electric potential here. Because we want it to be constructed to a full redox equation, we will need to change the more negative one to its reverse form, because electron always flow from the more negative part to the more positive part, right? So the half cell with
Just
the
add them
more negative
together.
value,
Add the
that will be
magnitudes
the reduced
together.
agent or the oxidizing agent. Is the reducing agent or the positive free agent. If we have a more negative electric potential.
So
0.34 minus negative 0.76.
Electron flows from the negative electric potential to the positive electric potential, right?
Yeah.
And then what does it mean? This part is given out electron, right? This half cell is given out electron, is that correct?
it's giving out electron.
Means it's reducing agent or oxidizing agent.
Giving out it means it's reducing agent.
Yes, it's reducing agent. It's reducing the other part. It's the reducing agent. If this zinc and zinc 2 plus is the reducing agent, means itself is oxidized or reduced.
Oxidized.
It's oxidized during the reaction, so we need to reverse the equation because
Zinc
the
is
equation written down here is
oxidized.
the reducing half part, right?
Copper is reduced.
Do you agree?
Wait, why reverse? Wait.
Why reverse? Because now we decide that for zinc and zinc 2 plus, this half cells needs to be the reducing agent. That's our agreement, right? Which means zinc or zinc 2 plus is something that to be oxidized here. It's something to be oxidized means it's accepting electron or losing electron.
Losing electron.
Yes, it's losing electron, but look at the equation that I have written down. Is it giving out electron?
It's giving.
Is it losing electron? No, it's accepting electron. Zinc 2 plus plus 2 electron is the process that is accepting electron.
Oh.
So it has to be reversed to the form that is actually losing electron to the copper. So copper can accepting electron, right?
Yeah.
So in any, just again that I need to find a way that you can get in any half cell of half equation we've written down to represent the electric potential, it's always present the way of accepting electron. However, in a redox reaction, we need to find someone to give an electron, right? And who is going to give an electron out? The one with more negative electro potential, it will be the one to lose electron. So for those part, it's losing electron. We are not writing the half equation correct. That's why we need to reverse it.
Yeah.
And then if you're adding those two equations together, it gives you full equation. So it's the same here that when you're adding up the half equation, you can add up the cell potentials to the cell potential of the whole equation. So this adding up cell potentials is a bit like when you're writing down two equations that both have enthalpy. If you're adding those two enthalpy up, it will be exactly the same. It's like Hess's law. Do you still remember that?
Yeah, I do.
So it's a bit similar. But the only thing you need to remember is that you need to make sure which half equation you want to flip. And as you are flipping the reaction, you also need to flipping the electric potential. With that?
Yeah.
Okay, so that's what we can come up from the previous reaction. So any more questions?
No.
No? Okay. So here are the questions. So here are some, so here is just a screenshot that something you will probably see from your data booklet is that we will have our metal with a more negative electrical potential, because we all know that metal is good at reducing, right? Metal is good at reducing, do you agree? And the hydrogen is good at reducing, but metal is even better. So you can see a lot of more reactive metal that has smaller value than 0, as what I said before. Smaller the value means stronger reducing. If it's smaller than 0, that means it's stronger reducing agent than the hydrogen. Remember that. If it's some value that's higher than the hydrogen, that means they are less reactive in reducing than the hydrogen. And everything that you will find out here with this electron potential, it's always written down in the oxidizing form. For example, magnesium 2 plus 2 electron to form magnesium, electron potential minus 2.37. Remember that this value actually means the electron potential of the oxidized half equation. So all the value here, this electron potential of the half cell is the oxidizing half cell. Just please remember that, because sometimes in the exam that they will give you an electric potential, but you need to create the half equation yourself. Then it comes to the problem that you need to make sure that it's always gaining electron to represent electron potential. That's something that has been emphasized throughout the whole section. Can we stop?
Yeah.
It's just like, think about that when we're talking about the standard enthalpy. We're always saying, oh, something is combust, something is standard combustion enthalpy, something is combustion. We define the direction of the reaction, right? Because if you flip the reaction, the value will be completely over. So it's the same here. For all the electric potential, we define as the oxidizing half part, as the oxidizing half equation. Happy with that? So if you think the process is a bit confusing, don't worry, just remember the conclusion, because for what I've said before, it's just helping you understand the topic. Why it's always oxidizing half part? Because we always set our standard electrode, the hydrogen one, on the left, and on the left hand side, we always say, oh, it's the reducing half cells, right? Because we always set our measured half cell on the right, so the equation that we're trying to represent is always the oxidizing part. Sorry, it's always the reducing part, my fault. I'm writing right, but I'm saying it's not oxidizing half cell, it's the reducing half equation. It's gaining electron.
What?
Why we always written down the expression of any cell's potential in this specific way in accepting electron way? Because in the measurement, we always set our measured cell on the right, and we meant to that the right hand side to accepting electron. Have we said?
Yeah.
Okay, that's why. Okay, so here is just basically something that you must remember. It is how to express the half equation for any hidden electron potential. So this is actually what we see from the data booklet. It's always written down as the half reaction, half equation. And you can see that something with a stronger oxidizing ability, fluorine, with something with a super large electron activity, fluorine, chlorine, oxygen, it has a positive value. It has a positive electron potential. And something like metal, it has a stronger reducing ability. So it's always having a negative value. However, we always keep the left hand side of the reaction to be accepting electron. Gosh, my eye is getting so hot, so it's doing weird things. Accepting electron, which means the oxidized form. And on the right hand side, it's always the reduced form. Okay, and the lower the electron potential indicates is which? Stronger reducing oxidizing agent.
Lower value, stronger reducing agent.
And if it's higher electron potential, it means it's a stronger reducing or oxidizing agent.
Oxidizing.
Exactly, that's all you got to remember, because that's what we'll be asking in the exam question. Previously, I was trying to explain it, but if you think it's confusing, that's just go directly to the conclusion. So that will be part of it. So tomorrow we will go through more questions that has been the real exam question. So I think that's it for today. Okay.
Yeah.
Okay, I will see you tomorrow.
Yeah, see you. Thank you. Thank you.
Don't worry about it.
三只。
Damn, time flies, bro. So I think I know everything in here, so I'll just move on to the next one. So I streamed for a total of 4 hours by now. 4 hours of studying. After this, I'm gonna do redox questions. I'm gonna do redox 2, all of these. And then hopefully go back to acid-base equilibria. And then transition metals. I think I'll do transition metals first. And yeah, pick up the pieces. Alright. And we'll come back to physics later. Studying until I pass the frick out. I pass away. Study until I pass away. Yay!
Before we start this section, we are going to do a quick recap about what we've talked about yesterday. So yesterday, I think I tell you a few rules that we have to follow when we're trying to do any questions about electrochemical, right? So
Yeah.
the first, I'm going to ask you that if we're trying to measure, okay, if we're trying to measure the electric potential of a half cell, what should we do and what is the rule that we have to follow?
We use the hydrogen half cell.
Yes, and we have the hydrogen half cell. What is the major components of a hydrogen-based half cells? Standard half cells, actually.
There's the hydrogen gas, the HCl, and the platinum.
Yeah, HCl. HCl, and what is the concentration of our hydrochloric acid?
1 mole per dm cube.
Brilliant. And where we should put it? Where we should put this half cell? On the left-hand side of the voltmeter or the right-hand side?
Left hand.
Yes, it's always here on the left-hand side. So in this case, if we put a voltmeter in the middle, we're going to put our target or measured half cell here. So what should we do with the value that comes out from the voltmeter? What does that mean?
It means that
Standard
the electrons are flowing
half
from
cell
left to right.
potential.
If it's
Yes,
positive.
yes, if it's positive, means electrons flow from our hydrogen center half cell to our target one. And what should we do with this value? Because our intention is to measure the electric potential of a half cell, right? We're not going to measure the difference between the two half cells because essentially that if we have a voltmeter in between two half cells, what is measured by voltmeter is the volt difference or electric potential difference between two half cells, right? It's always really, in the reality, is measuring the difference. But what we want here is the electron of the half cell. How should we do that? What kind of thing we need to do to have the value of the electric potential of the half cell?
Not sure.
Yes, we don't measure. We have the value here. Let's just say it's X. Oops. We have the value already, and we measure it. Measure has been done, and we got value like X. So what is the value? What is the electric potential of this target half cell or target electrode?
It is whatever
It's the same.
number is displayed.
Yes, exactly the same. It's just the X because we are trying to measure the difference between our hydrogen one and the target one, right? Because we already know that the electric potential of a standard hydrogen half cell is 0. Then the difference will be 0, and we want to know the difference between the hydrogen and the target one. So it will be exactly as what we've written from the voltmeter. So we don't need anything. What is the value that's coming out from the voltmeter? Take it, keep the unit, keep the minus or positive the same. That's what we have to do. Okay.
Yeah.
And from that, we also know that in the last session we also used a reference half cell. Do you still remember that?
The silver and chloride.
Yes, the silver chloride. Is it silver?
I think so.
No, I think it's the mercury one. Mercury Hg. Right?
Oh yeah.
Because is it because in Chinese mercury is frustrating, so you think it's the silver?
I forgot why I thought it's silver.
No, it's the mercury one. It's the mercury one. And if we set the mercury half cell here as a reference on the left hand side, and we know that electric potential of this one, I think it's some 0.27. Let me check, is it positive or minus? It's the
What were we talking about?
0.27. Okay, and then we also connect everything as what we had before, and here is our measured one. And let's just say if we have a reading from our voltmeter and that it's -1, I'm just randomly coming up with a number. If it's -1, so what is the target? What is the electric potential of our target half cell, the measured one?
Then it's 0.27 minus 1.
0.27 minus 1, exactly. Because the equation that we know is that electric potential of the left plus the value from the voltmeter will equals to the electric potential of the right hand one. That's the equation we come up yesterday, right?
Yeah.
So we just literally adding those two numbers up. And now I am going to, based on this question, we will start going to the yesterday. So I'm going to share the screen. Can you see the screen? we will start here. So as you can see, we will use this equation always. And if we try, and you can find out that the equation we just written. So now I'm going to do a small conversion that actually the electric potential of the cells here is the voltmeter reading, because the voltmeter reading is measuring out the electric potential of the whole cell, which is actually the difference between two electrodes. Happy with that?
Yeah.
So from the equation we just wrote, it can be converted to that electric potential of left plus electric potential of the cells would equal to electric potential of the right. So now we come up with the most important equation in this section. We've already know that, right, from the last section. So you can just remember it in any sense you want. You can remember it in the way that we written in the class, or you can remember the way that minus left-hand electrode plus positive right-hand electrode, or vice versa. It doesn't matter.
Yeah.
But what you have to remember is that this minus means you need to minus the electric potential of the left-hand electrode, no matter this electric potential is positive or negative. If the electric potential of our left-hand side electrode is minus, if it's a negative value, which means you need to do minus something. So you cannot be like, oh, I have a negative electrode on the left-hand side already, then you ignore this minus. You cannot. It's minus the value of the left-hand side electrode. Okay? So that is one of the most important equations we are going to know. And after that, we are going to see this equation again, because this is a very important way we are going to calculate the electric potential of the whole cells, which means we need to kind of sum up the electric potential of left-hand electrode and the right-hand electrode, right? Now, in this equation we explained last time, the method we're doing that is that we need to find out the more negative electrode, and we decided that the more negative electrode is the stronger reducing agent, and we want to let it lose electron. Happy with that?
Yeah.
Which means for all the given half cell electrodes, it will be given in the way of receiving electron, which is not what we want to what chemistry happen on this electrode. So we need to reverse the equation, make it to lose electron instead. Happy with that?
Yeah. Got it.
That's kind of confusing, but hopefully you got it. Because in a redox equation, we need to have one half equation to accepting electron and the half equation to losing electron. So it's a full redox. We can't have both half cells to lose electron. To receive electron. In this case, because we've reversed this zinc related half cell or half equation, we also need to reverse the electric potential of this zinc half cell to this value. So this is something like you've done in the entropy sometimes, because you want to use the Haas's law. However, the equation we given is a reverse version. You need to reverse reaction equation yourself, right? And at the same time, that the entropy value you need to do the reverse as well. Have you done that one in the entropy calculation?
Yeah, I forgot.
You forgot. Okay, never mind. Then we start here. That if we reverse any equation, so just remember that if we decide to reverse the direction of any equation, anything that's related to the energy or electron needs to be reversed. So anything that's related to this value needs to be related to this equation needs to be reversed. And then we're just adding up those two equations, and we're adding up those two values. That gives you the electric potential of the total cell. However, how does this one relate to the equation I just showed you? In this equation, we want to minus out the electric potential of our left-hand electrode, right? So that's what has been written here. We want a minus of our left-hand side electrode. Think about it. For the electric potential with a more negative value or more positive value, we are going to put it on the left-hand side. The half electrode we are going to put on the left-hand side. Is it going to be the one with more positive electric potential or more negative electric potential?
And more negative?
Yeah, more negative. And if we go back to the equation here, you can see our zinc one is the more negative one, right? So we decided, this is a reducing agent, and we're going to put it on the left of our half cell. So if we're going to use that equation, electrode potential equals to minus left-hand side. That's minus 0.76 and plus 0.34. And that was exactly the same value, because here at which that we are doing the minus calculation is this one. We reverse everything. That means we are minusing this electric potential out rather than adding that. Happy with that? Because we've got the minus here. So in any sense, you can do you can try to construct this kind of calculation and try to calculate the electric potential of the cells, or we can just use this equation. Cool. So for this equation, now it becomes a bit problematic. You see that in those two half equations, the electron losing and gaining number is not exactly the same, right?
Yeah.
What should we do with this one? We still use exactly the same equation, minus electric potential of the left plus electric potential of the right. In here, we don't need to consider the stoichiometry. Do you still remember this term? What does that mean? What is stoichiometry?
The number of moles.
The number of moles that is involved in this reaction. So stoichiometry is ignored in electric potential calculation. That's the most important thing. We don't need to do this like times 2 times 3 calculation, because it's an electric potential. That means how far away or how quickly this electron wants to lose or wants to be gained. It has nothing to do with this reaction happening twice or third time. It always wants to go in this tendency. So you need to do this. You don't need to do this times 2 times 3. At what time we need to do this times 2 times 3? When we do the energy calculation. Let me just bring an example. So if we have this equation, that will give you the standard combustion energy of carbon, right? So it will be the standard combustion energy of the carbon. However, when we're trying to do this enthalpy calculation, what is the unit of enthalpy?
Kilojoules.
Kilojoules. Anything else? Per mole. In all the standard enthalpy calculation, the unit is always per mole, which means it's highly related to the equation. This equation happens 1 mole, and the standard enthalpy is the energy that it gives out, because its combustion is nothing after something. So it's energy that it gives out. So if we are going to double the reaction, because here is per mole, That means for this newly written equation, we change the geometry. We want this reaction to happen 2 times before, 3 times more than what it happened before. Energy is, however, for the definition of standard combustion enthalpy, it's kilojoule per mole, but we want to know the enthalpy that's given by this equation. So everything happened twice, right? So it will be doubled because there is a per mole here. However, in our electric potential calculation, there's no such a per mole things. So it has nothing to do with the geometry. So it's all presented by the unit. Have you started?
Yeah.
Yep. So that is a major difference you need to distinguish. Well, that's not for A2. So here, all you got to remember is that we're just going to use this equation. We're going to use this equation just minus 2. Just the minus the electric potential of the left hand.
Until they pass away.
One and positive for the right hand one. So it's a bit doing weird thing. Hold on, I'm going to stop the screen. I'm going to restart. I think I'm going to restart my software. It should work a lot better. Yes. So it's going to be positive 0.75 minus 0.4, and now it's 0.35 volt. And that's the answer. So we can now find out that minus 0.4.
I need to draw this out. Okay.
And now it's 0.35 volt. And that's the answer. So we can now find out that for most of the electric potential that we calculated, it's always a positive value. Do you notice that?
Yeah.
So that's a key rule we have to follow. For a spontaneous reaction, electric potential of that redox or of that electrochemical cells is always positive. Just remember this part. Do you still remember what does spontaneous mean?
Itself.
Self what?
It happens by itself.
It happens by itself, yes, without any actual condition. So if you want to construct a normal, a proper redox reaction, you need to make sure that electron potential is always positive. And that's why we need to convert the more negative value to its reverse way to ensure that actually all electron potential will be positive. So if in any case that in your calculation you end up with a negative electron potential, check it twice. Check it twice is not correct. Okay, unless that we are trying to construct an electrode that is trying to measure something that's on the lab. That's the only time that we will see a negative, we will see a negative electron potential of the whole cells. Other than that, it should not happen. Okay, so that's one key thing you must remember in our section. So that's it for all the electrochemical calculation. So what you want is that you always want a positive electropotential and do not multiply the electron by the factor. What is the factor? The stoichiometry. So you just do the math, the electropotential minus the other one, and that's it. So here we go. So let's try another equation. Can you calculate the electropotential of this one? What would be the electropotential of this one? Just the first question.
Understand what the fuck is going on. Calculate the cell potential, which is the bigger one minus the smaller one, because no, 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 no. I know.
you still with me?
Looking. I think it's when they are added together.
Adding together, we never do the adding. Check out the equation. It's always 1 minus the other.
Okay.
So which one is the minus?
2.85.
1 minus 0.56.
Yes. 4114. For 1 minus 0.56, because remember that when for this half equation, for those two half equation, it's always in the reducing form, right? It's always receiving electron, but we cannot have two half equation in the same redox to both receiving electron.
Yeah.
Which means we need to pick up the first one, the one with a smaller or more negative or like smaller, essentially smaller electric potential, and turn that one into the reverse reaction, because we need to add this half equation to give an electron, right? And now the electric potential is minus 0.56, minus 0.56. Then it's the time you actually add two things together. So just in an easy way, always remember that if the electric potential has been given, it's always one thing minus the other. The larger number minus the smaller number. In this case, it ensures us to always have a positive value, right? Here is the larger value, larger electric potential, and it minus out the smaller value. In this case, in doing this equation, our electric potential is always larger than 0. Can we see that?
Yeah.
So it's not adding up, it's always minus. The only situation that you can add up the electric potential is that you have the properly presented half equation of both redox. So one part is receiving electron and the other part is giving electron. Great. So try another one.
Write the equation for the overall reaction to represent the cell with the cell diagram. Determine the voltaic cell, the E. The cell potential. Cell potential is 1.6 minus 9. Write the equation.
The bigger one minus the smaller one.
Yes, bigger one minus smaller one. No point, no. Right? And that's it. That's it. So here it will be another slightly fancier question they will ask you. They will give you a reaction. They will give you a reaction and then ask you whether it will occur spontaneously or not, which means you need to determine whether the electrical potential of this one is larger than 0 or less than 0. Happy with that?
Wait, so
A reaction. They will give you a reaction and then ask you whether it will occur spontaneously or not, which means you need to determine whether the electrical potential of this one is larger than 0 or less than 0. Happy with that?
Okay.
wait, so if it's larger than 0, then it happens.
Then it happens, yes, spontaneously.
Okay.
Because I wouldn't say it happens or not, because for some non-spontaneous reaction, it can still happen, but with help. So spontaneously is important. It doesn't means a reaction doesn't happen spontaneously, it doesn't mean it cannot happen.
Okay.
So I'm going to copy and paste this to Nico one. And also and the value is. So what would be the way that you determine this reaction is going to
Nickel's on the left. Right minus left, right? One point minus one.
happen or not?
So not spontaneous because not spontaneous.
There are many ways you can choose about this question, but I will give you a chance to do it first.
So I switch the nickel around and then get 0.26. And then I add them together and it is a negative value, so it won't happen spontaneously.
Brilliant, brilliant. Yes. So if we switch the nickel one, because according to the given for equation, nickel one has to be switched. And nickel 2 plus from potential minus 0.26. So if we add this up, now this value we don't need to calculate. It's definitely smaller than 0, so it's non-spontaneous. Right, that's it. So what does it indicate is that, so there's another way we can explain this question. So if we look at those two equations, we can tell the manganate has a smaller value, smaller electric potential, right?
Yeah.
So what does a smaller electric potential mean? Is it a stronger reducing agent or a stronger oxidizing agent? What does a smaller electric potential mean?
It's a weaker reducing agent.
Yes, a stronger reducing agent.
Oh.
Yes, that's correct. Which means we want the manganate to give our electron. However, in this case, manganate is actually reduced, right? It's actually receiving electron. It's kind of like this equation is against the natural property of this two metal. Manganate is a stronger reducing agent than the nickel, so the manganate want to reduce nickel. Do you agree with me for this part?
Yeah.
However, in this given equation, nickel is actually wanted to reduce manganate, but nickel is not strong enough to reduce manganate because manganate is stronger than nickel. So this is not going to work. So here is another way you can determine whether it's a spontaneous reaction or not without calculation. Just by the definition, you can tell.
Yeah.
That's the two way we can do this equation. So that will be the end of this part for now. And there's another thing we're going to cover today. It's a new way that we're going to balance the equation using the half equation. What happened here? So we look to. Hold on, I'm going to stop sharing. Why it's not allowing me to open? Apply to electrical potential.
Half an hour more of studying.
And electron activity means ability of an item to attract formed pair of electron. So for the electron activity, can you explain how it will change across the periodic table? Like, what is the trend within the periodic table in terms of electron activity?
Stronger electron activity across the period because it has more proton.
Who has more proton? And from which train you're talking about? Like across the group, across the period?
The period.
Okay, across the period. So we're going to talk about this line, right?
Yeah.
So what is the trend of it within the period? Getting higher from left to right or getting smaller from left to right?
Higher.
Yes. So here, this part is like larger, smaller, and why?
Because it has the same electron shell, but it has more proton to pull the electron shell.
Yes, to not only pull the electron shells, but also to attract someone else's electron. Because when we're talking about electron shell, you're meaning that that's the item's own electrons, right?
Oh yeah.
But here is we're not only attracting our own electron, but also attracting someone else's electron. But yes, that's correct. Same electron shell number, but increasing proton number within the nucleus to attract electrons. So from the left to the right, we're having larger and larger electron activity. And there's another trend across the group. Can you explain it? What is the trend first?
It's stronger electronegativity for less shells of
Yes.
the group.
Yeah, which means it's getting larger as we're going up to the group because we're having less shells. So it's easier for the nucleus to pull someone else's electron. Happy with that?
Yeah.
Great. So next thing we're going to quickly revise is the oxidation number. What is the oxidation number?
The charge.
The charge, and then the charge of what?
The charge of the ion.
Not exactly. Yes, it's charge of ion, but also it's charge of the element within the molecule. Because you can think about that, maybe in the ionic things, we have sodium. Let's just bring up the most common example, sodium chloride. Sodium is always +1. Chloride is always -1. Can you explain why?
Because the sodium gives one electron to the chlorine.
Yes, so because kind of like if we compare these ions with its original item, it's adding more electron or it's losing electrons, so there is a charge. That's what we call oxidation number. However, in a molecule, for example, like hydrogen chloride, there is also a term called oxidation number. Hydrogen is always +1, right? Chlorine in most of the cases is always -1. Do you remember why?
Because of the shells.
Not shells, due to the electron activity.
Oh yeah.
Right? Because chlorine in this case has a stronger electron activity, so it will pull this bond pair towards itself. So now it's actually kind of getting one more electron. Why it's not two? Because for this paired electron, each of item donates one electron to form this bond pair. And then when the chlorine is pulling this whole pair, it's actually pulling one electron back and also pulling one electron from hydrogen back. So it's actually only getting one more electron, not two. Do you get this explanation?
Yeah.
Right? And also vice versa for the hydrogen, because chlorine is pulling this electron to itself. Hydrogen is losing its electron that it donates to this bond pair. So hydrogen is +1 and chlorine is -1. So in this case, for a molecule, it still has an oxidation number. And for the easiest way is that we just remember the results. For example, halogen, here is my typo. Halogen is always -1 because it locates on the right-hand side. It locates on the right-hand side of the periodic table. That's the area that always have a larger electron activity. So halogen, which is the group 7 element, it's always -1 in most of the situation. And oxygen is always -2, right? Main group metal is always plus its group number. And the hydrogen is always +1. So here I'm just saying the most common electron activity, most common oxidation number you will see within the molecule. This just sounds like a familiar number to you, right?
Yeah.
So do you remember these things? Why those are important? Because we can use those known oxidation number to deduce the other element that's within the molecule. Because some of the elements that stay in the middle, not very right, but not very left, they have a variable oxidation number. So we are going to do a quick calculation. So here in the carbon dioxide, can you tell me the oxidation number of each? Element.
Oxygen is -2, so the carbon is +4.
Exactly, carbon is +4. How about the next one? It's methane. CH4 is methane. You've learned it in the first year organic chemistry.
-4.
I think +1 for hydrogen and -4 for carbon.
Exactly. Do you see the difference? It's the same carbon, but one's +4 and one's -4. So for those things that I didn't mention before,
-3 + 1.
don't make your judgment that quickly because the oxidation number can vary. It can vary according to who it's
+4
playing with. Because essentially here is that carbon has a smaller electron activity towards the oxygen, so its electron is pulling by the oxygen, so it's plus. However, carbon instead has a better electron activity compared to the hydrogen, so it's actually pulling electron from the hydrogen, so it's minus. That's why I say those middle parts of the periodic table element, they have variable oxidation number. So you either remember this or remember those essential elements who doesn't have like variable oxidation number, so we won't make a mistake. Okay. So for the ammonia, and this nitrogen dioxide, can you quickly deduce the oxidation number of each element?
Hydrogen is +1, nitrogen is -3.
Yep. How about the other one?
nitrogen plus 4, oxygen minus 2.
Exactly. So the carbon and the nitrogen, those are two things that has a really wide variable of oxygen number. So here oxygen have +4, and oxygen maximum can reach +4. Sorry, carbon maximum can reach +4, and minus it can reach like at the minimum it can reach -4. So you can see it has a good range of its oxidation number. For anything in between, it can happen to the carbon. For the nitrogen, it's the same. It's -3 to +5. So that's the range for those two elements. However, one thing that I'm going to say that even though for the oxygen and fluorine I say it's usually minus. It's like fluorine is definitely minus because fluorine is the one with the highest oxidation number. It pulls electron from everything. No one can steal electron from fluorine, right? So fluorine is always minus. So if we bring out an extreme example that we have fluorine pair up or forming a compound with oxygen, fluorine is always minus, and in this case, oxygen is forced to be a positive value. And that is the only situation in your life you probably see oxygen with a positive electron activity. It's the only thing that in my life to see oxygen with a positive electron activity. Other than that, it's always negative. That was that. And however, for those other halogen, it's usually -1. It's usually -1, but that will be some other cases. For example, chlorine can form compound with oxygen. In this case, it's plus, right? Chlorine can also form something with the fluorine. Now it's also positive, right?
Yeah.
So I just want to let you know that for this compound, they can be positive value, but it's just that in most of cases, when you are trying to put those items around the molecule rather than as a center molecule, they will be -1. Okay? But just like, and every time when you see a strange molecule you haven't seen before, do calculate the oxidation number by yourself rather than just write it down. Okay? And also for the oxygen, we will see a -1 situation. Have you seen this molecule before?
Yeah.
What is the name of it?
Hydrogen peroxide.
Brilliant. Hydrogen peroxide. So once you ever see peroxide this term, that tells you that oxygen here is -1. And
Okay.
it's not just -1, it's actually forming two oxygen together forming an ion. It's not one oxygen -1. That's not correct. We don't have ion like that. It's always two together. So that's why it's not simplified to HO. Because in these molecules, is to hydrogen and to oxygen. We can actually do a quick explanation with this one. Here is the structure of hydrogen peroxide. So we are going to think about the charge by consider each single bond. For this bonding here, oxygen is delta minus, hydrogen is delta plus, right?
Yeah.
Which means hydrogen loses one proton, oxygen is getting one, right? And we're doing the same to the bond on the left side. However, if we're comparing to the water molecule, those two bonds plus one minus one minus one, those two bonds are connecting, those two polar bonds are connecting to exactly the same oxygen. So same oxygen is pulling two electrons from those two hydrogen together. Happy with that? That's why here oxygen is 2 minus. However, in our hydrogen peroxide molecule, the middle bonding is an OO bonding. Oxygen, they share the same electron activity. So the electrons stay in the middle. No one is stealing one from each other and no one is giving out electron. That's why oxygen now has an oxidation state of 1 minus. Happy with that? And that's why I'm saying for the peroxide, it has to be two oxygen together because you must have this oxygen-oxygen bond. Otherwise, you won't end up with this -1 charge. Okay, so that's something you must remember and take it carefully. Peroxide means O2 minus, O2, 2 minus. It must be formed as a whole ion. So occasionally in the redox equation, you'll probably see this one, sodium peroxide. And they will ask you, please write down the peroxide ion. So it's sodium plus O2, 2 minus, and sodium plus. Sodium ion is also sodium plus 1, but peroxide ion is this. How is that?
Yeah.
Okay, that's some like extreme example you will see with the oxygen -1 the most. I will show you something quite interesting, but I don't think I've never seen it in the exam question. It's a species called superoxide. So we have this structure here. So you can see like the oxygen in the middle. You can see that oxygen in the middle. Those two oxygen highlighted in yellow, it has a charge of 0, right? Because it's connecting to oxygen only. And for the oxygen that I highlighted in red, it stays in the end, which means it has a connection to a hydrogen, so you can have a +1, -1 charge. And for this ion, we call it superoxide. And for this ion, you end up with a charge 4 oxygen. Together, the charge is 2 minus. So if you're trying to even out this charge to each single oxygen, you end up with a negative 0.5. So this is something never really shown in the exam question, but it's an interesting case that you can drop the oxygen number by just drawing out the structure and just make a judgment with each single polar bond, and you end up with an answer. Okay.
Okay.
Yep. So and here I'm going to ignore these two. So now while I'm oxidation number, because we're here I'm going to ignore these two. So now while I'm oxidation number, because we are going to use that to balance our redox equation. So here is a super simple one. So can you try to write down or trying to speak out the half equation for me?
zinc solid becomes zinc 2 plus plus 2e minus.
Yep.
And then copper 2 plus aqueous plus 2e minus becomes copper solid.
Yeah, and here is a zinc aqueous. So this is a half equation. So the first thing you need to know is that if I give you a full equation, you need to know how to break it down. That's the easy part. However, vice versa, we can also use those two half equations and we add those two things up together and it will form a full equation. However, the key thing is here that you need to make sure that electron gaining and electron losing in those two half equations should be the same. Because in a chemistry reaction, we are not creating new items, we are not creating new, electrons. It's kind of just like we're transferring electron.
Yeah.
Transferring electron. So very funny, I actually saw a sentence online in Chinese. They say 化学才是真正的电子经济 electron means 电子 So it's like 电子经济就是一般你打游戏嘛，对不对？就打什么撸啊撸啊、王者之类的。然后这些东西他们叫做电子经济，就是 video games。但是呢，其实做化学才是真正的 playing around with electrons. Electrons moving around. That's the key for all chemistry reaction. It's just an interesting term I saw online. Okay, let's go back to this slide. So here now I give you two quite complicated half equation. So how we are going to put them together to make a full equation is that we need to ensure that electron gaining and losing is the same, because we are not going to release a free electron to the system because it's in super high energy, so dangerous. So we need to make sure that this part is the reduction part. How should I say it? It's actually the oxidation part, because it's the reduction part. It's trying to oxidize somebody else and it's reduced. So I'll turn it as the oxidation half cell. Sorry, reduction half equation. So it's actually receiving electron, but for 1 mole of this equation to happen, it will receive 5 mole of electron.
Yeah.
And for this reducing half part, this reagent is going to reduce it, so it's actually oxidized. For this oxidizing half equation, is actually giving out electron. It's giving out electron, but for 1 mole of this half equation to happen, it only gives out 2 moles of electron. So what can we do to make sure that electron gaining and losing is the same?
Times 2
Times 2 on the top, times 5 on the bottom.
Exactly.
Yep.
And after you do this, 5 electron. After you do this, and all you have to do is adding those two fixed half equation together, and you will have a full equation. So I'm going to write this one down. And another thing you need to do is that you will find out some of the ion can be cancelled out in this equation because it's present in both sides of the equation. Is there any ion so far now you can cancel out in both sides?
The 10 hydrogen ion can cancel on both sides. So,
Yes. So we only have 6 left on the left side now.
Yeah.
Anything else? No, that's
No.
it. So now is what we have as a full equation. So that's it. So in a more complicated, no, that's
No.
it. So now is what we have as a full equation. So that's it. So in a more complicated version is that the question will only tell you what happened within the reaction, what has been oxidized and what has been reduced. However, without telling you the full half equation, and they will tell you the condition is in acidic solution or basic solution or maybe neutral, which is not promising. In this case, we need to write out the half equation by ourselves. Okay, so I will show you what we should do. So first, let's just read the question. It tells you that this nitrite is converted to the NO and the copper is oxidized to the copper ion. So that's all we know from the half equation, right? From the question. So we're going to write it down that nitrite, it forms NO and copper forms copper ion. However, the problem is that for the first one, it's not a balanced equation. You'll find out there are too many oxygen on the left hand side and too less oxygen on the right hand side. Any guess what we can do?
electron on the right.
No, it's not about electron. It's about the number of oxygen. Electron is something else. We haven't had it yet. Because
Add-
if you
is
see
it
the
water?
number of nitrogen, yes, it's water. Water is the ultimate solution because they tell you that reaction is done within the acidic solution, which means we can actually start adding some extra proton on the left hand side. In this case, proton will form water to use up those additional oxygen. So you can see that we have 2 more oxygen on the left hand side for now, right? We have 2 more oxygen because on the nitrite we have 3 oxygen, on the nitrogen oxide we have 1, so it's 2 more oxygen. Happy with that?
Yeah.
2 oxygen more. So which means we need to form 2 water in order to use those 2 extra oxygen. Do you agree?
Yeah.
Do you agree?
I agree.
Yeah. In this case, then we need 4 proton in total. And the last thing is that we are trying to finish up the whole equation just by adding how much electron is getting or losing. Can you tell me that on which side we should put the electron and how many?
On the left side,
On the
3 electron.
Okay,
Yeah.
3 electron which side? I
On the
missed that part. On the left. 3 electron on the left. Brilliant. So now the last thing we need to do is to check whether this reaction is fully balanced. So there are a few things we need to check. The first thing is the element. What do you mean by element? We have the same number of items on both left and the right. 1 nitrogen, and we have 3 oxygen, and we have 4 hydrogen. So that's element check. And the second is charge check. What do I mean by charge check? Is that we add all the charge on the left hand side and on the right hand side to make sure it's the same. So on the left hand side is like 3 minus, another minus, so that's 4 minus, and for plus, that means it's 0 or neutral on the left hand side, right? And also on the right hand side, it's just all the neutral molecules, so it's also neutral. So this equation has passed element check and charge check. That means it's fully balanced. Happy with that?
Yeah.
So every time when you construct this type of equation, you need to make sure everything has balance, including the element and the charge. Both are important. Great. And now we're going to construct the second one. This one is the easy part, right? Copper 2 plus and 2 electron. Because it's only involving copper, so it's just copper and electron. And the last thing is to do is to adding those equations together, but one is having 3 electrons, one is having 2 electrons. What should we do?
Times 2.
Electron. Happy?
Yeah.
Here is the solution, and you can construct how you can construct a full redox equation just from a few sentences in the question. Happy with that?
Yeah.
Okay, once you get very, very like familiar or very, expertise, you can actually do these things all together, but I wouldn't recommend. I highly recommend people trying to break it down into 2 half equations, then adding up together. Great, so here is the solution. I'm going to skip that part. So also that in some of the cases, they will ask you to fill in the geometry of an unknown equation. So the key to do this is still using that electron losing end should be exactly the same. So then we need to spot out the item that is having a redox reaction. So obviously the iron 2 plus is oxidized to iron 3 plus, losing 1 electron. Happy?
Yeah.
And also for this chlorate, what is the charge of this chlorine here? What is the charge of chlorine item in the chlorate?
+5.
Yes, it's +5. So what we would call this one is called chlorate, because chlorine here is charge 5. So we're going to return the charge of the chlorine in the bracket afterwards. You've seen this kind of representation before, right?
Yeah.
So it's a +5. So from this +5, then to here is -1. How many electrons it's having or it's losing?
Gaining 6 electron.
Yeah, it's gaining 6 electrons. So in order to make sure that the electron losing game is the same,
So 6
so
iron.
for every 6 iron, we pair up with 1 chloride. Happy with that? Because this electron losing process into times 6. And then we can be confident that for chloride and chlorate,
1,
and it's 1. And then all we have to do is just to take care of these 3 oxygen, 3
3
and 6. Let's say
H2O,
that's the order that we're trying to balance and,
6
render
H2
redox equation.
Yep.
Happy with that?
Oh, man. Tomorrow I'm gonna studying until North Korea. No. Let me think. Studying until China fights America or something like that. Studying until Russia takes over Ukraine. Studying until World War III outbreak. Okay, I'm gonna take a break. Play it, man.
Chris, I think you guys should start first. I'm still at my grandma's place. You guys should start talking about it first. I will join around 9:30 to 10. But I'll probably still be at my grandma's place. But do not wait for me. I swear, don't wait for me. You're gonna regret it.
What about the positive charge on the H plus?
What about what?
Positive charge on H plus.
Positive charge of H plus. What do you mean by that?
Because you balance the electron transfer of the other two, but then
Because hydrogen plus is always plus in starting material, the proton and the product, so it doesn't receive any electron. Because in the water, the charge of hydrogen is still +1.
Okay.
In a redox reaction, we only pay attention. Not only like we need to notice that something has been oxidized, something has been reduced, and usually I would say in the A level, we have one thing that has been oxidized, we have one thing that has been reduced. It barely happens that there are two things oxidized in the equation. We don't deal with that kind of question. So if I find out, oh, iron is oxidized, chloride is reduced, and that's me done. Hydrogen is not touched here, so you don't need to worry about it. Great. And also we can also do a quick charge check. Here is plus 12 and -1 +6. So altogether is +17. Happy with that?
Yeah.
And here is 3 times 6, that's 18, -1, that's also 17. So it's a fully balanced equation. Just always as a final step, if you have time in exam, do the charge check. That's important. Okay?
Okay.
Great. So now here is a commonly seen oxidizing agent and commonly seen reducing agent, because when you've been given a question, there are something that's commonly seen. You need to know their nature. It's usually being reduced, it's usually being oxidized. So we need to know the behavior of certain compound or certain molecules. So first of all, not surprising, oxygen, chlorine, bromine, it's always the oxidizing agent because they have a high electron activity. It's always pulling electron, right? Agree with that? So what will happen is that oxygen is receiving electron to form O2 minus. It's just like a half equation. I really shouldn't have written like that because like O2 minus is not a proper ion. But I'm just trying to emphasize that it's always getting electron and it's always going to the charge of 2 minus. So this is not like a super good representation. And for the chlorine or bromine, it's also receiving 2 electron to form chlorine minus or bromine minus. Agree with that? So here is the general half equation you'll see for those elements or for those molecules. Any question?
No.
This one could just be a molecule of iron. Okay, and the next thing you will know is hydrogen peroxide. It's also a good oxidizing agent. Why? Because here, remember the charge of peroxide, the charge of oxygen in the peroxide is always -1. However, we all know that for the oxygen, -2 is the stable state, right? -2 is the stable state. So it always wants to reach -2. In this case, it's getting electron, right? Because from -1 charge to -2 charge, it needs 1 extra electron. Agree with that?
Yeah.
Any question? And then we have hydrogen 2 plus. However, do you think it's like a good representation of the redox reaction? As I said before, O2 minus is not something always present. We have a problem here. So what does those two things together can make? You
Water?
have yes, exactly, water. However, is it the right ratio of oxygen ion and hydrogen ion to form water? 2
No.
versus 2. No, which means we are missing 2 hydrogen, right?
Oh, yeah.
In this case, if we just adding 2 extra proton to the left hand side, we can actually form the stable product. to water, and here is the usual redox half equation for hydrogen peroxide. It's performing in some acidic condition. 2 proton plus hydrogen peroxide, we end up with 2 water. How is that? Here is just I want you to be familiar with those half equation. Any more question? No? Okay, we are going to see the next one. Manganate 7 ion. What's that? That should be something you've seen before.
O4 minus.
Yes, magnesium and O4 minus. So just a quick question. Do you still remember like at which chapter or which topic you've seen this stuff?
You think the titration?
Apart from titration? Apart from titration? Somewhere else?
Is it redox 1?
Redox 1, what else? I'm keeping challenging you, what else? Something not inorganic.
No, I
Something
forgot.
not is inorganic chemistry, the oxidation of double bond. The alkene oxidation. Any idea?
I think I forgot.
It's double bond, and if you have manganate, you form a diol.
Oh,
Now you remember? Right?
yeah, very vaguely I remember.
But you definitely saw it there.
Yeah.
Because those two oxidizing agents is not only showing up in the inorganic chemistry, those two are also commonly used in organic chemistry, and you will kind of seeing once and once again. It's definitely there. Okay, it's just a quick refresh of your memory. Because that's something I find out most of students just couldn't really remember, like the oxidation and the redox. It also happened with inorganic chemistry. Okay, so what happened with manganate is that it will be reduced, right? Because it's a strong reducing agent. Now the charge here of manganese is like way too high, it's +7, which means it tends to get lower to become stable. It wants to do some electron. So what it will form eventually is that it will form a manganate 2+. It will form a manganate 2+. So now it forms a stable situation. So what we'll do is that it's also losing 5 electrons. However, the problem is that we have water, right? We still have water. We need to find a way to cancel out those, sorry, not water. We need to find a way to take care of those extra oxygen. So just like we've done before, we change into water. What's that? Do you have any question for this step? If we have extra oxygen, just on the other side, we use water to balance out those additional oxygen items. Okay?
Yeah.
And the last thing is that because we're trying to balance our oxygen with water, which means we also need to add additional proton to make sure that hydrogen is also balanced out. So here now is the balanced half equation of manganate oxidation. Happy?
Yeah. Yeah.
And one thing we need to be very careful about is the color of these things. Why is using the titration? Because this color is easier. It's very easy for us to tell whether this reaction has finished or not just by seeing the color. Still remember the color of manganate and the manganate 2+?
I think it's orange to green.
No, orange to green is actually chromate. It's actually
Ah.
chromate. The potassium manganate is like a purple solution. I don't like this presentation. It's not the color of manganate, or it's a color of like quite concentrated manganate. It's actually purple. Like it's actually those kind of reddish purple rather than a pure purple. Because I've seen that before. It's usually used in the hospital. I don't know whether using Hong Kong, it's usually like in the mainland China. We use the solution of potassium manganate as a sanitizer for someone who has a deep wound infection because it's a very strong oxidizing agent. It will kill any bacteria that's present in your wound. So it's kind of like a sanitizer. Have you heard this before? It's something used to clean out your wound, and it's the same for the hydrogen peroxide. In the emergency room, if you have some car crash, deep cut in your body, they use hydrogen peroxide to clean out your wound. It's really hurting, but it works. Those two things it's used in hospital. So the manganate 7 is purple, and if you reduce it back to manganate 2+, now it's colorless. So you must remember this color change, okay? And the next equation we are going to write is for this chromate. So it's actually dichromate. So do you remember the formula of this dichromate? What's that?
Cr2O7.
Yes, Cr2O7, and it's an ion.
So 2 minus.
Yes, 2 minus. And once it's reduced, it's forming chromate 3+. So it's actually losing 6 electrons because charge here is +6. It's forming 6. Happy with that?
Yeah.
And we're going to do the same. We need to balance those oxygen by forming water plus proton here. So I would highly recommend that to be familiar with those two equations because, as I mentioned before, the question will be like, oh, like if you something that's oxidizing, something's reduced, you need to write the both half equation out and put them together. So those two things, also the hydrogen peroxide one, those three equations will commonly beat the oxidizing agent using the redox. Very commonly used. So I've written down the redox equation for you. It's a quick, fresh of memory. Happy?
Yeah.
Yeah. So then what we'll have to do is that write down this is the reduced part, write down the part that's given out electron, and then do the calculation trying to make sure that electron losing again is the same, and that will be a full equation. So here is just a quick fresh up of memory. What is the color change in those two redox reactors? Also, I want to say is that this chromate is also used in organic chemistry. It's the oxidizing of alcohol to aldehyde and to carboxylic acid.
Yeah.
Right? And for this specific reaction, we use chromate most.
Okay.
Yeah, so that's definitely used here. And don't be surprised if those oxidation of organic things come up in the redox question because it's in the redox reaction. Great. So we're also going to summarize commonly seen reducing agent. That will be our reactive metal. Most of the metal because they have smaller electron activity, which means they like to do what with electron?
Give away.
Yes, they like to give away electron. Which means it will reduce something else, right? It will be oxidized and it will reduce something else. So we usually write it down as metal and we lose some electron to form metal and plus. So how are we going to determine this then? How many electrons is losing? Any idea? How to form a stable iron metal? Because eventually we are losing electron because we want to form a stable metal ion. So by losing how many electrons it can become stable?
It's 1 or 2.
1 or 2. When is 1, when is 2?
Group 1 is 1 and group 2 is 2.
Which means n equals to the group number.
Oh,
Right?
yeah.
That's the grade. Because it's like for a specific question, I'm pretty sure you understand that if you get the right answer, but we need to summarize things. Why is the number? Because we want to lose the valence electron or to form the octal, right?
Yeah.
Lose or valence electron to follow octal. However, this rule only applies to the main group metal. What is main group metal? Have you ever heard of the main group? I guess no.
But is it the non-transition metal?
Exactly, it's non-transition metal. Why is not non-transition metal? Because non-transition metal also, why is not applied to the transition metal? Because transition metal also have some d electron shells. Let's start with like a valence electron. So it has quite a lot of electron to play with. So transition metal always have a very variable oxidation number. That's why you remember that in the transition metal we need to note down the charge of electrons specifically.
Yeah.
So however, for the main group, basically just group 1, 2, and 3. Group 1 and 2 and 3, because it has to do with that specific number of electron, and that's stable. However, it's a really fun fact is that for magnesium 2+, that's a stable one. What, right?
Yeah.
In the unit level, like I know some of my friends, their group actually dealing with magnesium plus. I still expect these things are super unstable, right?
Yeah.
And in their lab, they actually burn down the building because dealing with that, burn down the whole chemistry building. Then it ended up costing us like so much money to repair, to refurnish the whole thing. Because they are dealing with the real reactive metal ion intermediate. So with like some mishandling, they ignite the fire. Sadly. So when I'm saying stable, that means those, magnesium plus or like aluminum 2+ won't exist. It occasionally existed, but like in a super low temperature, in a short time, and it's like super reactive, which you won't doing in your whole life probably, right? But it's just like a fun fact. Okay, and another thing is that sulfite. Do you recognize this term? I think you might not seen this before.
So is it SO3 2 minus?
Yes, it's SO3 2 minus, because in chemistry is that the spelling is very important. Sometimes two similar spelling, they can actually indicate to two different ions. It's a similar structure, but usually it's indicating different charge. Sulfite and sulfate. Sulfate is SO3 2 minus. So as you can see here, what we see the most is SO4, right? That's what we see the most of the time. Which means, do you think sulfite is a stable form?
No.
No. So what will be the stable form, and what will happen here?
Like the sulfate is the stable.
Yeah, sulfite. Sulfate is not stable, and sulfite is relatively stable. So what will happen in this redox half equation?
It's going to gain oxygen.
Yes, you want to gain an oxygen. From where?
From water.
Yes, that's a good guess. From water. Because in the past, we're dealing with those actual oxygen. We're trying to make into water. So vice versa, we are lacking oxygen. We can get it from the water. Brilliant. So because it's only missing one oxygen, so we only need one water molecule. And what will be the next step? We need to have a full balance half equation.
8 plus.
Where to put those H plus?
On the right.
Yes, 2H plus. Anything else?
Then on the right also 2 E minus.
Yeah, 2 electron, because in the sulfate it's +4, and in the sulfite is +6. So here is a commonly seen reducing agent, sulfite's redox half equation. Because sulfate itself is oxidized to sulfite, so it's reducing something else. Happy with that. So it's a very commonly seen half equation, and you can match up this half equation with anything you see here, the oxidizing part. Happy with that?
Yeah.
Okay, so that's commonly seen reducing agent. And then for the last part of this section, I'm going to tell you some quick treat how to do the titration calculation. Do you used to have problem with those titration calculation?
Not really.
Not really. Okay, then I'm going to quickly skip that. If you don't have a problem, I'm not going to talk about it. So let's try with this one. So it will be a typical question that they only give you the question by word, and you need to construct the whole question by yourself. So usually the first thing to do in any chemical calculation, in any chemical calculation is that you probably want to write down the reaction, right? You need to have the reaction, then you can do your calculation. So what will be the reaction equation here?
So FeSO4
Yeah.
plus.
Do you want to do half equation first, or you want just you?
I don't know.
Want to do the full equation altogether? Let's break it down, okay? It can be hard to do the full equation altogether, so I still recommend you to do the half equation first, okay? So it's iron sulfate, and what? What happened on the iron?
It becomes Fe3 plus.
Exactly, Fe3 plus, and we don't even need sulfite here, right?
Yeah.
That's easier, and it's actually losing one electron because iron here is essentially oxidized by our manganate. Okay, now what to do next? What we should do before we try to add up those two redox equations?
So okay, MnO4 minus.
I'll have equations here already.
So then the bottom one just times 5.
Exactly, we need to times 5 with everything. So we add them up together, right?
Yeah.
Just try to break it down. It can be hard for you to construct everything all together, and now don't do it. It's easy to make mistake. Let's do it in the simple way, okay? So now we have 8H, then 5 iron, then 2 manganate, 2 plus 4 water, plus 3 plus. So for this type of question, I recommend you that we just keep it like that. We just keep it as the ion equation, because one thing that we miss out is sulfite, and also it's usually used as the potassium manganate, right? It's what we call permanganate, potassium manganate, short for permanganate. And we're also missing a K here, so don't bother to write down the full equation. That's not necessary. We only want to know the ratio between our manganate and iron, right? We don't really care about how much sulfate and how much potassium we have here, so don't worry, we don't need to write down. Okay?
Okay.
For now?
Yeah.
And for now, so I'm going to do a quick charge check. So 10, 18, 17, 17, everything's good. And for the next step, we're going to do the calculation to use the concentration of the manganate to calculate the concentration of iron. So ignore what I've written here. What would you usually do? I wonder. What is the order you usually do this kind of calculation?
First find the concentration.
Of who?
Iron.
Yeah, of iron, but that one is unknown, right?
But you can use the molecular.
No, you can't, because this question asks you to calculate the percentage of iron that's present, which means you don't know how much iron is present here.
Oh.
No, not for this one, because
Oh.
what we have here is a typical redox titration. We want to use the potassium manganate concentration or the amount of potassium manganate to calculate the other part. So here, I have something with iron is definitely not known because they ask you about the percentage of iron. If you already know how much iron here, like we don't even need the manganate, right?
So then calculate the concentration of iron by so find 0.005 times 12 times 10 to the power negative 3.
Hold on, let me write it down. 0.005 times 12 times 1. Okay.
And then times 5.
Yep.
And then
So
times
that's
10.
Why there's a times 10?
Because the ratio is they only use 10 cm cube.
Yeah, so we need to times 10 for everything. Brilliant. Amazing. That's everything. So I think you're really good at calculation. I won't bother too much. You have your own way to do it. Just follow that. Everything sounds good. One thing I want to quickly remind you is that make sure you use all the number that's present in this equation, because what is the mistake that students usually make is that they miss this times 10.
Oh, yeah.
Right? Because we only use tens of the total solution, so we need to times 10, vice versa in the calculation, because here you obviously use all the numbers that's given in the equation. That's totally fine. But one thing I recommend is that when you use the number out, for example, like here and here, 0.05 and 12 is used, and this 2 is used to have 10, just cancel it out. Make sure that you use all the number that's given by the equation. If you miss to use any number, you will probably get it wrong. They give you a number for a reason. It's not giving you for fun. Okay, that's the only advice. Okay, so I'm going to skip that part. I'm going to quickly cover this part. So here is another titration. Have you seen this one before? I already see sulfite titration.
Yeah.
Yeah, if you've seen it before. It's part of redox too. When was time you learn it?
We did the experiment, I think.
Oh, okay, brilliant. So if you've done the experiment, that's awesome. So have you used starch as a iodine indicator?
Yeah.
Okay, brilliant. So you know what happened here. So basically, is that what we're actually used is this seal sulfite, and it's actually doing what from seal sulfite to this disyl sulfite. Can you tell me is it an oxidation or reduction? Here.
Oxidized.
Yes, it's oxidation. So that's what actually happened. So in this titration, we are measuring the oxidizing agent because our knowledge agent here is oxidized by the measured oxidizing agent. So in this kind of question, do you ignore what's being used as iodine? What is the key? Is this seal sulfite? Is that because what actually happened is that seal sulfite is oxidized by the oxidizing agent because the iodine here, even though it's oxidized by the oxidizing agent, is then reduced back by the seal sulfite. So what happened with iodine is kind of like it's oxidized and it's reduced back, which means there's no reaction happening with iodine at the end. Eventually, it's these two. So just remember that you need to find out the ratio between seal sulfite and oxidizing agent. Then do your math, it'll be the same. Okay, can I pass this part?
Yeah.
And you also need to remember that in this type of question in titration, they usually mention the color change because we want to know the endpoint of titration. Here, the endpoint is for the iodine that if the color disappears, which means all the iodine has been reduced. So remember that iodine will become blue when it mixed with starch. That's it. Okay, so here I think, no, I just have a, so remember that iodine will become blue when it mixed with starch. That's it. Okay, so here I think, no, I just have a few questions left here that you can, I don't worry too much about your calculation. Do you want some actual question with the redox, with the, not redox, with the electrochemical cells? I think that's a probably slightly more. So I will send you something later on because I have lecture afterwards. And if I miss that, just text me. I will send you one. Okay?
Okay.
Brilliant. So I think redox is fine. We just need to focus on practice on the chemical potential. Okay, so that's it for today.
Yeah. Okay then.
For next week, what kind of topic you want me to cover?
I'm not sure yet because I have another teacher teaching me the other topics.
Need to focus on practice on the chemical potential. Okay. So,
okay.
Brilliant. So I think redox is fine. We just need to focus on practice on the chemical potential. Okay, so that's it for today.
Yeah. Okay then.
For next week, what kind of topic you want me? Yeah, that's fine. So if you want to book a section next week or not, can you tell now? Not now.
No, I don't know right now.
Okay, that's fine. So if you want to book a session, just try to book it like in your head. Like tell me by like Thursday something. Just don't all of a sudden on Saturday morning say, oh, can we have a lecture tonight? That's not
Okay.
working.
Okay.
Yes.
Yeah.
Brilliant. Thank you. Bye.
Yeah. Thank you. Bye bye.
Ding. Fuck you, Q-Dog.
Hey, stop getting rage baited.
You are so good at rage baiting, I tell you. You had me howling.
Protein cubes with white sauce.
What? What are you saying?
Can you hear me?
What are you saying?
A steak. We call that a steak.
Okay. I told Ethan to join. He's gonna tell us some important information.
Oh, okay.
You're actually rage baiting, bro. Mid convo goes to scroll reels and proves it to me. We said like why you like stop typing and then just disappear is because you go scroll reels. And bro actually went to scroll reels.
Yeah, I remember you saying that, so I did that.
You are such a rage baiter, bro. Ethan,
Ethan, this is like the quarter meme.
what meme?
I don't know, the one of like the low and high bar thing.
Yeah. What about?
Yeah. I'm like low quality, and Chris is just constantly rage baiting.
Wait, which meme are you talking about?
I don't know what. How do I describe the meme?
Is it the monkey and the tiger?
Not that one.
No, it's not
Wait,
that one.
Ethan.
Yeah, I have it. Wait, let me just send it. Oh, you sent it. Okay.
Where?
I didn't send it.
Wait, you didn't send it? Wait. Oh, okay.
No, I didn't say anything.
Oh, I'll just send it in general. Chat.
Yeah, okay. This is just me with everyone, every single person I know. I'm low.
Exactly.
And Chris
You're
is
doing
high.
that to me. Like I'm like howling, and then you're just doing that.
Chill out, man.
What do you mean, chill the fuck out? Bro ignores me to scroll reels, bro. Bro, Ethan, it's actually true. Mid convo, he starts ignoring me and starts sending me reels.
Hey.
Bro is intentionally rage baiting me, bro.
Hey, that's the best thing you said before I sent you the reel was, "Oh, Daddy Chris, I'm enjoying this so much."
Yeah, because I asked you like, hey, when can you VC? And then you're like, oh, guess what? Guess who got their powers? Like, I don't give a fuck. Just tell me yes or no.
I thought you would realize that. I thought you checked Discord and see me on the call.
Why the fuck would I check Discord when you're on Instagram?
Do you not check both at the same time?
Why would I go to Discord if you're already on Instagram?
Because that's where we PC on Discord, not Instagram.
Oh my god. Why would I go to Discord when we're already talking on Instagram?
We can talk on both platforms at the same time. You don't do that?
You don't do that, bro. You disappear on both platforms.
I talk and disappear on both platforms, yes.
No, okay, no matter which platform you're on, you go to Instagram and start scrolling reels.
No, not really. I would play Wordle. Or
You play Wordle for the whole fucking day? You spend 2 minutes doing Wordle. How could you spend more than that?
oh wait, I didn't finish my word yet, did I? I didn't finish it yet, so I
great.
did.
Oh, great.
Okay, what are we we're talking about the Japan trip, right?
Yes, Ethan.
Oh, yeah.
Let's start us off.
Okay, so basically,
Presentation.
bro, that got me nervous all of a sudden. You said the word presentation and I got nervous.
It's okay, even just
presentation, bro. Okay.
oh no.
This presentation is out of 100 marks.
Okay, so let me start. Okay, so basically, I have a friend.
Yeah.
He's living in Japan, Tokyo, So basically, he suggests that we can look at the anime stuff for like 1 or 2 days, and he thinks like we can't really spend like 7 days in Tokyo unless we spend it really like slowly. Like we just do like one thing every single day, which is probably not what we should do, right? We should probably look at more stuff.
Yeah.
Right? Plus, like like
Yeah.
people like Leonard, he doesn't like watch anime, so we can't just look at anime stuff all the time, right? We
Yeah.
should probably look at some other stuff, right?
Yeah. Yeah.
So he suggests that we could try going to other cities like Osaka or like Kyoto as well.
I would like to go to Osaka.
Yeah, we could do that because apparently, like, I asked him like, how's like the night buses? Like last time we saw on in the video, right? They're like the overnight
yeah.
buses, and apparently it's actually not too bad because he told me that there are like curtains for each seat, and there's also a toilet in the bus. So literally, yeah, it's actually really
Right.
comfortable apparently.
Oh, okay.
What?
Yeah,
So
it's
we can literally sleep on
We're
a
planning the
bus,
Japan
so we
trip.
don't have to like worry about hotel either as
Oh.
well. We can literally one night we can sleep on a bus. And he also told us.
Yeah.
He also told me like hotels are actually not too expensive, and we should probably just book a hotel instead of like an Airbnb.
Okay.
Oh,
You know,
okay.
Iran hotels are really cheap right now.
Let's go to Iran, guys.
What?
Oh my
Check out the
firework.
wars.
You know one of my dad's friends. She's like a lawyer or something. She went to Iran for like a case, and then after that she disappeared. My dad tried to contact her, and she just never replied after going to Iran.
That's crazy.
Boom boom went bye bye.
Oh God.
Benedict,
on.
do you have time to go to Japan trip with us?
What time? I have to. There's a lot of people wanting to go. There's like a lot of trips I have to consider.
Yeah. That
Yeah.
makes
No,
sense.
there's a lot.
We'll send
No,
you the date,
Chris,
guys. What's the
You
date?
you and Leonard have to decide on when you guys are free first, because me and Ethan are gonna be. I'm gonna be free this month, and Ethan's gonna be free pretty early as well. It
Yeah.
depends on you and Leonard.
Oh, it's up to us. Okay.
Yeah.
Sign up, guys.
Uh,
No, the problem is I don't have money.
oh,
That
what?
is
How?
There.
You
I have to save
too
my-
many trips?
No, I have to save up money for every trip. So I have to work part time after my exams.
Okay. When does your exam end?
Next month.
Next month. So May.
My
My exam ends at June, end of
Yeah,
June,
so it's
so
gonna be
start of
after June
July.
anyways. Yeah, so it's gonna be like the end of June, right? Like
Start of July,
I
just be
know.
safe.
like
I'm invited to like 4 different trips, so I have to consider which one to go.
okay,
Oh.
yeah. I mean,
Just
yeah,
go to all of
I
them.
guess.
I don't have that much.
Travel the world. Go side hustle. So I think start of July. So like, maybe 5th. We start on Sunday, 5th of July, maybe.
Okay.
Okay. That works.
So for now, let's do 5th of July.
5th of July? Okay. I mean that's fine.
Can we ask? We should also ask Leonard though.
Have you played on my Minecraft account?
Yes, I played on your Feather account, but I didn't play on the normal launcher because I don't have your password.
Oh, do you have that now?
I'm
Do you
still
have that
logged
now?
into your Feather account, but I don't have your password for the Minecraft launcher.
Oh. When you look for me, I was in mainland.
Oh,
Yes. Ever since my family got the Shenzhen license, car license, they kept on going back.
for what?
Yes, fair.
Anything.
For fun. Yeah, that's reasonable. That's reasonable.
Everything's cheap.
Yeah, everything's cheap.
Oh, that's true. Also, at the start of May, we're gonna plan a spa day.
Can that be after my exams?
Wha- You said it next month, so when on May?
Next month is May, bro.
I know, but when on May does it end?
The first week.
First week of May. Oh, okay. So let's do it after that then.
Okay. Protein tube with a white sauce.
If I study 10 hours a day for 2 months,
No. It's useless, Chris. I already forgot 90% of what I studied for the vlog.
Wait, but didn't you say you studied everything?
Yeah, I studied everything, but I forgot practically everything. I have to
What?
restart
How?
soon.
Yeah, that's how studying is. You study it for like no matter how long you study, you just forget it after everything. There's
They're
no
just
point.
repeated like in seasons. Like I repeat
I only
everything
remember
you
the
studied.
Krebs cycle. It's like something a cat, I kissed, fucky, no,
What?
it's sucky,
What?
fucked my ovum. That's like
What?
What?
that's the only thing I remember studying.
What do you
That
mean?
surely,
Okay,
that surely was not in the test.
no, look at this chat. Look, okay, a cat. No, hold on. Okay, look into the chat, and you'll see.
What is that?
Hold on. You'll catch up. And then
I don't think I'm catching up, guy.
What?
What?
wait. I'm typing something.
Okay.
I passed it.
I'm trying to remember how to spell words, okay?
Oh. Yeah, that's fair, actually.
Citric. I actually already forgot. Citric acid. Suck.
You sucking on?
What? Yeah, what are you sucking on? Just wants to join in the sucking.
Sucking no acid.
What?
Succinate.
What? Why are you sucking on ass?
Hold on. You'll
Chris, are you catching up? Because I'm not.
No.
hold on.
I'm trying my best. I'm holding.
He's revising right now, which is
There. That is a cycle of chemicals for plants. I think it's for plants. Yeah,
you have
it's
to
plants.
remember all of that. That's crazy.
That's for one. That I think that's for like 3 marks.
Well, I think there's a better way to memorize. Right?
No. This is the way I made. My way is best way.
Well, yeah, I mean that works.
Tudok. Tudok is a genius, bro.
I don't know why he has to like. It's
Is
so
he
funny.
Bro's an emo.
ACISS?
How is that emo? Giggling is not emo.
No, I said
no,
bro's an
no.
emote. Like Elvis is an emote. You used him as an emote.
Yeah, exactly.
Chris, I found a very fun game.
What?
I found a very fun game. Watch my stream. So you know how there's Roblox voice chat?
Yeah.
You listen to people sing in this game. Wait, no, I'll show you some clips while in the intermission. Okay, let's see if there's clips. Wait, where is the clip? This is one of the clips. Okay, this is like this kid sings this song.
I can't really hear it.
Wait.
Oh, you should
Share
share
the
the metal
background
link.
sound.
You should share the metal link.
There, now you can probably hear it again. Oh my god! Oh my days! I don't want to post this shit on my account though.
It's fine. It's fine.
What happened? What happened to internet? Okay, whatever.
Oh, I just want you to come with me. We're on a
It's the same kid.
Okay.
Galo.
What the want to come with me.
Oh, what the?
I'm gonna be tiny.
Nah, that's why I find this game so fun. No, this is like the front. No, this one is like the first clip.
If you want to bury me in your memory.
You stupid nigger! Son of a bitch, I hate niggers! And you are a nigger!
Exactly why we play this game.
Every word, centuries old and unbent.
I'm just waiting for clips. It's like watching America's Got Talent with Kid Child. This is not that bad. The bad ones are stupidly funny.
Stay in your place, better seen and not heard. Well, now that story is ending, 'cause I
Wait, is this the game? Like you're actually
Yeah,
playing
this
it right now?
Yeah.
Met her on my way to Chicago, where she was all alone.
Oh, they have a duo.
I met her on the way to Chicago, where she was all alone.
Just read the lyrics, bro. Not even sing.
So I asked her for her name. She smiled and looked at me. Sunrises, that woman like that is really into me.
Best game. I think it's worth showing my ID to Roblox, right? Oh, everyone's gonna raise their hands for this.
Do you get to sing?
I can choose to sing.
I'm just trying to be your man.
No.
Cause I'll do anything. Anything.
So this game is designed to be awkward.
Yeah. Wait, is there karaoke? Hold on. Not this one. Is it this one?
Okay.
Wait, no, it's okay. It's a good song.
What am I listening to?
And then,
sorry.
Okay, can I please load into the game?
Di na pakinggan yung kanta na yun.
Can I like why is this so advanced? Can I listen to someone sing? This is like a Roblox date I'm witnessing right now.
That's crazy. Unlock your mic and ruin it.
What's up?
Ay, grabe yun na.
I'm out. I'm out.
Ayaw mo na mag-rap?
Bro, this is e-daters.
Bro, I should get my ID check for date him. Date this person.
Anything you should be something I don't want you
This is fucking hilarious. Is there anyone else? Oh wait, there's someone in here. Is this like?
It's me standing in the arms of the door.
Get me out of here! Get me out of here! Get me out! Oh my god, another guy. He's not even singing.
Sing for him. Sing for the person.
What is happening?
They're e-daters.
Oh, these two are still singing.
They're having the day of their lives. Sing.
What is this?
Sing it.
I don't even know what the word is.
Sing this. Try to sing it. Try to sing with them.
Hi. Continue.
That's so evil, bro.
English karaoke. I need to wait 9 seconds. Welcome, all rights belong to the corresponding artist. We don't claim any FAK. Play. Oh.
Do what you can.
Did you that volume was so fucking loud. That was so fucking loud. Beat it. There's a kid crying in the background.
Wait, what? Sorry.
What is that?
Okay, yeah.
This is fucking hilarious.
We
Sing
should
with
actually
them.
just decide where we want to go.
It is so loud.
So my friend can also drive us around.
Wait, which city can you drive us around?
If he can rent a car, he can drive us around.
In which city?
Yeah, it depends on what day we are going. Cause like he is free after like July, cause that's when his school ends. So
I just realized I'm standing in a very awkward position.
So if he
Hold
I think
E to
he can
skip.
just drive us around in any city. Like he has.
This guy's gonna sing
license,
505.
any city?
I can't wait.
Yeah. It depends where we're going from. Like some places it might be just more convenient to just take the train, you know.
Oh, okay.
Oh.
Then we should have a plan of which cities to go to.
Yeah.
Like
Wait, turn up the volume. I want to hear him.
How do I turn up someone's volume? Oh, okay, it's like in the middle of the chords. You know what? Let's just next room. Espresso. No one's singing.
No one's saying. They're just enjoying music.
Maybe you turn down the volume and that includes their voices.
No.
Oh.
This is new joys of Roblox. Fucking hilarious.
Try to join one of the songs.
Even singing.
Try to sing for those who aren't singing.
Okay, let's see which song I know.
You don't have to know the song, just pretend to know it.
Oh, like sing off key?
Yeah, like no, just guess the key. Guess the song.
Yeah, I have volumes.
I always had that dream, like my daddy before me.
Bore me, live life, know me. I was 12 years old. My daddy got sold.
Just mood in every single one. Mood in every single one of them. No. Why did you do that?
It's like next one. Next one.
Bro, just kill the mood. Like kill the mood. Like, I want you to go into a room, start singing, and then everyone goes silent because of you.
And I continue singing.
Yeah. That's the funniest shit, bro.
It's okay. I want an alt. I made an alt for this.
Wait, you can do that?
Yeah, look at my name.
Winged pigeon.
One winged pigeon. Okay, let's go. Let's start. Let's go mess up some vibes. Yo, I don't want a loudspeaker. Okay, calm down. How do I?
It all became so lovely.
Should I do it?
Yeah, do it.
Above me, those funny feelings I had never felt before I met you.
Just sit next to him and do it.
I'd stay a while. Try to learn to smile. So
Your avatar is adorable. Thanks.
Maybe I'm not alone. I see the colors fading.
I need to. I need to like. I need to go to a song that I know so I can mess up the chords. Like confidently mess up the chords. What is this? Look at German typing. Is he like? What is he typing? What is he typing? Hey, Daddy. Bro, can you pick a song already? I'm not going to the next one. It's good. What is this?
Pretend to know. Pretend to know the language. Pretend.
Let me sit down. Kalimbali.
Seriously, do it seriously.
I can't take myself. I gotta take myself seriously. It's like I'm fucking summoning a demon. Holy shit. Oh my god. Okay. Let's go back. Aku. I'm so hungry.
Stop running away. Go back.
I'm crying. I'm fucking alright. I'm crying IRL. This is too funny. Imagine this shit just. Alright, let's go to Mr. NGS Juggy. What are you saying? He's still typing.
No. Go and sing for him. Like, just start singing. Sit down and start singing.
No, you can be a better man for your brand new girl. I'm lagging, I guess. Good for you, you look happy and healthy. Not me, if you ever scared.
Good for you, you're doing great at IB. God, I wish I could. Like. I tried. I tried.
I wish I could do this, bro.
Everything you want, you bought a new car and your car is really taking off. It's like we never ever had baby.
What is up with that? Good for you, you never ever met me. Remember when you saw the video? It's time to jump in the ocean. I can't. Wait, I have a mic. This guy hasn't picked a song yet. Let's pick a song. How do you pick a song? Interact. Oh, did he pick something?
Oh, new.
Let's do it.
Wait, it's right there. It's the third one.
Oh, really? Oh, shit. Okay, let's do it. Select song.
But sing it off key. I can show you the world.
Okay. I can show you the world. Shine ships. Hard decide. I open your eyes. Take you wonder I want. Over sideways and I'm on it. Yes. Okay, let's go back to Danny's house. Danny's house looks more intriguing. There's a date to interrupt here.
See you.
Sit in between the couple.
I go whoops, kitty, whoops, kitty, whoops, Senzu. Ala, nakadula.
Leave! That's a perfect date song.
Shit.
Oh, W Wingman. Like a lazy ocean hugs the shore. Hold me close, sway me more. Get me out.
Why?
I don't know. Next game. Roblox talent show. Let's go. Let's go.
Don't look at me. They just it's all to you. Don't look at me. You gonna take that? Me personally, I would never take an insult like that, but that's just me though.
Look at her avatar.
Oh, they got banned. They got voice banned. They got voice banned. Oh, they got voice banned. Oh, Lord, they can't hear us. Oh my God. Wait,
That's what they get.
yo, this cat looks like it's been stretched. Like you rub your hand and then like you just pull its face back.
Do you hear what I'm hearing?
Oh, girl.
I don't. Wait, what? Can you turn up your volume?
Up?
Listen to Tom and Jerry. Wait, Tom. Queen is back. No, they never left.
I leave the pocket
Nah,
alone.
they managed.
Pocket alone. Hey there, lip girl. I see your lips back and forth whenever you talk.
There's nothing here, bro. Rap battles.
Click.
Yeah, nigga.
They just spit some fire. Can you beat that?
One, 2, 3, 4.
5.
Wait, this it's not a mic. I don't think it's a mic rap battle.
No, I'm pretty sure you can have your mic. Majority of people have their mics. The monkey guy doesn't have a mic. Oh. Hi, I'm watching rap battles.
Rappers for this round will be.
Oh.
Ready to throw down.
No, I'm just watching.
Go.
If I join, I'm just gonna leave.
Hello.
Hi.
You stepped in comments. That's cute. I get it.
What?
Rap battles.
But no one's actually saying anything. That is not fun.
Because of the Roblox
The actual part
restrictions.
Nah.
Sing it.
No, I'm going back to karaoke.
No.
Stop
Oh,
laughing when
dance
you sing, bro.
karaoke. I love playing that.
Oh, I'm so sorry. I think I
We're
ruined
trolling.
like 20 people. I think I ruined 20 people's experience on this game.
Bro. I love playing this game.
Is I? Okay, let's go crash someone's karaoke. What is happening here?
Start singing, but don't laugh.
Okay, I'll try. This is just the two of us, okay?
Wait, let me join you.
Just the two of us. Start singing, bruh.
No, the lyrics
There's no
isn't up
lyrics
yet.
yet.
There's 10 seconds left. The pre-chorus here is really long.
Open your mic.
Wait, I can't. Why can't I find you?
Oh, he's on
This
an
is
alt.
Did I have you friended?
Sing.
And the beauty of it all. To make those rainbows in my mind. What are you?
I wanna spend some time with you.
Sing.
We can make it if we try.
Just the two of us.
I am
That was a
running
perfect
away
song.
from my problem.
Add me.
Oh my god, I don't have my ID verified. I can't join you guys.
Red dye, add me.
What?
On Roblox.
This is my alt.
Oh, your alt?
Yeah.
Yeah, are you watching the screen?
Yeah, I'm watching the screen.
Sing. Benedict.
Alright. I don't know this song. Let's do it. To hold your hand for you and mine. I'm gonna be your man till the end of the time. He's laughing. He's laughing.
Stop laughing! Stop laughing and do it!
He left. He knows that was. Yeah, he felt my aura.
Connect me, twin.
Oh, there's a date here. Let's
Connect
see
me,
it.
twin.
Oh wait, how? I have to leave the game and go to. No, someone wants to add me. What? What? You're not here.
I connected you, I swear.
I think I connected the wrong guy.
Oh.
Wow, let's make some. Let's make my avatar.
That's so gay.
Oh, woman! Oh, that is such a steal. No one told me women were free.
That's...
Say that.
It's pending request.
What is this?
You can be clear.
I can be Claire. I will. Let's be clear.
Oh.
Oh, mama.
Now you gotta speak in its accent.
Connect me, twin.
This one, right?
Yeah.
Who the fuck is this guy?
I don't know.
He added me from sing it because I sang some random bullshit on the stage.
Let's play sing it. Let's play sing it.
Let's play sing it. Okay, let's do it. Let's do it. Let's do it.
That's why you get one winged pigeon.
Yes, this is the. Oh.
Oh no.
Oh
no.
Oh no, that was such a good song.
I used to think that I wasn't fine enough.
Wait,
And
my sister wants to hear, so like, I have to put my headphones down at max volume.
I used to think that I wasn't fine enough. And I used to think that I wasn't wild enough. But I won't waste my time trying to figure out why you playing games. Was this all I
Cry emoji.
can't believe you're hurting me.
Oh, let's make let's sing something.
We've come too far to give up.
Oh, I know this song. I just realized I know this song.
We've come too far to give up. Let's raise the bar.
Not well. Obviously, his best is not enough. Hidden gems meant to be hidden.
Freestyle.
Let's do it. Let's do it. Oh, you're it.
Hi. My name is David. Dad, I want some ice cream. David, that is my name. David, I want another. David, where is my ball? I'm running out on the road. There is a car, and it's gonna hit me.
Zico.
Absolute cinema.
So you're still thinking of me, just like I know you should.
What are the votes supposed to be?
So you're still thinking of me.
It's like you have to like click to try to attempt to sing the thing.
Cannot give you
Like you have a chance of singing if you click.
Oh.
I'm so high at this moment. Yeah, we're just young, dumb, and broke, young, dumb.
This game is gold.
Don't be fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know.
I give him like.
Why did they get cut off?
Yeah, you have a limited time.
By the rocks that I got, I'm still. Used to, I don't know this song.
Cheer!
Crawling back to you.
Oh, let's do it. Let's do this one.
I know them.
It's me.
Whoa.
Crawling back to you. Every thought of calling when you had a few. 'Cause I'd always do. Maybe I'm too. I forgot the lyrics. Gang, my bad. I'm getting hearts. I'm getting hearts.
Jesus Christ.
This is so funny. Why does this bird have 2 mouths?
Oh,
She
I
has
can't hear.
lips.
that's disturbing.
Give me 24 hours. When all I need is 24 hours. I promise you, I'll plenty more. You probably be with me forever. Sigma, Sigma.
What the hell?
Oh my god. Oh my god, let's do it.
Sigma, Sigma.
I swear.
It's you,
my
it's you,
God,
it's
me. Sigma, Sigma boy, Sigma boy, Sigma boy, Sigma, Sigma. Stop laughing.
Cheer.
Sigma,
Cheer, cheer,
Sigma
cheer.
boy, Sigma boy, Sigma boy.
The echo.
Does it just repeat? I don't know the song. Actually. Sigma, Sigma boy. Go girl, I'm crying. Thank you. Thank you.
Good day in my mind, safe to take a step out, get some air now, let your
They
edge
actually
out.
like me.
Good day in my mind, safe to take a step out, get some air now, let you add out. Just in my
This game is way too funny.
Can you get to
I want to sing it without knowing how to sing it.
No, you
Hey, not everyone has good mic qualities, okay?
baby, baby.
People set the bar really low in this game.
Cause all of the
I know this one, let's do it!
things that you do.
No! Fuck! It's either very.
Most of these are kids.
I'm pretty sure. No, I'm pretty sure these are all 18 plus ish. Is my account's verified as 18 plus. Or if someone just used their mom's IDs to fucking. Oh, you got first place!
Oh,
Let's see how many points I got for that. I got 20 points. I'm equivalent to third place.
I got first.
Way too good at screaming.
Oh my god, thank
Yes,
you
girl.
so much.
Yes, girl. Hey, girl. Your confidence has
I didn't know I would win.
I'm gonna act gay. I'm gonna act gay, Chris.
Girl, you deserve it. And kings and queens in this server, you.
Hey, queens!
No, shy, okay? We are playing for fun.
Y'all slayed!
Yes, slay, king and queens.
Oh wow.
Let's go. Let's
Guys,
eat
let's go on. Let's have a
I get your number, girl. I'm dying, bro.
Wait, is that a king? Yo, king, what?
I can't.
Oh, my bad.
I can't take this game seriously. I can't.
Can you click musical for me?
This game is way too funny.
Can you guys pick musical? Please.
Actually, I don't know, like, what's the. You know?
I wanna sing musicals.
I think as long as someone picks it, it's in the loop.
Oh.
Baby, don't let me down, I pray, oh pretty baby.
No! I wanted that! No!
Oh, pretty baby, don't bring me down. I pray you're pretty baby.
Peak! This is peak!
Found you. Ah! Stay and let me love.
Yes!
You.
Yeah.
Diva.
All I
Diva.
can trust is this concrete oasis. Seems every time.
Ah! I don't know how to sing this one! It's Freeze Your Brain! Oh my god! Wait, no.
Go for it. It's your turn.
All I can trust is this concrete oasis. Seems every time I'm about to despair. There's a 7-Eleven.
Yeah, I thought you were doing it.
I don't know, I only know
All
the
I can
chorus.
trust is a concrete oasis. Seems every time I'm about to despair.
My guy is not even
7-Eleven
singing.
Right there. It starts in the
He's
same.
reading.
From Las Vegas to
She's just
Boston,
reading,
in all
bro.
places that I love to
He's
get
reading.
lost in. I pray at my altar. Yeah, I live for the sweet for the rush.
Nah, some gooners just hear a girl's voice and just cheer.
I've lived a life that's full.
Yes! I lived a life that's full. I traveled each and every highway and more, much more than this. I did it my. I got cheers.
Close my eyes. I don't wanna fall asleep because I
I'm way
miss
too good at
you,
this game.
baby.
My parents thought it was too loud from upstairs.
I don't wanna close my eyes. I don't wanna fall asleep cause I'll miss you, babe. And I
Bye.
don't wanna miss a thing.
Shut the fuck up, nigger.
Even when I dream of you. When I'm thinking of I'll miss you, babe.
Falling, but
I
I
don't know
never
this one.
thought you'd leave me. Falling, needed.
Wait. Actually, I'm gonna try to get first place in one game.
Falling, but I never thought you'd leave me.
I'm gonna prove
needed something
men's
to believe.
supremacy or something.
Oh,
Just joking.
I thought that you were the one, but it
I'm gonna
was
prove
all in my
toxic
head.
masculinity.
Yes, at singing. Proving toxic masculinity and ballet.
What the fuck?
Just please don't say you love me, cause
I don't know these songs.
say it back.
Damn.
Doesn't mean my heart stops skipping when you look at me like that.
Let's just wait until we have a
There's
song that I
no
know.
need to worry when you see just where we're at. Just please don't say you love me. Work hard in a trap.
I don't know this one.
What is this?
I can't walk out
I could have sung that.
because I
Join.
love you too
I can't. I don't
much,
have my ID verified.
baby.
Man.
I could have sung every song.
Looking for a job and then I found a job, and heaven knows.
Wait, someone's singing. Oh, not this one.
I was looking for a job.
Bro, this
and
girl's
I
just
found a
fucking.
job,
She's just
and heaven
reading.
knows I'm miserable now in my life. Oh my god, I don't know. Lupa nada. Sorry.
What?
Slay, diva. I can't type. What?
I can't be your
What are these songs?
Yeah, I have no idea. Why do I know none of these?
I can't be your only one. See, I can sing it.
I can't be.
Where's your ID?
I don't know. Okay.
Verify right now. It doesn't take that long.
Wait, how long does it take?
5 minutes.
5 minutes and then I get verified?
Yeah.
Immediate, like the response?
Yeah.
Oh, okay. I'm gonna do it right now.
And then we can play neighbors and talk to random people.
Blaster, can't you just make it move faster?
ceiling plaster. Can't you just make it move faster? Loving to be sitting here with you. You're kinda cute, but it's raining harder. My shoes are now full of water. Loving to be
I'm gonna dominate,
Oh,
yeah.
oh, finally something I know. Oh my god, finally
for
a
it.
song I know. Carry my, no he can read my poker face. She's got me like nobody. Carry my, no he can't read my poker face. She's got me like nobody. Poker face, poker face.
I don't know what to give you. I'm biased, not based. What is this?
Who loved your eyes? Who loved you first? Wait, who loved you first? Who loved you last? Why do I always think of these things? Cause wait, what?
Oh my days, this is boring.
Never mind, I don't know the song. I'm sorry.
Get out.
Because these people don't know.
Yeah, they don't know and just click.
Wait, I think I can join you.
Join.
Yo, I'm joining. Yo, wait.
I see you, but you don't have your mic.
Wait, how do I activate it?
You have to wait. You have to verify.
Yeah.
Did you not verify?
Testing. Yes, I'm connected to voice chat.
Yes.
What?
Wait.
You verified before?
No, I think it's because I used my face. And it predicted my
Oh.
age.
Sing something.
You don't have to say what you did. I already know. I found out.
Wait, let's compete for the higher marks. Let's compete.
We can't even compete if there's no songs that we know.
True.
I found out from him. No, there's just no chance for you.
I'll cheer everyone for the for the morale boost.
There'll never be, and don't make you sad about it.
Give me a
Wait,
freestyle.
you have voice chat.
So come and let it go.
Yeah, I don't know this one.
Just let it be.
Let's go, Chris.
So come on, just let it go. Just let it be. Why don't you be me? Everything that's broke, leave it to the breeze. Why don't you be me and I'll be you, and I'll be you and me. Yay! Clap. I did amazing.
Oh, there's actually no songs I know.
Yeah. You get the best of both worlds. Chill it out and slow, then you rock out the show. You got the best of both worlds. Mix it all together. Skibbity! Skibbity. And you're supposed to. Is this more relevant?
Hey boy, I'ma get
Oh.
ya. I'ma get you real
Oh my
good.
god,
I'ma
let's
get
do
ya.
this
Hey
one.
boy.
No.
Hey boy, I'ma get you real good, and I bet ya. Hey boy, once I get ya, you'll be oh so glad that I met ya.
My strategy. Get ya, baby.
Oh my.
Whoa,
did
I'm
I
on the
get it?
leaderboard.
I'm first place.
Yep, let's go.
What did I even sing? My
The
way.
servers suck.
Purple. I got first place. You know, my singing is peak.
Sotro.
My screaming is peak, not singing.
Hey guys, hey guys.
Yeah, this is Chris.
Please.
I'm gonna win this, y'all. You guys are no competition to me.
Girl, you're nothing compared to me, girl.
Girl. I wish I could swear at you right now, girl. Girl,
Look at
you
that blue
hear
ass
me,
hair.
girl? I'll slap your face.
My Minecraft's loading up.
Oh, what?
Chris, I didn't know you're gay.
Oh, girl, I'm gay as hell, girl.
No, Moga, you got, it's muted. Like you can't even get to say anything. You only say you can speak in the lobby or.
Wait, can they hear me right now?
No.
What? I can't say gay in Roblox.
Chris, look what I've been practicing.
What?
Why can't? Oh, how did I miss? I suck. I pulled it off a couple times before. Yeah.
Guys, I just woke up. I want someone that deep.
We should go to the karaoke one, like the one you were at.
You wanna?
Let's go to the karaoke one.
This server is based for me, so.
You want to stay in the server?
I think. You want to go there?
Wait. Let me see if I. Oh man. Okay, let's go.
Mars! I love you, Mars!
What?
That's my friend.
No. Who's that? Oh, is he like in the server right now?
Yeah. She's the one singing.
The one with the pumpkin on the head, like above their head. I joined a random one. I couldn't join you guys. Are we doing?
Oh yeah, let's go.
18 plus. Is anyone here underage?
Cute dog.
Now we is back on track. I hope. Please. Star said his condition is really bad.
Which server you joining? Let me join you.
Oh my god, let's go do some Briz. There's literally a bar here.
Wait, why?
Why at this time? Oh, why would?
It doesn't say you're playing anything.
Yeah. I haven't chosen yet.
Girl, you're so diva.
That's Queen.
Oh.
Wait, which one should we do?
Girl.
Do you want to do dance karaoke? Yeah, let's just do the underaged one. Join me.
Wait. Q-Dog is yelling.
I'm
Q-Dog,
not
say
yelling.
something.
I'm not yelling.
I
I'm just
muted
talking.
Q-Dog because there was too many background sounds.
Yeah,
Yeah.
I muted Q-Dog as well.
Yeah, that's fair. Yeah, that's fair. I left. You guys can hear me, right?
Yeah, I hear you now.
Yes.
Oh, okay. I can't upload the freaking banner. I uploaded the other one. Wait, can
I wish I was special,
Let's do it together.
but I'm a creep. I'm a weirdo.
My ears has been.
What the hell am I
by the
doing?
time. I'm very grateful for
I'm getting
my
followed!
ears.
I'm getting followed! Get me out of here! Get me out of here!
What?
I'm very blessed. My ears are so blessed right now.
They are.
Yeah, I feel great to be alive.
Makita beriker, berakir.
Should I verify?
January.
the fuck?
Oh, oh.
What are you doing?
Oh, ooh.
Go.
Ooh.
What the hell is happening?
January.
January.
Sing the
Sin
little
by
Manamida.
little Nina ni
Oh
Maria.
god, my ears. Should I verify? Should I verify?
Got 88 scores.
Maybe.
Okay,
How
let's
to verify?
let's go to the next. Let's crash the next party. What is happening
How
here?
to verify, guys? How to verify? Wait, I'm gonna regret
Have a good
this.
time, guys.
Oh, am I gonna regret this?
Toretti.
Toretti.
Toretti. Ako.
I need this.
Toretti.
I need this.
Oh my god. My ears are so
Tourette syndrome sa'yo.
My ears are so bad. I wanna die.
Toretti. 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 Sa'yo.
It's my candy store. It's my candy.
Oh my god.
I got number 1 again.
I'm
How? How did you get 99?
Passion.
Wait.
Let's
How
crash
do
the
I
next
verify?
party.
I can't find it. I can't
Oh, this one,
find
this
it.
one.
How? Wait, I can't find it. Someone help. How do I?
How could you make me hurt so bad?
Screen share.
When I have
Oh,
loved
okay.
you more. When I have loved
God, my
you
ears so
more.
bad.
Anyone can do.
I'm so happy
Can't
to be alive.
believe the pain. Cause I'm feeling now because of loving you. I can't
glad.
seem
I
to.
can't seem to
I can't seem
understand.
to. How
happy
can
to
love
be
be
alive.
so unkind, yo? You broke my
Where is
heart
it?
despite
Go
what
back.
I've done.
Still my
It
love
is
is not enough.
What?
Oh, I am giving you my all.
Account info.
I can't
Oh,
take
okay.
it
I can't take it anymore.
Bro, my ears are so
How?
bad. Okay.
How?
There.
Say
Check your
What do you
age to get more features.
What? Oh,
You can
okay.
continue with camera or continue with ID.
Where?
when,
Oh, you're talking.
when I loved you more
Oh,
than
okay.
anyone could. Feeling the pain.
Oh my god,
I'm
so
feeling
blessed.
because of loving you. Block the lyrics. Block the lyrics.
Good job, guys. Good job. That was beautiful work. Especially you, Tammy.
Beautiful singing, Tammy.
Beautiful, beautiful, Tammy. Would you like to
Beautiful
sign
boy.
a contract?
Oh god. They're scamming people now.
Leave some morphine at my door, cause it would
Because
take,
it would take
a whole lot of medication
to overcome my heroin addiction.
to realize what we don't have it anymore.
Have it anymore.
There's no
There's no
religion that could save me. No matter how much money I get, I will still be a spoiled little brat. Oh ho 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 ho!
What's going
So keep in
on?
mind all the sacrifice. Do you know how much I sacrificed
To make
you
you
by
just
my
to keep you
side?
by my side. Just keep
Walking
you from
out the
walking out the door.
Cause there'll be no
Cause there really no
sunlight.
sunlight.
If I lose,
If I lose
you, baby,
baby,
there'll be no clear skies. If I lose,
If I
you,
lose you,
baby,
baby,
just like the clouds,
just like
my
the
eyes will
clouds,
do the
I will do
same.
the same.
If you walked away,
Walk away,
every day it'll rain. Rain, rain.
Oh, space berries. We're too good at this.
Yeah, winged pigeon. I have a.
I think we should become a very good duo.
Yes, I think I love you too. Your daddy can't even look me in the eye. Oh, if I was in their shoes, I'd be doing the same thing.
The same thing.
Saying
there goes my little girl.
With detective language that may violate Roblox's community standards, you may lose access to chat voice with
Oh my god.
violations.
Got a warning.
I was so. I'm
Got a warning.
20 years old.
Watch
I look
me
20,
change
that's
their
not so sad, I'm
minds.
17.
Oh yeah, you
Yeah,
I'll
guys.
try.
Oh my god, my ears.
And I'll pick up those broken pieces till I'm bleeding. I'll make it right.
No
There'll be
sunlight.
no sunlight.
If I lose you, baby.
If I lose you, baby, baby, baby.
This is
Oh,
nothing.
there'll be no clear
There'll be no
sky.
clear skies.
Baby, oh, if I lose
baby.
you, baby, baby, baby.
Oh my god, I
Oh,
When I was 13, I found my first love.
you walk away every day in a rain.
I think you
Rain.
can talk.
Rain.
Okay.
Raindrops keep falling on my
Huzzah.
face.
Huzzah.
Rain like creaming on my face.
Yo, chill out.
Wait, but now,
I like the
how do I talk and be
Oh, don't
Roblox?
just say
goodbye.
goodbye.
Just don't say
Just
goodbye.
say
Goodbye.
Wait, now after I
I'll pick
verify,
up
how
these
do I?
broken
Now
pieces,
what?
shove
Till
it
I'm
up your
bleeding.
till I'm bleeding. I'll make it right, cause
Okay.
there'll be no sunlight if I
Sun don't
lose
shine.
you, baby.
And there will be no clear skies.
What is that?
Oh, if I lose
okay,
you,
get out,
baby. Oh, just like the clouds, my eyes will do the same.
If you walk away every day,
Every
it'll
day
rain.
it'll rain.
Rain.
RGW 2020-11.
Actually,
Rain.
don't know. Try privacy and content restrictions.
Beautiful work, boys.
Okay.
Good job, everyone. We did amazing. Someone should be paid to watch this.
Communications?
I think I got number
Yeah.
one, not gonna lie.
No. Voice
May
tap
step towards you. Towards you, cause all that waiting is regret. Don't you know I'm not your ghost? Ghost
Oh.
anymore.
You lost the love.
Love most.
Social connection
I learned to live half alive.
Alive.
Live half alive.
This is
Alive.
Now
you want
me
now you want
one
me
more time. And
who you think you are?
Who do you
If I
think you
remember
are, boy?
there, maybe you
Running around leaving scars all
leaving
over my
scars.
post-it.
Collecting a jar of hearts. Oh my god, that's brutal.
Oh, visibility
Tearing
and
love
privacy.
apart.
Love apart.
You're gonna catch
You're
a
gonna catch a
cold. Cold.
Oh, never mind.
From the ice inside your
Inside
soul.
soul.
So you don't come back,
Come
for,
back
me.
for me.
Who do you think you
Who do you
are,
think you
boy?
are? I hear you.
I hear you're asking all
I hear you
around,
asking
boy.
around on these hoes. If I'm
Anywhere to be found, to be aroused, found.
to be found, I have
But
grown
I have
too strong.
grown too strong to ever fall back in
into
your
your
arms. I learned
My
to
ears.
live half alive. Now you want me
like
one
more
more
time.
time. Hey,
I'm so blessed right now. I
And
want
you
to take
think-
this
who do you
moment
think
to
you are? Running
my
around leaving
dad
scars,
into this world.
collecting a
I
jar
hate
of
my
hearts, and
ears.
tearing love apart. You're gonna catch
You're
a
gonna catch
stray
a cold.
This is
boy
real life
from the
karaoke.
ice inside your soul. So don't come back for me
I think
instead
you
of
should just
come
join
on
the game
me.
and see if you.
Who do you think
have
you
it or
are,
not.
boy?
Okay.
Dear. It takes so long just to
feel alright. Remember how to put back the light in my eyes. I wish I had missed the first time that we kissed, because you all broke all your promises. And now you're black. And now you're black. You don't get me black. And who do you think you are? Oh my god. You may lose access to chat with voice after multiple violations.
I think because you said black.
Oh.
What? Update my
You're gonna catch a
content.
stray from the ice inside your soul. So don't come back for me. Don't come back at all. Why? Who do you think you are? Who do you think you are? Who do you think you are?
Oh, you did it?
Allow. Oh my god.
You think you are?
I did it.
No, you.
Skip this stupid tutorial.
So you
We did it, guys. That was so amazing, everyone.
Clap for all of us.
Clap, clap, clap.
I want
clap,
you to
clap,
stay
clap, clap.
till I'm in the grave. Till I'm in
Till
the
I'm in the
grave.
grave.
Till I rot away.
Till I rot away.
And but buried.
Till I'm in the casket
you carry.
What is up, my gang?
Shut up, cute dog.
Bye.
Hey, don't pay.
You sing the song. Alright. Oh yeah, alright. Oh, please don't say nothing left to lose without me, baby. Oh, birds of the feather. We should stick together. I know.
Wait,
I said never. I wasn't better alone.
What
Change the weather might not be forever, but it's forever. Yeah, that's what I mean. Yeah.
What the fish?
It's even better, and I don't know. You know what I mean? No. What I'm crying for.
What I'm crying for.
I don't think I could love you more. It might not be long, but baby. Oh, I'll love you till the day I die. Till the day I die. I have a 5-minute suspension?
If you have
if
a
this
5
happens
minute
again, you may lose
suspension.
access to your account.
Oh
You guys
my
made a
God.
mistake, bro.
Why does he have a suspension?
Did you swear?
I don't think so. This is so annoying.
I throw you, but you're so full of it. Oh. Tell me it's a bit.
Why is that the
Oh.
karaoke screen?
What is
I'm
those-
polluted.
what are those dance
Say
moves, bro?
you wanna quit. Don't be stupid.
Can I dance?
And I
in-
don't
in
know
game?
what I'm crying
I
for.
disconnected.
I think I could love you more.
Keep it up, Gus.
Gus. Say goodbye. Till the day that I die.
You're singing your heart out.
Close my eyes. The day that I die. I knew you
This is-
in another life. In your eyes, I loved you. Don't
Wait.
act so surprised. I love you till the day that I die.
Oh, do you want to see my emotes?
Good job, guys. We did absolutely amazing.
Oh, I know the song.
That's it.
What's up?
Oh yeah, Wait, no, wrong song. That's not. That's Bruno. That's Bruno something. I forgot. Oh, can we do
that's
Begging?
Bruno
Oh my God,
Boss.
Begging's so good.
Oh, her eyes,
Her eyes,
make the
making
stars look like they're
like
not shining.
shining. Her hair.
pulls perfectly without her trying. She's so beautiful.
Beautiful.
She sells a
And I
seashell
tell her
by the
every
seashore.
Yeah, I know.
I know. When I compliment her, she won't believe me.
It's
So sad to think that she don't see.
But every time she
What
asks
is
me,
this?
I don't know.
What is this next to me?
Noise.
What am I
What the hell?
in?
Who is this?
Is that a panda? Oh, no, that's a cat.
Hey yo.
Just the way you are.
Just the way you are. I hear this like a ton at the gym.
Oh, it's weather. Let's do it. For a while. Cause girl, you're amazing.
Just the way you are.
Yeah. Yeah. Amen. Her lips, I could stare at them
Stare at all day if she let me. Her laugh, she hates me, but I think it's so crazy. She's so beautiful, and I tell her every day.
I need a mic here.
Oh, you know.
I've never asked you.
You know.
Perfect. What you're searching for.
I
Don't even bother asking if you look okay.
I'll say
When I see your
When
face.
I see your face, there's not a thing that I would change. Cause you're amazing. Just the way you are. When you smile, the whole world stops and stares.
Cause you're
amazing.
Just
the way you are.
Oh, my mic got wet. The way you are.
My mic can't pick me up.
Just the
way you are. When I see your face,
there's not a thing that I would change. 'Cause
They call me Bruno Jupiter.
just the way you are.
and when you smile,
When you smile, the whole world stops and stares for a while.
Cause you're amazing. Just the way you are.
Yeah. Yeah. Amen.
Ben.
Okay, who's this?
Burn.
Does anyone know this song? Wait, I think I know this, but
I know every song.
Wait,
I
I
know
can't
you,
hear
girl.
you, Mars. I can't hear you. I need to set my volume higher.
no, Mars got suspended.
No, Mars is still here.
Oh wait, no, you were Mars.
Yeah.
Oh, then Bruno Jupiter got suspended.
Bro, why can't I sing, man?
Chris got suspended, bruh.
This is a beautiful scene. This is what humanity is for.
This
what
is what
the
the
fucking
internet's for,
kind
guys.
of activity is this?
Why are we covering the screen?
So that nobody can sing.
Hey, hell yeah. Look at my butt instead. I feel like that will get me a violation.
I really enjoy singing the foreign languages.
Okay, let's do a French song.
Okay.
Can we skip this one, gang?
until you learn to forgive. Try
as hard. Oh, did we get to skip?
I know every song, man.
But you got suspended, cool.
They can't handle
sorry,
me.
girl, sorry, girl.
To flee the shadows of the night, it haunts me, makes me feel blue. But how can I try to hide, yo? When every breath, every hour,
every
50%
breath, every
skill,
hour.
100% power of will. I still end up thinking of you, yo. And in the end, everything we have me is yo, yeah? It's worth fighting. No. So I will hold for as long as leaf wells soon grow from the bareness of the trees, yo. Yeah, and all will be alright in time, yo. From waves overgrown come the calmest of seas. Yeah, from the waves overgrown come of the calmest of seas, yo. And all will be alright in time. Oh. And you never really loved someone, alright. Until you learn to forgive, yo.
Is that baby shark in front of me?
Yeah, it is, boy.
It's baby shark.
It's my shark, baby.
Shark. What's up, gang?
Where are you? It's been 5 minutes. Why can't I?
You need to leave and join.
I got ignored.
You gotta
by
rejoin.
4 people.
Guys, how about we have a private? Let's have a private karaoke.
No, we have to join the
This
others.
is way too fun with random people.
What's poppin', yo?
I agree.
What's poppin'?
Here.
Wait, I can't hear these guys.
Okay.
What am I seeing?
I'm the host. You can add songs.
Perdalam yang perna coraza.
Let me see.
What's
Where
poppin',
are you guys?
yo?
Are you guys in Danny's house? Oh wait,
Perdalam yang perna coraza.
这头在他欧万马，在你瓦里莫尼在你他在。
Taruki manis dalam dagan nanggangku jiwamu jiwaku menanto bergeraklah kerusakan.
Chris.
It's okay.
Hangatnya
Chris.
sentuhan kasihmu bawa aku penagniku. Oh shit, bro. Oh my god, I said a swear word! No! Is he gonna ban me?
Saratina. Yeah.
I got suspended for 5 more minutes, bro! Oh my god. Where are you guys?
We're in Danny's playhouse.
Oh. I see you, cuh.
Did that guy just break this?
天気はいいのに進めないに
Techie ni baku.
Techie nigger.
Techie wa ni ojisu manai.
Thank you, what's up, man?
What's up, man? Orubaku. Demi mono ofu.
Oryufu, Orubaku.
Orubaku.
Urubaku. N-P-Y no ni susumene.
Oh, I got second place, gang.
Whoa.
How did I get a score? I didn't even sing.
How did I get 8?
This thing is so rigged.
Hello.
Biggin.
Oh, I'm so good at this. Put your love in. Wait, what?
Put your loving hand out, baby. I'm begging you, yo. So put your loving hand out, baby, yo. I'm
begging.
begging.
Wait, what? Begging.
Put your
I'm
love-
begging you. So put your loving hand out, baby. I'm begging you. So put your loving hand out, darling. Riding. I'm not gonna get banned for saying riding. Walked away. You warned me then, but easy come and easy go when it was so. I need water.
Let's find that seed, let it be a grow. How many knees I'm begging? Because I don't want to lose you. Hey, I'm begging you. Put your loving hand out, baby. I'm begging you. And put your loving hand out, darling.
I
need you to understand.
Tried so hard to be your man.
I tried so hard and fire but in the end, it doesn't even matter.
An empty shell I used to be. The shadow of my life was hanging over me. A broken man,
but I don't know.
What even stand the devil dance to in my soul? So what are we doing? What
are we chasing? What are we doing?
You can change the volume in my settings.
This has to be racist, right?
Begging, yeah,
begging you.
So put your loving hand
out, baby. I'm begging you.
So put your loving hand out, darling. I'm finding hard to hold my own. Just make it all alone.
Mars, look at this. It's the guy from Yakuza.
And gonna fade into black. I'm begging you. Put your loving hand out, baby. Begging you. So put your loving hand out, darling. I'm begging you. So put your loving hand out, baby. I'm begging you. So put your loving hand out, darling. I'm begging you. Why? How long does this go, bro?
So put your loving
hand out, baby. Begging you. So put your loving hand.
Wait, what?
How is Dog number 1?
What the fuck? 99 scores.
I did all the work and I got a
get
score of 6.
99. You didn't even sing.
How does this work, bro?
Oh,
believer. First things first.
Let this here all
Not
the
yet.
runs in my mouth. Oh.
First things first, I'ma say all the words inside my head. I'm fired up and tired of the way that things have been. Oh, all the way that things have been. Oh. Second thing, second, don't you tell me what you think that I could be. I'm the one at the snail, I'm the master of my seal. Oh, the master of my seal. Oh,
I was broken from a young age, took my soul into the masses, running my home for a few that could be from my heartache, from the pain, taking a message, from the pain, taking a lesson, from the pain,
Pain.
pain,
believer, believer.
pain.
Break me down,
15 minutes more of this, I'm gonna get scolded by my mom. So like,
Believer,
pain. Let the bullets fly, oh let 'em rain. My love, my dog, my drive. Wait, Chris, let's go back to sing it. I want to get first place again.
I'm a believer,
Like
believer.
believer.
Actually, don't know the lyrics.
Third, send the prayer up to the ones up above. All the hate that you heard.
Has turned up your favorite
Your spirit up above.
I'm choking to the crowd. My brain up from the cloud, falling like ashes to the ground. What do I feel like they would drill around? What do I feel like they
Rain down,
break me down, you pain, let the bullets fly, let them
rain.
My love, my drive, it came from
pain. Believer.
last face, last by the grace of the fire and flames.
You're the face of the future. Blood in my veins. Blood in my veins.
but
limited
till it broke open and rain down,
rain down like
believer. Pain, you break me down, you build me up, believer, believer. Pain, oh, let the bullets fly, oh, let them rain. My life, my love, my life, it came from pain. Maybe a believer, believer.
Is your suspension done?
Let me leave.
I don't know how he is suspended and still got a score.
Who the Oh, I gotta be careful what I say. And now the end is near, and so I face the final curtain, my friend.
The final curtain, my friend. I'll say it clear.
I'll state my case, of which I'm certain I've lived.
Of which I'm certain I've lived.
Certain.
A life that's full,
so full.
I traveled each and every highway. I have no idea how the song goes, to be honest.
And more, much more than this.
I only watched the TikToks.
I did it.
I did
my way.
I've had a few. But then, too few to mention.
Here, Butterman.
I did what I had to do. It's how it
Hey, dog, start singing, yeah?
without exemption. I planned each charted course, each
Why are you so
careful
quiet,
step along the byway, and more, much more than this, I did it
my
I bit off more than I could chew,
But through it all,
when there was doubt,
I ate it up and spit it out. What the god? What the hell?
like how I did to you.
Hey,
I faced it all.
Gigaduck.
Gigaduck. Hello, Gigaduck.
Gigaduck.
What's up,
Gigaduck.
Gigaduck. Gigaduck.
He's
Say
a
with us.
Gigaduck.
I've loved and cried. I had my fill, my share of losing. And now, as tears subside, I find it all so amusing to think I did all that.
You can sing this.
Not in a shy way.
Oh no!
Oh no. Oh no, not me. Wait, what?
I did it my way.
For what is a man? What has he got? If not himself, then he has
not to say the things he truly feels,
and not the words of the one who kneels.
The
record
shows. I
took the blow,
and I did it
my way. I think your mic is not picking it up anymore, bro. Oh yes, it was my way. I think your mic cut out. Chris,
your mic got cut out.
Chris, your mic is gone.
Really clearly.
Can you hear me now?
I can only hear you in Discord.
Wait, what?
Yeah, I don't think Discord. I think Discord is filtering out your screens.
Oh my god.
Wow.
Cut number 2.
Oh my god, it's baby hotline. Oh my god.
You used to call me on the cell phone. Is it this one? Oh wait. Baby flatline, still time to do it too. Baby snack time.
Baby.
I'll come.
I'm gonna go ruin someone else's.
But I'll come back when it's still into you is up. All right. Oh, there's a party going on.
I did it my way.
For what is a man? What does he got? If not himself.
Start a song, boys. Start a song, boys.
Let's do some song, boys. Let's run it.
What's up, boys?
Prom nyo? Umaga prom nyo? Afternoon. Oh.
What if I went up to a random person and went like, "Hey,
Okay.
girl"?
I think you'll get banned.
I mean, malaki yung A.
A yummy puffy? Oh my god.
Ayaw talagang gumana.
Let's sing.
The Giga Chat over here.
Where?
Oh my god. Come over here. Oh, Giga Chad.
Oh my god, it's Giga Chad.
Look at him. Oh crap.
Oh my god, I'm
He's so
attracted.
strong.
Oh. Look at those dance moves. Oh my god, he's so strong. You got that crazy
Look
dab
at those
bod going.
panties, boy. Oh, I'm gonna get back on my...
What song is playing?
All the love that I give.
Let's go. Good job, Lazy Briar. You're so good at
Good
singing,
job,
man.
mate. You just won the Olympic thing.
Yeah. How's you doing? Are you doing?
I'm doing you, boy.
Yeah, puff ka muna.
Yeah, let's start a song. Let's start a song, mate, yeah? Hell yeah, mate.
Okay.
You pick a song, mate. Whatever song you want, mate.
Okay, let's go.
Let's get it, boy.
Yeah, let's hear that.
It's Giga Chad.
Oh, we're gonna have a great time over here.
Hey, Puffy. Look at Chano's avatar. He's Giga Chad. So handsome.
Whoa. Oh. Muốn natin ang iyong gabi, ikaw ngang pahinga kayo, mahal, lumiliwanag, kang ngiti kapag kausap na kita. Kapasang lang kong babalik natin kahit di mo ko hanapin magkalipilig lang sa'yo
pinapawi mo ang haho
ang hangking
o ang puso
malimlim ingkang pangingin mo parasing sa para mo na ako
ipapatid ko at sa'yo nga isa lang
ang hinahanap ko hanap ko ikaw raman kung papararin na mapapasakin ba kung san-san magkono magkambas paso halanggang mo lang ang tanging malaman hindi alam kung ba't mas sinunod mo pa.
This has to be racist. This has to be racist. What song is it?
Atin kahit di mo ko hanapin magpapalimpin masalama panpawi po kain po sana ba'y alam salalaykum pag napansin mo na ako ipaunawa ko.
Is he summoning these demons?
Hinihamap ko hanan ko ikaw raman kung papalarin na mapapasakin ba
Kung oh
what the
interlude.
Have a good time. 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I can't. Oh wait.
I can't. Oh wait, what?
Oh my god, I can't. Kana naman. Pwede bang sa akin lang. Kung mang akit. Akit ka na naman. Pwede bang sa akin lang. Kung mang akit. Akit ka na naman. Pwede bang sa akin lang. Isa lang.
Ang
hinahanap ko ang ikaw raman araman kung papalaran na papapas ka ba. We did it, boys! Hell yeah!
Wow, we sang so nice. 98. That's crazy.
I got
So
number
much
1.
passion.
We
You
did
did great
it!
too, Lazy Brile. You were amazing.
Hell yeah!
We did it. Yeah, hell yeah, we did it. Let's go,
We
Lazy
did it,
Brile.
girl! Hell yeah, girl! Diva Queen!
Slay.
Yeah, oh my god, yeah.
This one next.
I want to do more foreign songs.
No, nothing. In game.
Let's sing with this guy, Lazy Brile.
Let's do it, Lazy Brile!
Body
Roblox,
Let's do it.
What's up, boys? If you could return, don't let it burn, don't let it fade.
Oh,
I'm
God.
sure I might be rude, but I got a 5-minute suspension. You got another
Ruin me
suspension.
everything. I swore, I don't know this song.
Just wing it. So why were you holding me, her hand?
I
Is
will
it
be
the way
back.
we stand? Were you lying all the time? Or was it just
like
a game
30
to
minutes.
you? But I'm so deep inside you. Okay, whatever.
I swear the last time I left here it was this song.
Yo, Lazy Brile's following me.
Yeah, Lazy Brile's having fun.
And our lovers,
Love's
only one worth
only
fighting
worth
for.
fighting for.
Wherever you
Wherever
go.
you go.
That's what I
Wait,
follow
this is
for.
Fabulous, no?
Nobody
Hello,
promised tomorrow.
nobody's
So I'ma
promised
love you every night.
tomorrow. I'ma love you
Like-
every night like it's the last night.
Oh,
Like
it's the last
night.
If the
If
world
the
was
world is
ending, I'd wanna
ending,
be
I wanna
next
be
to
next
you. If the
You're
pie.
suspended, Space Berries.
Well, I still want to enjoy this. Ooh,
I wanna hold you just for a while. And I with
smile.
a smile.
If the world, was
was
ending, I'd
ending,
wanna
I
be
wanna
next
be
to
next
you. Oh, right next. Wait,
right
what?
next to you.
Next to you.
Next to you. Right next to you.
Oh.
God damn, 666 Kev. You're crazy.
God damn,
Crazy
man.
good at singing. Yes, sir, Crazy Kev. I mean, 666 Kev.
Crazy Kev. If the world was ending, I'd wanna be next
to you. If the party was over and our time on earth was through, I wanna hold you just for a while. And
Smile. If the world was ending, I'd wanna be next to you. If the world was ending,
then I wanna be next.
I don't know.
Ooh. All right, I'm out.
Where's Q Dog?
I think he left. Is he still on the server?
He couldn't handle us.
He couldn't handle the power. Man.
Oh wait, there's an English version of this. 上前抱住，金王长烟上朝为上冲，国内呀那抽烟就garam gondoro，那个
I can't say that.
Abando Yawa Sergio Joyo Jorin Now Ponil Nandong Jay Masio Dro Now Jernan O Kyoto Piano I know my still anh hay trong khối Yorio Iyagi Young one more than
You have no idea how funny you sound without the background music.
It
sounded like it sounds like you made up a new language and just like went. It sounds like you made up a language in your own religion.
They created a what is it? A cult?
Yeah.
Where are you? Wait, I'm gonna rejoin.
I'm back in there.
Wait, should we join like those talking chats?
Oh my god, we should. No, let's do neighbors. Let's do neighbors. Wait. Join me. Neighbors. It's like where you connect to random people.
Oh. Let's rizz some boys up.
Yeah. Should I do the voice changer?
Oh, good, do it.
I need to like
connect, boy.
Oh, people in this game are so bloody boring, bro. Jesus Christ.
Is he talking about me?
Hello.
What?
Ni hao. That's not even China. You
你好啊，
racist.
兄弟，
Okay, I'm
兄弟
back.
你好，
It's Hong Kong.
你好啊，兄弟，
Hong Kong.
We're on
你在说
neighbors.
什么呀，兄弟？
你好，
我听不懂你啊。
Hong Kong.
你是 how are you？
Or
What is going on, mate? Are you okay? You having an aneurysm?
Wait. I need to plug in my voice
Are you
changer.
okay?
How are you？
Sounds like it's
wait, where are you right now?
兄弟 ，no English。
Wait, hold on. Wait. I'm plugging in my.
I want to know. Teach me Hong Kong.
I
wanna-
can't
wanna-
find you guys.
OK， OK， 屌你老母 ！Say 到屌你老母 ，it mean hello。
Loud demo.
屌你老母
What? Why did it sound so wrong?
！Oh my god! I got Smith.
Test. Oh, Kristen, please watch me play.
Okay.
Why is it's so high pitched? I have to fix it. Hold on.
Why do I have to see?
Test. Oh, this sounds good, right?
I couldn't
Actually,
tell
what's
that
wrong?
you were bad. Oh my god. Okay.
Test. Oh, this is good. All right.
Let's do it.
Oh my god. What are you doing?
We're doing neighbors.
Voice
Oh
changer.
my god.
I'm gonna pretend.
Hello? Hello? What? Can you hear me?
Is that a
Oh my
new
god, it's just a
baby?
kid.
再见了，小朋友。How do I skip? Or is it like a limited time? I think you go next round random, like to a random time, right? Hello? Oh fuck, my foot trapped. Shit.
You're gonna get it. Oh,
You're gonna
you're
get
gonna
banned.
get suspended.
Oh, I did. The voice changer says Rob.
You should just skip.
My flight cramped. Next one, let's go. Why is it calling you bad? Like last time I used it, it's decent. Like I just speak normally. Hello again.
Is there only you two in this server?
I don't think
Bro,
so.
just now I pretended to be a Chinese guy who didn't know how to speak English. They fell for it. He thought he was having a stroke. Wait, let's pretend to be Asians, like heavy Asians who don't know how to speak English.
Wait, let's all
Wait,
three be
wait,
Asians
let me-
and
let
then
me-
we go to the same person's house.
Yeah.
I think I'm very Chinese servers.
It's the same person?
Oh my god, it's the same guy.
It's the same guy. Can I select servers? Oh, it's kind of slow.
What?
You can, yeah.
What? What do you say my name?
American.
English servers. Yeah.
Is it fish?
Aussie. Should we do Aussie?
Yeah. Try to pretend to be Australian.
Oh my god.
Oi, mate. Oi, mate.
So what's poppin', mate? Yeah.
Damn, I got crickets up my bum. Crikey.
What's poppin', mate?
That's good. Hello? Hello? I didn't even get a chance to talk.
What's poppin', mate?
Oh, hello. I keep on getting rejected. What? Hello? Linger Gooly. Nice name.
I'm yawning.
They're all
What's
kids,
going
bro.
on?
Are you allowed to say that?
One
What's
wing
up?
pigeon. Yo, what the hell?
Hello?
600. Of course, money.
Hello?
English.
Yeah, we can hear you loud.
Pigeon, yeah. That's my name. Hello?
Are you a guy?
Average Roblox.
What?
Car physics.
Are you a guy?
No. I'm a boy. I'm not lying. I'm not lying.
Issues.
Nah,
Emma, what
I'm
did
a
you want?
boy. Trust. How you guys doing?
Hello.
sucks.
They skipped me.
Oh my god.
Hello, dude. Hello, no English. Why you are laughing at me?
I do love myself a little Asian boy.
Oh.
Get me out of here! This Chinese, this Chinese grandpa's trying to get me to his farm.
Oh, open door. Open door.
You might get a Caesar soon.
Oh, no, Caesar. Doctor say no. How to open the door?
You right click.
Okay.
Yeah, right click.
How to see the left and right? I know my left and right.
那他妈你就去躲躲。
Oh no, say that, no say you get banned, boy.
I can't speak Chinese.
No, they banned me for say the Hong Kong bad word.
What is the Hong Kong bad word?
Oh, you tell me,
How am I supposed to know?
Because I.
When you locate to another Australian server and there's no more Australian servers.
Hello, people.
Hello?
Why they keep skipping me, bro?
Hello?
Hello, sir. How are you?
He's mad autistic.
Whoa.
Shut up before I eat you, dude.
What?
Oh,
Is that a voice changer?
Oh, they know it instantly.
Yeah, it's a voice changer.
Okay. Yeah, it's kind of convincing.
Sure, it's AI.
Oh, that's the person that skipped me. Oh.
Hello? It's
the kid again.
Hey, dude. What's up?
What's up? The real
Hello?
question is, are you a girl or a boy?
No, I'm a boy for real.
Don't lie to me.
No, I'm not lying. I'm a boy.
Okay. You should invite
What you doing?
more people.
How do I invite more people? I'm kind of new to Roblox.
I don't know either.
Oh.
What's poppin', mate?
All right, let's go next.
Oh, 你好.
Nina.
Oh.
Nina.
Oh, hello.
Hello, Nina.
I am Chinese. No English.
I want to see Chris's POV.
No English.
Sorry, I don't understand you.
Chris,
Nina.
can you stream?
Do you
I want to see.
Oh, wait me 5 seconds, okay?
Oh, alright.
Wait me 5 seconds. I do something important.
Beat her ass. Let me hear it.
Bury me inside. Lay me down on
It's her.
Oh, beautiful voice, okay? Very beautiful voice.
Stop it! Like stop the accent. You're not Chinese. I
Oh,
know that.
that's not very nice.
我不是中国人，你觉得我在骗你吗？I Chinese, okay? I real Chinese.
You're not a cannibal, right?
What I need?
Oh, you love me? Oh, ho, ho. You very good Chinese, okay?
谢谢。
Oh, you learn Chinese?
You're not Chinese.
I am the Chinese 50-year-old.
What?
You're not.
Hello?
Yes, I am 50-year-old. 51 next year.
Your accent is changing. Like what the hell?
No. No.
You're laughing. No, it is. I
Yeah,
am
one
Indian.
link
You know
pigeon.
that?
Why do you not have the accent?
I have the accent. I wasn't.
No,
saying
not
it
chicken wings,
earlier.
not chicken wings.
Why do you not have the Indian accent?
I have the Indian accent. I'm speaking
Chicken wings?
in Indian accent right now.
I got a vegan.
Oh, very good. I don't know
Yeah,
how
I
to be Indian, but I know I am Chinese. Okay?
Yeah, I used to eat it, but I've been.
You are Indian as well. You have a good Indian accent as well.
Thank you.
Look
Thank
at
you.
KFC, bro. I'm vegan.
If I die.
Yeah, I'll eat these veggies.
What are you singing? What are you
And fish,
singing?
because I'm a pescatarian.
Frozen. No, I'm not
Very good.
singing. I'm dancing.
Oh, very good dance.
Very good to dancing. Do you like the dance?
Very good. Very better than me.
Very
Oh,
better
girl.
than
I'm
you.
very
Am I better than
I'm
you?
30 years
voice.
old.
You said that you were like 50. That's
Well, yeah.
pretty. I don't know. You're changing a lot.
Yeah, yes. Oh, tomorrow I turn 50, but today I'm 30.
No, you told me that you will turn 51 tomorrow. And
Oh,
you are
yes,
50
yes,
today.
51
You're
tomorrow.
changing a lot. You're
To
contradicting yourself.
no, my math not so good. Can you teach me?
Yes, 2 plus 2
What's
is
wrong with my
5.
name?
2 plus 2 is 5. Oh, I know. 30
It's
plus the
Coco.
1 is 51.
What's 9 plus 10?
I think according to
21. Say
to
21.
my calculation is 21. Do you think I correct?
Yeah, it's
I
AI,
think
it's
you
AI.
are lying. Like, what? Why are you doing that? Like, you're not even a Chinese and you're acting like Chinese.
Yes, I am Chinese. I'm Chinese.
You're not Chinese. I know that you are not Chinese.
Yes, look at my flag, bro. Look at
You're
my flag.
Indian now. Look at my
Wait,
flag.
you want me
I'm
to turn it
Indian
off?
as well.
Alright. Hold on.
I'm Chinese. Look at my flag. You know the flag, right?
Yeah, what's up?
Oh, you're changing the accent. Oh my god, you almost slipped. Oh, that was.
Sleep.
Hello?
It's sleep water.
The slip means that you are falling.
Test?
我是
You hear me,
Chinese.
right?
你知道吗？
In a Chinese, it is meaning.
No, it's just like my internet's really bad.
What you say? You say
Yeah,
again.
yeah.
You say I can't do this. You say again, please.
So it is hu dao in Chinese, if you know Chinese.
What?
Hua dao.
What?
Your Chinese very bad. Okay, very bad.
Hello again.
I cannot even understand your any Chinese. You know.
You just told me that was good. What I need.
Oh, you
Chris,
you.
I'm gonna
Okay,
I'm gonna
very
do
very
Charlie
good
Kirk.
Chinese. This very good, very good.
Hold on, hold on.
Oh, very good, very good. This is very good. 非常 good.
你好。
对对对
Yes.
对，你好。
Hello?
No, you're not Chinese, are you?
我 yes yes 我是 Chinese 我是纯正的中国人，你懂吗
No, you're not.
But
Wait, you actually understand? 你真的听得懂我吗？你真的听得懂我吗？ What you say just now? Hello?
oh god.
我懂中文。
Oh!
Hello.
Oh,
I'm trying to
very
find
good.
a Chinese guy.
Very good. Oh my god, stop with the accent. Oh my god, that's
No
No.
accent.
so funny.
It's my normal voice.
No accent. Is that your real voice?
You look beautiful.
我是中国人。
Do you know what I'm saying? Do you understand my accent right now? Do you understand this accent?
Yes, I understand. I understand you.
You understand me now. Why are you suddenly Indian?
Because sometime I have personality
Hello.
disorder.
Hello?
Yeah, multi-personality
I'm
disorder.
not good at it.
I have multiple I have
does one spend
multiple
170 hours in this
personality.
game?
I'm
非常多的
finding the Chinese
personality.
guy.
Hello?
He has
That's
like
not good.
blue hair and pink skin.
Hello?
Why you pick me up like
Yeah, I'm trying
a
to
doll?
find someone.
You
Dude, I'm
crazy
gonna
are you?
directly
You crazy?
teleport to their house.
Put me down. I have very bad back.
I don't know.
Very
just
hard
skip
back.
until I get him.
I'll throw you from the rooftop.
No, you kill
Yeah, I
me.
can speak Chinese.
Oh,
Oh.
my back. Oh, my back.
Okay.
Stop it, bro.
You break 你 break 一个 old man 的 back. Oh, you do again, huh?
What's going on?
You're very
你
funny.
你
Oh
break
my
我的
god,
back,
this is
huh?
very funny.
You laugh at the broken back?
Oh my god.
Stop it. I don't want to laugh so my stomach hurts.
It costs a lot. It's okay. I
You
can
put me
get
on
it.
chair.
Thank you.
You
Stop
how
it.
you
You're
carry me like
actually really
this?
funny.
How you carry me?
Funny.
How you are carrying me like this? Why you this dangerous? This my back.
Whoa, Freddy Fazbear.
You broke my back again. 5 broken bones, spinal.
Ni hao.
My spine is broke. You do again, huh? You crazy?
I'll keep you in the bed. No, I'm not crazy.
Yes, you crazy. You break old man back.
From Australia. My neighbors are from Australia.
I know what's happening. Wait, let me join in the fun.
What are you doing to me, huh? Why are you jumping with me on my back?
I'm gonna fix my sleep schedule. I
want to join in the fun.
I'm gonna fix my sleep schedule, guys.
So many people talking right now. I cannot hear anyone.
Oh, I can't. Oh, I want to see.
Why you find me fun? Why you hold me on my back? You already break the 5 bones. Very uncomfortable for me.
Connect.
Stop.
Why
Who
you
the
have the
fuck is-
jumping coil?
Because I love jumping.
What is this game? How do I find my friend? How do I join you?
It's like a dating game.
Is it
Supposedly.
dating?
Oh.
Is dating?
So many
I don't
people
know.
talk at the same
Dating?
time in my head. I cannot focus on any.
So is it the Indian talking or the Australian guy or girl talking?
How do
or
I
is it
Yeah, mate, the
use
Chinese?
Australian is bothering me, mate.
Oh.
He's. I haven't found him yet.
You're finding Chris?
I am
Oh.
in VC right now,
No,
very
I need to
noisy, so
buy
I
in
cannot hear you. I
fights.
apologize.
Wait, I'm gonna go to sleep, guys.
You can't hear me?
Good night.
All right, night.
But
I cannot hear you clearly. There is many
Wow.
people.
There's a person
What?
screaming.
What music is that? So elegant.
Like skipping
roleplay.
until I get
you
him.
would have known that it was Chinese.
Okay. Oh, fuck.
哇，非常漂亮
How
的
do I
音
play
乐
this
啊！
game?
Oh, so beautiful music.
Oh, what the fuck?
Oh no! Oh no!
This-
I'm going. Ah!
This, oh, this music very beautiful.
Hello.
This music is very beautiful. Beautiful music.
Very beautiful, right?
Very beautiful. Very beautiful man. Very
Hello.
beautiful man. Oh my god. 我都快要哭了呀
What you say,
I almost
I don't
I almost
understand,
giving
yeah.
up, you
Wait
know?
20 seconds. Hi.
Oh, what about Hindi? Do you like Hindi songs? It's my song.
Oh,
You're
whoa,
Chinese,
whoa.
I'm Hindi.
Hello.
It's my song.
Oh, voice chat works.
Wait, I turn off the other
Hello.
people
Good.
voices. They're too loud.
Alright.
Using voice chat.
Oh, Hana he's Hana he ha.
No, sorry, I don't know the lyric.
So clearly to me, you are the Indian because you have many Indian cultures.
Yeah, I don't know.
Very beautiful music.
Stop it! You're so
Stop
funny.
what? You want me to stop my speaking?
Yeah, I want you to stop your speaking because I don't really like hearing you speak.
Oh,
It's annoying.
Very good accent, you.
I'm Indian, so I obviously have a good accent.
I'm scared.
Very, very good of your accent. I give 10 out of 10. 10分.
I give you 2 out of 10 for trying to be.
Oh,
Chinese,
you.
I don't know.
Why you are insult me, huh?
No, this is. No, I love this Chinese song.
Shadow the Hedgehog.
You listen to the Chinese song.
Yeah, I love them.
Do you know how to sing them? Oh, very, very beautiful. 非常的 beautiful 啊。There is tears going down 我的脸。Oh, very beautiful, beautiful.
Yeah, it's really beautiful.
Why you have such a American accent?
It's my first time seeing this video.
Because I am. I don't know.
Do you go to the international school?
I go to Indian school.
Your legs are like dancing around and stuff.
那为什么你的英文非常的美国化呢？
Very funny.
What is that? What does that mean?
Why you are so whitewash?
It's
Why
okay.
you? Oh my god, that's so
I'm trying to find the Chinese man, so I'm gonna go.
Oh, I'm gonna die.
Why? No, don't die, don't die. It's very bad for the health.
Diane is bad for the hill. I didn't know that. Thought Diane was good.
I
for
give
the
you the
hill.
Chinese wisdom.
Hello.
Oh, Chinese wisdom.
我
Is
的
it like, do
功
you know
夫
kung fu?
master
Or do you-
teach me.
Explain myself. What did I say last time?
I watched Shaolin Soccer. I watched Kung Fu
Oh, very
Hustle.
good movie.
Yeah,
you were?
I love Kung Fu Hustle.
I'm sorry.
I know some moves, but I don't have it here.
Wait, you say you know the move? You know the kung
Country
fu
is
move?
yours. It looks similar to mine.
Yeah, I learned Kung Fu trained under Master. I don't know what's his name was. Master Shifu.
You know the Shifu meaning is just master.
I'm from Hong Kong.
Oh, really?
It's Hong Kong.
Shifu is mean the master.
Yeah, it's a very.
Do you know?
No, Zhang Wu.
place.
What?
Shang-O. Shang-O.
生活
Yeah, like below.
Zhang Hua.
your accent your accent is too American.
China. I'm gonna get
Xiangxin.
arrested for saying this. Hong Kong is not China.
Your accent, my accent is not American. It's not.
Very whitewash. 非常 whitewash. You know when I talk to you, I think your flag is fake because I think you are a white person.
How do you know that? That's not true.
I know many things, okay? I think I know you are a white person, not real Indian.
No, I'm Asian, but just whitewashed. I don't know. Like you said, maybe.
No, I'm not in school. It's
This is
actually
very sad.
12
I am
right now.
I am professional Chinese, you know?
Oh,
You're
time to do
not. You're
Wordle.
faking the accent.
Wait, I'm gonna
like
do
you're
Wordle.
not.
No, I professional Chinese. I promise you.
I'm gonna get it in
No,
one
I don't
try.
believe you.
You sound very tired. Do you want to move on to other the people?
Do you want to move under the peacock? What do you mean?
Do you want to move on to other the peoples?
Oh, I don't know. Yeah, maybe you should try talking with other people. Chinese Nian.
对，我就是一个 Chinese man.
I can't think of a word.
Why you pick me up again? Huh? You think this is very funny?
No, I didn't get it.
I think it is. I think you're really funny.
You
So,
think
I
break
guess
my back
thanks
is
for-
funny?
Thanks for making my night. It was really fun to meet you.
Oh.
Space berries
This
was
word
taken.
sucks.
Oh, I should write something
word
for you.
sucks.
You don't have any comment. What should I write? 50-year-old Chinese.
Very thank you.
Very thank you. Wait. Don't skip me. I'm gonna write something on you, and you can skip me.
Oh, I'm missing one letter.
Why you sound so white?
I don't know. Do I sound white? I don't know. Do I?
You really sound white. You sound very white.
You sound Filipino. Philippines. Like, are you Chinese or?
I typed the same word twice.
I'm from Hong Kong, you know, the city, the Hong
You're
Kong.
just changing the accent again. Oh my god.
Because
Because
I have many language under my skill set.
I think you're Filipino or Indonesian. I don't know. You sound more like that.
I got the
Bro,
first two letters.
look at my flag. It's literally Hong Kong.
PMO.
You can change that like I did.
Wait, you're actually wait. You're white. You're from America.
I'm not.
Wait, but you said you changed your flag.
I mean, I don't know.
What do you mean you don't know? No, wait. You've been lying to me this entire time?
No, I'm Indian, really. Namaste. How, आप कैसा है?
Oh my god, you're fake! You're fake! You're not Indian! You're actually fake! I'm real! You're fake! What? Now the table is turned, what the hell?
No, I'm real Indian, like namaste.
You only know a few words!
No, I know. Namaste, aap kaisa hai? Timi.
That sounds Japanese, bro. That's not Indian. Do you know the language of Indians?
I do. It's called Hindi because I'm from India.
I don't believe that. That's
I'm
not
from
that's
India.
not true.
I'm
You're
from
white.
India.
You're American. You're American.
Chris,
It's not.
let's go on a
Like,
date with
it's no, it's I'm not really.
Chris. Where?
How do I find
50-year-old. You're
how
Chinese.
And the
The
girl.
thing
I
is
want to
pretty
talk to the
good.
girl.
对，我是 Chinese.
Chris, let's be in a party, man. Chris, be in a party.
Method acting.
Wait, I add your friend, okay?
No,
What are you
I'm not.
talking like?
I'm Indian.
Chris,
Do you
let
like
me hear your
Indian?
party.
Like,
You yank.
Wait, my friend asked me to join party. Do you want to join?
yeah, can I see
Why
how
are you talking
your
like
friend?
that?
Wait. I need to write something for you though.
Write very fast. Oh, where can I see?
Oh my god, there's two black men surrounding me.
50
Chris.
50-year Chinese method acting. Hey, it's not acting. It's not acting.
Can I join your party,
It is. Oh my
Chris?
god, so annoying.
I got suspended for 5 minutes.
Do you want to 加入 our
Chris.
party?
Stop declining my
I want
party.
to join your party. I want to hear how your friend sounds like. Like, let's see if your friend got some method acting as well.
Oh, okay. I call him. Okay. I give him a call on the cell phone.
The fuck?
You give him call on the cell phone. All right.
Kira,
I'll be waiting.
send party invite to some say
Wait,
some.
can you send party invite
Can you stand still? I look at your name to invite party. Kira,
Some say,
invite.
some do. We already
Say
added,
some do. Say some say some do. Some say some.
How do I go to my home?
Some say some do. Some say some do.
How do I go to my home?
Oh, okay. I invite my friend. Invite you to the party. We both join. Okay.
Wait.
All right.
How do
Let's
I go to
see
my
how your
own
friend
house?
sounds like.
You white girl. You are a white woman.
No idea. I'm figuring that out. I'm just jumping around. I'm muted, but I'm jumping around, just like getting harassed by different. Oh god, that person is horrifying. Holy
Oh,
shit.
very
Get me out of
beautiful
here,
song.
please.
非常美丽的音乐，
Get your own like
What?
home or something.
非常美丽
Can have a party.
What does that mean?
，very beautiful.
My voice? Oh my god! Thank you.
No,
so
no,
much.
the song. Your voice very
No,
average.
My voice is very. No, my voice is very beautiful, right? Thanks a lot.
You are
Yeah,
you are
I
white
know.
voice. You are white. You know
I
Indian.
know. More Hindi.
Stop ignoring me.
You are not Indian, bro. You are not Indian.
I am.
Can I be invited? Chris, let me.
Oh. More.
Wait. Let me ask.
Birthday ho. Birthday
Chris, stop
Hindi ho,
ignoring us.
Indian ho.
Yeah.
That's Japanese or something. That's Japanese. That's gotta be Japanese.
Are you speaking? I can't hear you.
Hello.
你好，你好。
आप ऐसा कौन कह रही हो?
你好，
बोल रही
你
हो?
Oh my god. Can I join
Ni
one
hao.
of you guys?
我是
Just join our party invite.
How? Where is the freaking body invite, man?
你好，你好，你好，你好。Do you hear me?
Wait, invite
Do you
me
hear
too.
me?
Can you invite?
I invited you.
No, let me invite you. What's your name? Your name is
Did someone
Space
invite me? I'm not receiving any.
Space
Oh, when is the party?
Berries. I don't know.
Hello, hello, hello,
Party?
hello, hello.
And then invite your friend.
Yes.
Why don't you join her?
I can't find your friend. Q something? Was it Q something?
It's wow, it's a cutie.
Can you repeat the username? I'll search it again.
And Eva, please.
Wow, a cutie. Wow, is he in the server? Oh, it is. Is it she or her? Because she or he already belongs to a party.
You can't
Can
say
you talk like your accent? I love your accent.
Can you hear me? Can you hear me? Okay, invite the Q is wow is a QT, and then invite Ermiva. Ermiva, ERMEVA. Yes.
Oh my god, I got it. Shh. Okay. Shh. Listen to me. Your friend is already in a party.
Oh, Kira, you guys are in a party.
We're not in the party. We're not in the party.
We're not in a party anymore.
No, like
They no longer in the party. Okay, you invite them again.
I invited her, him or her. Is it a him or her?
Oh.
One him, one her.
But that's there's only one person.
One him, one her.
The other one.
What is that?
What's the name of the other one?
Ermiva.
So where are you guys?
Wow, it's QT and Ermiva.
Ermiva. Where's Ermiva? I can't find her.
Allow me to search.
Hello, my friend. I'm from India. Where are you from? Are you also from China? Your friend is not talking like 50-year-old guys.
I'm from planet Earth.
Are you from China?
你说什么？我不知道，我看不懂英文。
What was your friend? What is your friend saying? I don't understand your friend.
Do not redeem.
他说什么啊？ 他说什么
？Invite me.
你可不可以 add Eva？
What？
谢谢。
QT
Eva。
Do you hear me? Hello. QT, why are you speaking Chinese? You are not Chinese.
你说什么？我是中国人。道理吧。
Whoa! Don't swear. You're gonna get banned.
Can you add your
Chinese swears?
Can you add your
They recognize Chinese swear. Oh.
Yes, they recognize the Chinese swear. Where is the Ermiva? We cannot. How to invite her? This is crisis.
Well, I got her.
We are all very Chinese, okay? We all from the China. The Great Wall of China.
I'm from India.
No, you are white people. You are America.
I'm finally here.
我要冰淇淋，你要不要冰淇淋
I'm from India. Hello, girl.
I'm finally here.
Stop speaking in English. We are all Chinese, okay?
Oh my god, this is so noisy.
This person she not Indian. She is America.
I am Indian. Like,
You are not Indian, bro. You are not
你
Indian.
不是印度人啊
Oi, you yank! You better stop lying to us, yeah?
You liar.
You don't want us to forget.
You damn you liar, yeah.
Yank.
Should we skip? Like, should we find other friends? Since we'll be like together, even when we like skip, right?
What?
The power of friendship, yeah?
Yeah, we'll
If
skip
we
and let's
skip, we'll be together, right?
Yeah, we will be. We will be.
Okay.
Don't worry.
Let's.
We're gonna be together. Hello, Ori.
奥利奥啊！
Hello.
Why more so you let me in, yeah? Oh,
There's so
let me
many of
get in,
you.
yeah? Oh, I'm in.
奥利奥，
你好，
Why
我
you
是中国
green,
人。
yeah? I'm green, yeah?
Yeah.
奥利奥
I'm
，do
green,
do you
yeah?
know that we
I'm
are
green,
all
yeah?
Chinese?
Yeah, we are Chinese.
I'm
What
Indian.
kind of fruit is this?
This is the mango
我
fruit.
们是中国人，
我也是中国人，
我好喜欢冰淇淋。
我们都喜欢冰淇淋，
你好，
我们都喜欢冰淇淋。
So cute. Good night,
你好，你好。
我现在在中国，我现在有冰淇淋，我喜欢冰淇淋，我最喜欢冰淇淋了。Oh my god，冰淇淋！
速度与激情
要不，要冰淇淋？
速度与激情。
我们是中国人，我们是中国，我爱中国。
Cutie.
Oh no, she kicked us.
Hello.
你好，你好。
你好，你好，我们是中国人，我们是中国人，
What are you doing?
My ears hurt.
我们都是中
我
国人。
们是中国人，
Hello, how are you?
我们爱冰淇淋，你爱不爱冰淇淋啊？
你喜欢冰淇淋吗
Tasha, how are you, Tasha?
陈立邦，
杀！
？Oh my god, you're gonna get banned.
我们是中国人。哦，
Oh no, they're
你好，你好，你好，你好，你好，
你好，我
你好啊，兄弟们，我们是中国人。
你好，你好，
你好，我们是中国人。
我最喜欢冰淇淋了。
我们喜欢冰淇淋，我们喜欢冰淇淋。
我们很喜欢冰淇淋。你好，你好，我们是中国人。
我们是中国人，我们是纯正的中国人。
Hello, how are you, Flash?
No.
I love you. Please speak.
我好喜欢你。
Oh my god, you picked him up.
Oh.
How you have superpower to pick people up?
你好，你好，你好，你好，你好，你好，你好，你好，伊亚丽娜，我
艾丽安娜，艾丽安娜，
中国人，
Elena.
艾丽安娜，
我们是中国人。
艾丽安娜，我是一个非常大的粉丝。
你喜欢冰淇淋吗？
我们是非常大的粉丝。我是你的粉丝。
我们是你的粉丝。
是不是？是啊，
我们是纯正的中国人，都是你的粉丝。
Translation, I am your fan.
Well, I can understand some because I took Chinese in my senior. I took Mandarin.
Oh, very good, very good. We meet the other Chinese persons.
笑笑。Oh no.
雪花飘飘，北风萧萧。
你好，你好。你是我的小苹果。
花飘飘，北风萧萧。
This is very beautiful party, you know.
I don't know the lyrics actually.
你好，你好。
This very beautiful party, you know. I'm very tearful.
What kind of fucking party is this?
Whoa! You don't swear, bro.
你不可以说 FUCK 啊。
哦，对不起。
Why you are laughing at us? You think Chinese is weak? You think the Chinese people is weaker than America? I tell you, later the Xi Jinping will send a nuclear bomb to your country.
Yeah, it's not American.
Space, you know
He's
what's
from
going to happen
Australia.
to young boys like you, Space.
She is American.
Better watch out, Space.
No, he's from Australia.
You know what's going to happen.
You know the Chinese will send no. Wait, I want to watch the stream.
中国人 no no you cannot do this you cannot do this I don't know how to do the Chinese accent, bro. It's actually so bad.
You think of you think of the Chinese person talking, and then you pretend to be the Chinese.
Oh my god, it's the Cantonese guy.
Hello.
Hello.
Hello, how are you?
Leho.
How are you? You're also Chinese.
我们西相处的西桑桑，我จะ来。
小苹果。
I don't know how to sing that song.
I don't know either.
Suspended so they can't hear me.
What are we supposed to do?
Wait, he got a bird.
5 minutes.
He got a bird shoulder toy. He got a bird shoulder toy. You watch Burr?
Yeah.
Oh my god! Oh my god! You watch Burr?
This poor pink.
I love his videos.
This pink man is suspended.
Yeah, this pink man is
stupid pink
suspended.
man.
Our favorite Chinese man is suspended.
Yeah, our favorite Chinese is suspended. It's really sad, honestly.
Yeah, we have to wait like 5 minutes. I'm Chinese.
What? I didn't say anything. I'm gonna get suspended next. I didn't even say anything. I'm just speaking normally.
My sister typed that.
He's
He is gay.
Don't listen to him.
I mean,
he's
he is
gay.
yeah.
Gay, yeah.
It's real.
He's the G-A-Y.
Wait, can he hear
if you know
us?
what I mean.
Please. That's what we-
I got suspended too. I was just playing the piano.
Oh no.
Well,
we all got suspended.
you got suspended. Roblox, you're racist. If you can hear me, fuck you. Now what, guys?
I don't know.
Wait, we need to be with this person.
I want to go harass other people.
We're talking Discord.
In different games.
Wait, ask her if she wants to join Discord.
Don't ask. Also, is your sister really here? Oh, okay, cool.
Yeah, are we actually gonna ask her to get on Discord?
It's the only option. And then we have to all pretend to be Chinese.
Chris's sister. Should I draw more porn of Chris?
She what? What?
Do you want me to draw more sexy pictures of Chris like last time? Should I do
I've
it?
seen enough.
Okay.
Wait.
Wait, can you show me?
You want to see the? Hold on, let me get my iPad. Draw Chris pregnant.
Great. Bigger is better. Yes.
When are they gonna be unsuspended? You guys want to play like a different game, like a different voice chat game?
Yeah, maybe. I don't know though.
Also, I got a new follower on Instagram from this, so
Oh my
I
God.
won't complain. Yeah, he's from Australia, and he wants to come to China.
Oh,
And he's,
very good.
What else? He's black. He's black as well. Yeah, I got his Instagram.
Black Australia.
Well, time to draw Chris Gay. I mean,
what?
What? Nothing. I just said time to draw Chris as a beautiful man. That's what I said.
Oh, where's the guy? Space, come here.
你好
Can you speak?
你好 testing testing.
This guy is fun. You should speak because you're like really he's a 50-year-old guy.
Yes, I am 50 years old.
Oh, really? I'm 1,000 years
It
old.
only works if I have to make us if I touch the screen.
My 2 Chinese friend is blocked.
No, Amoeba
I
declined
thought
my
Joe
party request.
gave one
Oh
of
my
Chris.
god.
And draw Chris pregnant.
Really?
Yeah. Is that green guy banned too? Like Space, listen, Space.
Yes,
Is he banned? Like is Cutie banned?
suspended.他们
Really?
是被 suspended 了。
He's suspended?
Anyways,
Like,
how's my
what did he
mic? Does my
do? I
mic
didn't
sound better?
hear him
Because I
say
just did it
anything.
just now.
For saying the G start word.
Why did you hear the freaking Among Us noise?
Yes, Mushashi.
Yeah, for like they got suspended because they say G.
Oh, that's GAE.
Oh,
Yeah,
very
yeah.
bad. Very bad behavior.
Very bad behavior. You did it. Space.
Tell her to invite me.
Invite the Armiva.
All right.
No, that
Chris, are you ready?
How do you
I
do it?
draw you now.
I'm back.
The girl is back. Yeah, she's back.
hey, that's you that was beautiful.
Is my mic working?
Thank you, Mushashi. Let's see.
木沙石。哦 ，The Mufasa。
不是，是宫本武藏。
Bless you.
What you say to me?
I then asked to rejoin as well. Let me join.
Girl, what's your name?
My name is Some Say Some Do.
Okay.
Where are you from, by the way? Armiva. Are you Chinese?
Kong. I'm Hong Kong.
Really? You are?
Yes.
我哋係純正嘅香港人。
No, I'm
Invite me to
Indian,
party.
Indian, like, do you not get that?
Oh yeah.
Tell your friend
Do
to.
you have
You do, right?
DC?
What is this?
DC?
你有没有兴趣加入那个中国的共产党？
Oh, yeah, the D.
Yeah.
I'm trying to not get suspended. Discord.
Yeah, I got it. Yeah. You will get banned for that.
I know.
Do you want to join
let me
the
find my
Chinese
user.
共产党?
Well, I'm not. How do I say this? I'm not Indian, but I'm not white either. Like, I am Asian.
This is my user.
What the shit?
Can someone invite me?
Senator, are you part of the Chinese
Back to
government?
party?
Oh, invite the green guy.
Oh, right. The green guy. I'm sorry.
我
What's
们
his
都是
name again?
纯正的中国
Wow, it's a
人，
cutie.
中国共产党的一员。
Shut up.
你好，你好，你好，你好。
Oh my god.
我哋係香港人。
港人。
呢個人係香港人嚟㗎，佢廣東話好差。
Why do you have an accent?
Wait, what?
He really does. Like, I thought he was. What's funny?
我係香港人。
Wait, I'll add you on D. Wait. I need to log in. Like, I forgot.
Okay.
Alright, wait for a while.
Stop stepping on my head. You bum. Am I gonna get
I
mad?
love drawing people.
I think the WoW is a cutie is drawing me do very naughty things.
For what? Why you get banned?
So annoying. Oh no.
Why you are suspended? Very sad.
Oh my god, you're so funny.
This very sad tragedy.
Yeah, it's a
This is a
tragedy.
tragedy.
Yeah.
Chris
I
is
forgot
not ready
my-
for this masterpiece I'm doing.
Wait, I need to log in. Wait. Mushashi must be bored. You're listening to us.
Oh no, I'm not bored.
Can you sing for us? Like,
Sing? Nah, I don't sing well.
you don't sing?
I don't know how to sing unless you teach me.
你是我的小人小苹果。
I don't sing. Oh, I got it. No.
No. Bad.
What?
Hey,
You can't
propaganda.
even sing the Chinese theme song?
Chinese song?
That's not allowed.
I don't know. I'm gonna get banned. Yeah, that's why I stopped singing that.
Chris, you're gonna love this masterpiece I'm drawing of you right now. I think if you see it, I think if Chris sees it, he's gonna be like really happy.
With gay.
Who was that Chris's sister? She said Chris is gay.
Wait, yeah, I always thought Chris was gay. Cause like
Chris
I
is
always hear
gay.
him talking about being feminine or
Yeah,
something
your
like
brother
that
is
when
gay.
he falls.
Oh my god! Don't say gay!
That was
Oh, thank you. Oh, wait. Wait, I'm still talking with this guy.
But who is this?
Wait,
Oh, is
I am
the
the Indian. It's the Indian girl.
the white girl? It's the white girl.
I'm not white. I'm Indian.
I don't believe your white ass.
Oh no! Wait! I'm still talking with the Mushashi. Wait. Thanks.
Cow Cow Super Dog Gaming.
Hello.
We met this other person in Neighbors. She's white. She's not actually Indian.
Neighbors?
Yeah, Neighbors on
You're not
Roblox.
What is that?
It's like it's where Robloxians e-date, but we
Chris,
don't
do you
do that.
see?
We just troll.
Yes, I see it. It's very funny, kiddo.
Chris, do you think this is a masterpiece?
We're trying to be.
I'm gonna wait. Can you try and
pretend-
find my
I
sister
mean, not
in
pretend.
Discord?
Like we're gonna act like Chinese.
Chris. Chris,
And then just talk to them in Chinese.
do you see it? Chris, do you see it? Are you proud of me? Chris, are you proud of
And
my
then
work?
this person below me was the first victim.
Wait, we're live.
Chris.
Yes, I see it. I'm sending it to my sister.
Wait, what?
Yeah.
Hi
Wait.
stream? Hi stream?
Your stream?
You didn't know?
What stream?
Color Punch.
You guys are streaming?
I'm not.
I am.
Chris is streaming.
You're streaming? You didn't
You
tell
didn't
me.
know? You didn't
No.
know?
No.
This guy streams 24/7.
Yes, I do. It's my job now.
I didn't
It's
know
his
you're
job
streaming.
now.
Chris has been Chris been streaming every day for like almost this entire day. Each day. It's so
I
fun.
have
This
to.
guy
I
has been
have to do
streaming
it for
for
the
hours.
channel.
You don't have to stream every day.
Yes, I have to, bro. It's my job now. Otherwise, we're gonna go broke. even though we are.
We are even.
We're gonna go broke on the $0 that we have.
We all got suspended.
This
It's been
is
like 5 minutes,
Fate
though,
on Sound.
right?
Yeah, I can come back.
Yeah, you guys should join. Chris, you're not name's Chris. Like you're not 50-year-old.
Oh,
He's not
very
50
very
year old.
misunderstanding. 我是那个 I
Very
very old, okay?
misunderstanding.
Old man.
You are very old.
Why are you copying my accent?
You.
Why you are copy? You make fun of me?
Okay, you can invite
I'm
me
not
now.
making fun of you.
I just love the accent, really, I do. That's why I'm saying it.
You are 50
you're
years
American.
old.
You're
I don't
American, bro.
know.
I'm not. I'm
Are
Asian,
you a
really. I am.
groomer?
We're the same. I don't know. We're the same.
What are you doing now, Chloe? I think I joined the server, by the way.
Sorry, my mom summoned me to help her clean the table.
Oh.
I made an even better version.
But I'm
He's drawing Chris pregnant.
I'm drinking liquid.
Oh, wow. Liquid. I love liquid.
Exactly.
Oh yeah, my mom and dad's gonna be gone tomorrow, so do you wanna do something or you have uni?
I do.
Here, doggy,
have
that's a
uni.
bit too much. You don't think?
Can do?
What? I can come to your uni?
No, I was thinking, what if you went to my house?
Tomorrow?
I should probably ask my parents before I say this.
Yeah.
What are you guys doing, huh? Getting
Oh,
into
what do I do
attic?
in your house?
I don't know.
No one's
Yeah.
speaking, so
Like if you want to hang around,
How to
Yes, I
enter the
want to
attic?
hang around.
I don't really know. Because I do have stuff that I
what
need
are you
to do.
doing?
This
Add
very
me!
stinky.
Invite me to your party!
I kind of do miss you being in my house.
Yes, I'm gonna collect our debt.
Yes, exactly.
Yes.
Wait, Agent's new skin looks so sick. I like that.
Sorry.
Don't sorry that. Why you sorry?
Aw.
You should tell your friends to become. I'm already an artist.
She doesn't know.
You should send her my actual Instagram, so I don't look like a fraud.
So you don't look like a fraud.
So
Big
I
strong
don't
man
look
come here to wrestle me.
How do I join your party?
Oh, you have an auto clicker. You have an auto clicker, bro.
No, I don't. No, I'm using my finger.
Wait, hold on.
How do I pronounce your name? Somer?
I was about to ask, what's your
Yeah.
name?
You can just call me some. Some say, some do. You can call me
What the hell? They're using auto clickers, bro. I am the Minecraft player. I
You're
click.
bad at
How
it,
are you
really.
guys
Just
winning?
admit it. You're bad at it. You're bad at it. I'm sorry.
Some add me, invite me.
Crash out.
Where? Oh, right. I'm sorry, girl. I'll at you.
It's okay.
In army. Oh, I don't know how to pronounce it.
Yay! I'm back.
Oh, Spaceberries, you want to lose again?
I'm gonna win. I'm a jitter clicker.
You're bad. I'm sorry, Chris. Chris,
You are the cheater. You use the auto clicker every day, every night, in your sleep, in your brush teeth.
Oh, it's annoying. Oh, don't say that. It's funny, really.
Hacker.
Hacker!
Hacker. How do you know? How
Hacker.
do you
Out of
know?
my
Hacker.
Use the big
Oh my
hacking
God.
device.
They're really funny. Oh my god.
The Bluetooth device is ready to pair.
I can't open the
Sorry.
door. What the hell?
Let's play.
Oh, there you go.
Oh!
Where are you guys?
I'll teach you. Ooh.
Chris, your
Just
sister
use
said. Your sister said I drew him. I drew you exactly the way she sees you every day.
So dope.
Chris, you might want to work on your reputation for your sister. I think your sister has a bad reputation of you, Chris. I think you might want to work on that.
Yeah, this is... I don't know what to say.
Chris is lost for words. That means my art was very beautiful.
I'm here. I'm here.
Hello. He's gonna pick Rock.
Where
Chris.
are you, Lon? Where are you guys?
You're bad.
You know, go for Rock.
He's gonna go for Rock, Chris.
I'm kind of smart.
What? What?
Like, what taught you?
Go for, you know what? Maybe Caesar.
Caesar,
Oh
sorry.
my god, this guy.
Pick
You
Rock,
go
Chris.
for the
Pick
Caesar?
Rock.
Chris, let's arm wrestle.
Chris, you're bad at this.
I'm very good.
Yes.
Every day I wake up to training.
Oh, sorry. Cutie. Oh, wait. I'll bring it.
What?
What?
What you trainer?
Train.
I train
Oh,
my
Chloe, do you wanna
brain.
join?
God damn it. Hey, get Robert's with
How to go take shower.
No, I'm good.
You haven't taken a shower, you stinky.
Wait, what?
Oh,
Ew, shower.
oh no. I got suspended again.
Wow.
You're saying shower?
Never. It's possible.
Chris, it's already.
Wrestle in bed with me, Chris.
That's impossible.
Oh my god.
Wow.
Daddy.
You were.
Oh, Daddy
were
Kill
not.
Dog.
Yeah, they ban you for saying stinky. I got banned earlier too.
What?
Yeah, they
Yeah.
do.
Why?
Chris,
do
there's no
that.
bed in this house.
Bro, that
Chris.
is like
They do.
so nothing.
I will
burger.
pound
I
you,
know.
Kill Dog.
It's so
What?
bad. Oh my god, I have to wait another 5 minutes.
What's in no bed?
PMO.
I'm from India. They're from
No,
China.
no, you are not. You are not India.
I'm
You're
Indian.
white, you're
I
white.
am from India.
You speak a sentence.
Nice to meet you.
You are also from India, then we are twinny.
I am from India. Yes,
Yeah.
my bad.
Oh, we are Hindi is. Do you know Hindi? Oh, you know Hindi, right?
Why did I get banned
Yes,
again? I'm
yes,
sad.
No.
It's my 4th time.
on the outside, but white will be inside you.
Oh my god. Yeah, I get you. Like, it does
Can
really
you play
cool.
something else?
Do you want to play something
Can you
else?
play
Oh,
something else? Yeah,
okay.
Look at
What
this
did we
Chinese
play?
guy. Wait, the Chinese guy is coming.
I don't know.
Oh my goodness.
Do you want to fight?
Fighting?
Yes, yes. Let me fight. Let's fight.
Let's fight. Let's fight.
Oh,
Fight.
King, like, look at.
Did you
Fight.
guys
Oh my god,
actually?
wait.
Yeah.
Did you
Nee,
guys
Okay,
actually
let's
think
fight a
she
bit.
was
We
Ni
can,
Indian?
hao.
wait, we can also
No, she
wait,
is
guys. We
Indian.
can also
We're just joking that she's white.
Oh, okay.
guys.
It's the other
Guys,
way,
we can
way
act.
around.
We can also play. I got an idea, guys. We can also play Bite by Night, because in Bite by Night, your voice is with the animatronic, like they change your voice when you're at the animatronic. It's funny.
Wait, is that actually a thing?
Yeah, that's true. They changed
my
the
God.
voice.
Friend, wait,
You're playing as the
can I-
animatronic in
can I
Bye Bye
say
Night.
something?
To the animatronics voice, like when you talk.
Oh, hello.
你好，
You
你
join
好
my
啊，
party.
你好，小姐，
Join
你
my
好。
party.
小姐你好。No English here, but
新版 slay.
what you say?
新
What-
版 slay.
No English.
Being chilling.
Oh yes, very good, very good.
How to say I
This
peg
is
my
insane.
husband? Please tell me.
How to what
Wait,
husband?
wait, I'm brushing my teeth.
I peg my husband.
Oh no good.
Why?
Very painful for your husband.
Oh my god.
You're
Sorry, that was
你是
my ringtone.
you're racist
That
to
was
me?
my ringtone. No, that was my ringtone.
You are
Oh,
racist.
level 40
Racist.
now. I just realized.
No, I am not.
I think you're racist because you put the ringtone to your phone
Because I
that
peg my husband.
mock my
Oh
culture.
my god. You are so homophobic. You are so homophobic.
I'm gay.
I love the gay people. No, I'm gonna get banned. No.
Oh, so you are homophobic.
How'd you get banned for that?
Okay.
I
No,
said
no
gay like 10
homophobia.
times and then they
No
banned me.
homophobia today.
So funny. How do you get banned
I
for
am not
that?
racista. Quit.
You almost make me banned. You know. You make very much trouble. What language you are speak?
What language we speak?
You are lagging to me, Miss Mayor.
Oh my god.
You're very lagging. I don't understand your English very bad. 非常不好，你知道吗？
Oh my god.
You are challenged. I know you are challenged. I think you are challenged mentally. You are now lagging very bad.
Let's fight. Wait.
Let's bite?
Chloe. Are we fighting or biting first?
I'm peeing. I'm
bite.
I'm peeing.
Oh.
What did you say?
How are you in here while you're peeing?
Miss Mayor, you are very laggy. I do not respect your English.
I do not respect your English.
You do not respect it.
You are very laggy. I think your English is worse than me, a Chinese person.
The way you speak is so funny. It's so funny.
Your English is so bad, I cannot understand. This is ridiculous.
This is so funny.
You are so lagging. It is ridiculous to me. Okay.
Oh, I got a slap hand.
You are sounding like a robot. It's absolutely racist to me. This is racist. This is how you mock my accent.
Oh my god.
You are a robot. I do not respect the robot.
I do not respect
Bankers. Bankers.
You know what you are? You are a clunker.
Wow, no, that is wow.
All you are is a clunker, and you make fun of my Chinese. That's ridiculous.
I'm gonna die.
What is,
Oh my god.
what is happening? What am I witnessing?
He's been like that for a few hours now.
What?
你好，你好，Schmark，你好。
And they're going on another fiction. Oh my god, this guy.
My brain is making the electromagnetic wave. I don't know why.
Oh my god. Guy's trying to be the Asian smart stereotype, bro.
It's make electromagnetic wave. I think this is the X-ray, the gamma radiation.
Why did that echo like that?
Oh, Schmark, I hear you now.
QQ, I think
You
you're
Schmark.
now.
Do you know I am a Chinese?
QQ.
I am a Chinese.
No, just skip that.
QQ, you're gonna get banned if you don't play.
Good number.
Hello.
Oh no, he got banned.
你好 Rin.
How's it going?
你好。
Oops.
Why you say
I was also peeing.
Chinese.
Oh, no.
Why is everyone
It's okay.
peeing right now?
Oh, ni hao.
I'll
你好
I'll come back
I
after this
speak
round.
Chinese.
Wait, you can join me. You
English
can
is
join
a
me.
little bit.
Code is 7839.
Oh, very beautiful. Very beautiful music. I listen to every day.
Oh my god.
You know, I listen to that song every day because I am Chinese.
Oh no, it's full.
Oh,
Okay,
yeah.
I'm gonna come back to you later.
Okay.
Rin, what is your hobbies?
Being
Hobby is.
Leon.
This is so entertaining.
Leon, 我
I'm
是
learning
中国人。
Chinese accent.
Leon,
Gets you.
Hello.
what is this flag? Where are you guys located?
Outside. Come on.
Damn it.
Hi.
你好 I am a Chinese. Do you know where is Chinese located?
Where
It's
did
a
this
big
guy
chicken
even
on
learn
the earth. The global map have the big chicken.
China is
It's the Chinese.
Chinese is not the
Wow.
biggest. Is it?
No, China is not the biggest.
Yeah, China's not the biggest. Chris. China's not
Shut
big.
your mouth.
Oh, here's my team. Oh.
It's like we're the second biggest, right?
No, I think it's the third. No, I don't know actually.
I remember it being the
I know you
third.
don't know.
Oh, hello, cool. I am the Chinese. Do you know?
Chinese.
No, you ain't no Chinese.
你觉得我不是 Chinese 吗？我可以说中国话的，我是纯正的中国人，你不信吗？
What? You found P?
Yeah.
What? You found P? You found P?
So confused.
No P. No
Ew,
peeing.
get away.
Why
She
you are carrying her on your shoulder?
Stinky over there.
I
Ew, it's stinky over there.
no pee.
Ew.
I very hygienic. I Chinese.
No, you're not hygienic.
I very hygienic. I put on the diaper every day.
Come on, legs, walk faster.
Diaper every day.
Walk faster.
I cut you off on the other side, okay? You come back, okay? We have civilized conversation. We have civilized conversation.
Go back to your Panda Square.
I from China, okay? Very big, advanced country.
I got a serious question. So
Okay, ask me.
You ever tried cat and dog yet?
Oh, every day, man, every day. So tasty, bro.
He guys. Basically, he like guys and girls. That's crazy.
What you say about me? You think I am the homophobia? The
You Asian?
Yeah.
Oh no!
I'm gonna get the coronavirus. I'm just kidding.
Hey, China is not known for coronavirus, okay? It's the America give the Chinese the coronavirus. They produce it in the laboratory.
I do.
Is this responsible for the coronavirus? No.
I'm Chinese.
That guy over there, though, he tried too hard.
No, he does. Like, he's from he's Chinese. Really.
对，我是中国人，纯正的中国人。
Okay, join my party.
Oh, okay.
Sometimes I look into the mirror and be amazed how Chinese I am. Stop running away from me. I know the coronavirus. I already washed my feet. Why you are running away from me? We already under the rain in the shower. 已经下雨了，你知不知道？
I'm from.
She is America.
No.
She is enemy, okay?
Oh, God, it's
enemy of
upside
China.
No, I'm not.
She say she is India, but no accent, okay? Where you go?
Oh my god, you're gonna get banned.
Oh my god.
No. I mean, I say that I am, but I'm not.
This man is boring.
It's a secret. It's a secret from him, from that guy.
Oh well, he can't hear you. No, wait, I'll fly up then.
No, no. Let's go to him. Like.
Oh. Oh wait, I just realized this is kill. Actually, how did I realize this? There's literally no capture point. This map is so easy to tell it's kill, and I didn't realize.
Yeah.
Ugh, I'm getting gangbanged.
You're banging me. I mean what?
Excuse me. Excuse me.
You're hitting me.
Whoa.
I didn't mean it that way.
Where did these guys go, bro?
They're gone.
Wait until they find out I'm not actually Chinese. They will be so shocked. Wait, I am Chinese.
You are Chinese. Oh.
Bro, where the hell did they go?
Where are you from?
Wow, this is the easiest round ever. Okay, I'm gonna stream so you guys can see.
Not bad.
Let me go.
Yellow power.
I'll take it.
Oi!
He's bored, really. Like, talk with him. He's like really bored.
Why you can fly?
Because I got it from Temu. I got it cheap from Temu.
Temu is it the Chinese company?
It's like AliExpress, right?
Chinese company, I think. So the wings belong to me, okay? I produce the wings using my labor.
You said she belongs to you. Okay.
No, the vast majority of the GDP of the world is belong to China.
Huh? She belongs to you?
No, the wings. He's talking about the wings. He's talking about the wings.
It's okay. She said she wanted you anyways. Here you go.
How you go through the window without open?
I don't know.
Because I'm Asian. I use my brain.
I hate this map.
Sure,
What is
let's give it. Maybe.
No, why are we on the opposite team again?
Very
Damn it.
sad. Go.
This is getting kind of boring.
Yeah.
I don't have that much Chinese left in me, bro.
Yo, we sat there for a minute, bro, arguing with them.
Spider-Man,
Oh my god,
Spider-Man.
leave me alone! Leave me alone,
Oh my god, it's the little dog. Little dog from the Adventurous Time.
I'm losing health.
Oh,
they skipped us.
So close. So close. So very close.
It's the same guy.
Is it?
So very close.
God, or
So big. Oh my god.
Oh, 小笼包. 小笼包. Oh my god, you are my 小笼包, okay? Oh, this is beautiful. Beautiful 小笼包. Oh, this beautiful little 小笼包. You go into my stomach. You come back here, you little 小笼包. I will eat you into my Chinese tummy, okay? Oh, very, very fat, very saturated 小笼包 go into my stomach right now.
Oh god.
Wait, you're from Hong Kong? Me too.
Hong Kong?
Who got suspended?
No,
Did you
no,
get
I'm
banned, Chris?
suspended.
Oh no, he got suspended. Like his band.
Oh man.
Oh my god, I finally found someone from Hong Kong and they get VC banned. Are you serious?
Yeah, you can like talk with him here. Harry, Chris, can you talk? Speak.
Do you hear me from the other side of the VC?
Can you hear it?
Hello? I can't hear.
Yeah, she wants to speak with you, Chris.
小笼包 啊，非常好吃啊。You are from the Hong Kong?
Where is he?
Oh my god, my keyboard.
What you say? Please say again. I cannot hear you very clearly.
Hong Kong.
What? Hong Kong? You are from Hong Kong? We are all from Hong Kong. Do you know? 雷猴雷猴.
Lei Ho.
Yo, this Koyo is so good at the game.
Do you know there is entire VC of people
Where is that
behind here? They all waiting for you. They are all from Hong Kong.
Oh my god.
Do you know you were a beautiful 小笼包? I almost want to eat you.
Shut up.
You oh, every time I look at that face, I become hungry. And that little wand you are holding, I want to put into my stomach, put into my throat.
Oh my god. Get out!
Oh.
God.
And those beautiful little wings. I think you can fly very high.
Bro.
Oh, these beautiful persons, I don't even notice. He was in the background the entire time with a very beautiful smile.
What is that?
Gaslighter.
Oh, they're Singapore.
Oh crap. Ni hao, do you from Singapore? I'm from China. We speak many similar language, you know? Do you know? Are you asleep? How
You
is your
didn't ask
health?
voice chat. You're suspended.
Oh,
No, he's using my.
The fighting tycoon. The fighting tycoon.
Yeah, the fighting tycoon.
I'm sorry.
No one can even hear
Gaslighter, do you
Chris.
hear me from the other chatting?
You can't even hear him though.
I am from Chinese. You are from Singapore. I think we are become brothers, you know?
Oh my god.
I hope you do not gaslight me once we become brother. That's very dangerous.
What? How do you play this? Tycoon.
Yeah, you play it like a tycoon.
Actually?
You are a treasure hunter, I see. What does that mean? What is that mean?
你不知道。
Oh, you speak the 你讲
How do you
中文
capture
是
the
吧
point?
You know the
You
you know
need to
the
build a bridge
Chinese
up.
because you are Singaporean. It's very good, very good. I very respect your Chinese. Are you respond to me or you are gaslighting me right now, I think.
Oh my.
Hello? 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 你好.
Hello.
He's saying thank you, like he's thanking you.
Do you hear my voice through the something some do? Do you hear me from something some do microphone?
Why did you kill me? We're having
Oh.
fun.
Oh, my bad.
Why you are so close to my face? Do you want to kiss me?
Ow.
I have very
Oh.
beautiful eyes, do you know?
我知道，可以听得到。
Why you call yourself a gaslighter? Do you gaslight many people? Whoa! Yo!
What? Who did I die
Put
to?
me down! Put me down! Oh,
Oh,
what
you
am I
died
doing
to
to you?
the
Oh my
lava
god! Put
on the top of
you-
the.
Oh
you
my
know.
god! Put me down!
Oh, just lava?
Yeah.
What kind of powers is
Oh.
this?
Yeah.
There's so many seals.
Are you not doing that?
Oh,
Oh my god, why is this?
I'm very
he's
spicy.
controlling you. He's controlling you.
How you
Yes,
are
I
doing?
am.
How are you doing this to me?
Your dance. The way you move looks good. Yeah, it looks good. Can you do it again?
Please, I have Chinese rice. Please.
I have Chinese rights.
Oh my god.
Oh, thank you for giving me back my beautiful body.
Gosh.
I know why you are called a gaslighter now. You gaslight me just now very much. No, don't do that to me again. I very traumatic.
No, do it to me. No,
I'm in
not doing
Sword's car.
No.
I got killed by a laser.
No.
Oh my god, it's Splatoon music.
I become very traumatic if you do this to me.
that. God.
Oh, Omni-Man. Father, if I live for 500 years, I still have you, okay? Do you feel very emotional about this? I think we can talk this out. You're very emotional about our relationship, but I think we can work this out one day, and you can put me down very gently without the violence.
Put you down? What? Freak you down like a dog?
God.
Oh.
What are you saying to me, Q Dog? This is so mess up. Please put me down. I have many families. I'm very loyal to my family. Oh, what you're doing to me? Oh, you put. Why you use me? You use my body again. Very bad behavior.
Oh my god.
Some say some do this not me. What you see right now is his soul control my body.
Alright, let's see you dance.
Why do you flip like that?
오빠 강령사예요.
Oh, that's Ooh.
I hate the gritty.
I can't breathe. Did you just
Ooh.
fall in the pit?
Yeah.
That's what I did in real life.
Oh, this is what you did in real life, yeah.
Please release my body to myself. I don't know why you have so much power over me. Maybe Singapore is better country than the China, but this does not give you the right to control my human rights. I have the Chinese rights, okay?
Hello.
Oh.
Chinese rights a bit much.
Maybe the Singapore have more advanced technology than the China, but this does not give you the right to.
Dodgeball.
Oh, thank you.
Yeah.
Thank you for giving me back my body. I very appreciate it. You are very tall, you know, tall and black. I very admire your. I very admire your body type. I have blue hair naturally.
Black?
He's orange. He's yellow. Oh my god, he's so big.
Why you eat the green apple?
He wants you to eat his meat.
Pick him up.
Well, I'm speaking the truth.
You're very in suspicious positions of me. Why you choke me again, okay? Father, your strength is beyond
Why did
me.
everyone leave suddenly?
Your father is beyond. Your strength is beyond my father. But okay. Why you have so much the robots, huh? You are a city boy. You have rich father. Your father give. You know us the Chinese have to walk the mountain every day to go to school. You are very privileged boy to live in Singapore. Have the father give you the money to buy these Roblox items?
Go. Wait, I'm getting banned. All right.
Wait, what?
You're gonna make me get banned. Like I got warning.
Oh,
sorry. I got a warning.
I apologize, Gaslighter. I just now say many mean words that almost get the some say some do the getting banned. But now that I apologize, why you are inside my leg? What are you doing up my butt cheek? Are you exploring my internal organ? It's very Chinese organs, right? You see the dog bones inside.
Oh god.
Kyle.
Leave me alone.
I'm not killing anyone. I
You
keep
feel
getting my kills
very warm inside.
Moving, bro.
What do you see inside my my buttock?
Well,
You're gonna get me banned.
You drink. Oh, you expanded my internal organ.
Please do not say that.
No,
I have that in my
suspended. I
head
got
now.
suspended.
While
I
playing
got
fighting.
suspended.
Do you know how distracting that is? Do you
I
know how
got
bad it is to
suspended.
have that in my head?
Your strength
while
beyond
playing
me.
fighting?
I know you're a very strong little boy, but
No. I
I
got suspended, so he's not gonna hear you.
oh. How? How are you suspended?
Because of you, like
You!
obviously.
What did I say? I just said I was a hardworking Chinese guy.
You said butthole.
Yeah,
said
you
buttocks.
did. Like, oh my god. No, like you should come from. God.
Why do they have jetpacks, bro? This game is so unfair. I'm gonna wake up fully American tomorrow. I use up all the Chinese essence inside me today. Tomorrow I will become the fully American.
Yeah.
I think that's horrifying.
He
I
keeps
think American
slamming
kids-
me into the ground. He's pounding me in my cheek.
Oh my
God.
He has so many superpower that I dislike. I think life is very unfair. Some people get the Singaporean superpower. Some people like me need to work hard like the Chinese man. We go to school every day. They go to school every day by the Singaporean bus. But we the Chinese need to go every day to farm the cows, the chicken, the wheat before go
God.
to school and have to walk the dangerous roads of the tiger and lion.
God.
Oh god. Bro, this Koyo is so good. He's my role model.
Yeah. Come here, look. There's Sonic's feet here.
What? Where?
What the
Where
hell are
are
you guys
you?
playing?
I'm here. I'm the penguin.
Oh.
Up
Let
here.
me see Sonic. Oh.
Sonic's shoe.
Oh. Sonic's feet is up here.
Yeah.
No.
Feet.
Feet, feet,
How to join back the game? I cannot find the some do some say.
No. I left.
Oh, very
She's too
tragic.
tired of your shit, bro.
Everyone is tired.
Yeah. Let's leave for now.
Okay.
Alright, good night, guys. Have a
Goodbye.
Good night.
Good night.
good night. It was fun
Chris is
hanging
gonna
out
be
with
fully
you. Sam.
American tomorrow.
Oh my
Yeah,
God.
mate.
Yeah,
Yeah,
I'll
bro.
hear you.
Ooh.
I'm gonna yeah. Good night.
Good
Good
night.
night.
Good night, bye.
666.
Yeah, you get money from this.
I should have some more fun in the chat game. Fully
You can go back
flesh
to the
out
union.
my Chinese.
You can go to the karaoke place and sing everything in like a Chinese accent.
Oh my god, we had so much fun tonight, bro. This stream was supposed to be me studying for until... Holy shit, bro. My Chinese accent is kind of lingering.
Wait, Chris, you want to play Bite by Night with the voice chat? It's really funny.
Oh, okay, let's do it.
Wait. Can you wait 3 minutes? Eva, you wanna switch games after this match?
Yeah. Maybe not. It's 1:30. My dad's gonna come out. Maybe tomorrow.
Yeah, let's do it tomorrow.
Okay.
Tomorrow you're gonna come over and see me fully American, alright?
Okay.
Oh, no.
I'll be fully
you didn't-
American.
You gotta flush out the British in you as well, Chris.
Oh yeah, mate. You yank. Tomorrow I'm gonna be fully British. Because I lack the energy to be Chinese, and that balances out. Whatever. I don't know how to explain. I don't know why I'm so good at acting like Chinese.
You are Chinese. the fuck you mean? Why you don't understand why you're so good at acting Chinese? Because you are.
But I'm not like, you know, that kind of fully pure Chinese accent. But I know how to do it for some reason.
That's just a
If you're Chinese.
stereotype thing.
Studying until I pass away.
Ah!
Fully pure. I've been streaming for 7 hours. 8 hours plus the 3 hours. So that's 8 plus 3. I've been streaming for 11 hours, guys.
Guys, should we, in the future, do a subathon?
How? Yeah, we don't have any audience.
Like, let's just continue streaming until we get audience.
Okay.
That's what we're doing.
I'm
can do a
carrying you guys,
subathon.
man. I'm the only one streaming every single day.
Yes, you are.
Bro, I should edit the video, like edit the stream into a video.
Hey, can you edit my April Fool's video for me? The live?
I don't know. I feel like it's too low quality.
Maybe. I gotta work on my stream setup. I'll make it less laggy.
There's also not much that happened in the April Fool's stream. There's 3 people watching my stream.
Like we never ever had.
Should I verify?
January. Oh. I'm watching my singing. Oh.
What are you doing?
Oh. Ooh.
No. Ooh. What the hell is happening?
January.
January.
Sing the little Manamina.
Nina ni Maria.
Oh god, my ears. Should I verify? Should I verify?
Got 88 scores.
Maybe.
If I lose you, baby, there'll be no clear sky. If I lose you, baby, just like the clouds, my eyes will do the same. If you walked away, every day it'll rain.
No,
Rain.
that was
Oh, Space Berries, we're too good at this.
Yeah, winged pigeon. I have a.
I think we should become a very good duo.
Yes, I think I love you too. Your daddy can't even look me in the eyes. Oh, if
I should play one
was
more
in their
round. If
shoes,
there's no
I'd be
elevator, then
doing
I'm
the
going.
same thing.
The same thing.
Okay.
Saying there's
Okay, if there's no
Remember
special
parts
class, then
of
I'm
detective
going.
language that may violate
Okay.
Roblox's community standards. You may lose access to chat voice.
Wait, I'm Water Girl and you're Water Boy. Whoa, we're
Oh.
siblings.
Whoa. We are siblings. Iron Cafe too.
Iron Cafe 2! Iron Cafe
It's
2!
51.
Choose! Iron Cafe 2!
Iron Cafe too.
I think according to
21. Say 21.
my calculation is 21. Do you think I correct?
Yeah, it's a
I
yeah,
think
it's a
you
yeah.
are lying. Like,
Yes,
why are
yes.
you doing-
Oh, what the hell? Whoa, it looks different. It looks bigger.
It does look
End
bigger.
stream.